Hello, everyone. Can you hear me? Oh, we've got like 3 people in the stream. There were 6 people waiting a few minutes ago. Where'd they all go? All right. Can you guys hear me? I want to make sure we've got good audio, good video. Hello, hello, hello. All right. That's Ricky. He heard us. All right. So it's day 2 of DConf Online 22. We've got a pretty good schedule lined up, I think. And I'm only talking to a couple of people right now, so I'm not going to give all the details about what's happening with the workshop because one of the people is the guy who recorded the workshop and knows all about it. So I'll wait and announce that later on. And something interesting, not interesting, but I mean, I've been waiting for something to go wrong. Something always goes wrong. Brian knows nothing. Something always goes wrong. And yesterday, I realized what it was. I forgot to pick a winner for the daily prize, the $50 Amazon e-gift card. So I did it after the stream ended. And Ricky, sorry, it wasn't you. It was Alexander who had won a swag prize earlier. So he got the $50 gift card. And we'll be giving away another one of those today, plus a $100 grand prize, $100 e-gift card at the end of the day. And I'm not going to forget this time. So, how are you, Walter? We're early for you, but that's no problem. I mean, I'm not talking about your local time. I'm talking about for the stream. But why don't you go ahead and tell us what your talk is about? Give us a summary.
Okay. When I first learned C++, I didn't know anything about inheritance or object-oriented programming or anything. I knew literally nothing about it. What I did was I picked up Bjarne's book on C++ and I read it. And there were things like member functions, and I'd look at the member function, and the member function has an implicit this reference. But I didn't know that. And I was going, how the heck is this function manipulating the contents of the struct when it doesn't have a reference to it? And then virtual functions. I was completely baffled by virtual functions. What do they mean, virtual functions? What do they mean, overriding functions? The book kind of went over it and explained it and showed examples, and I had no idea what was happening. So at the time, there was the C-front translator that Bjarne Stroustrup had written, which translated C++ into C. So I had access to that, and I just fed the program examples into C-front and looked at the C code coming out. And then I saw the hidden parameter. I saw that the virtual functions was just pointing to a table of functions and function pointers and picking a function pointer out of that and calling it. And then all of a sudden, the whole thing made sense to me, what was happening and how it worked and all that. And that's always been true for me. I've never been able to understand things from descriptions of the top level behavior. I needed to understand how it was implemented underneath in order to figure out what was happening. And I've noticed that, some members of the D community have the same thing. No matter how well it's described what the behavior is, they're not seeing how it's implemented under the hood. And this impairs understanding of how things like the function and parameter attributes work. So constantly people have trouble with how things like scope and return and ref work together with function parameters for member functions and things like that. And it's not making sense to them. And I always encourage them to rewrite it in terms of just simply pointers and values, and then how the attributes are applied will make a lot more sense. So I'd keep going, here's how you rewrite it into pointers and values to understand it. And I finally realized I just need to make a talk on the internal rewrites the compiler does to reduce all the syntax sugar in D into simple constructs like pointers and values, which people coming from a C perspective understand. So that's the point of this talk. It's just what is happening with those higher level constructs in C, and how do they work? Those higher constructs in D, and how do they work?
Yeah, that was I was aware of most of that. I was actually surprised by one of the items in there, and I'll get to that later since these guys haven't seen it yet. I'll leave them in suspense to see for themselves. Ricky suggests here now if only foo array equals constant could be a for each rewrite instead of a call into the runtime.
I guess why? What's the difference? Well, I can explain the difference on that. The difference is that the for each loop is rewritten into ifs and go-tos. And the intermediate code of the DMD compiler can only handle expressions, not control flow. So by rewriting it into a function call, then you can have it these array assignments embedded inside expressions. Whereas if you turned it into a for each loop, it wouldn't work because of the way the AST works in the DMD compiler. So that's the
Ricky's
explanation for that.
Yeah, Ricky's motivation is that because it doesn't work in better C, the array initialization like that, and
it should work in better C.
Well, if it's calling into the runtime and the runtime's not there.
Yeah, but it calls a template. See, if you call a template, you don't need to link to the D runtime library because it gets expanded into your.
Ricky says it's not a template.
It's not?
It's in RT package, runtime package.
Well, I'll have to look into that then because I thought that Razvan had changed it so it called a template.
Well, I know Theodore is working on the runtime hooks. I guess he hasn't converted that one yet. Is that the case, Ricky? Is that what you're talking about? There's a list of stuff that Teo has converted so far.
Okay, I thought all the array operations had been converted to calling templates in the runtime.
No, it's in progress. Apparently, it's a lot more work than.
Okay.
Okay, but he says there's an issue for it, and it's not on anybody's radar. All right, so the talk is getting ready to begin in a couple of minutes here. Here's the link for those of you who want to switch over to it and watch. And by the way, I've got the chat on. I've got slow mode off today. So just please don't spam us. We'll be okay. Yeah. All right, 60 seconds till the video premieres. What talk are you guys looking forward to the most today? And I know Walter's going to say all of them, but what's
mine? This time I have a different opinion.
Okay. Thank you, Adam. I did not know that. All right. Yeah, Mike Shah says he's looking forward to yours.
Yeah, Mike, you're on my Mike Shaw. You're on my favorites list now.
Actually, somebody commented on YouTube on the testing editors, the editor talk, which is after yours. Somebody commented on YouTube as soon as I posted it. Waiting. This seems to be a topic people are very interested in. Yeah, that talk is He goes through every single editor on the DWiki that's listed on the IDE and editors page. As far as I know, it's every single one of them to see what's still available, what's still working. And he actually, the Larry Hemsley, who's giving the talk, has been around the D community for quite a while, kind of a lurker in the forums, and he still has some old installations of some of the older text editors that aren't around anymore, which I thought was very interesting. So, but it's a pretty thorough look at all of the editors. And it is now, we are now on the hour. So yes, the video is playing that intro, that YouTube intro, counting down. And I don't want to start talking about your talk until it starts. So I'm kind of stalling. We got started a little early.
Okay.
How's the weather in Seattle?
I don't know. It's dark.
But have you guys had any snow or anything like that recently? Or
Yeah, it snowed yesterday. It's sort of alternating drizzle and snow.
Yeah, we had our first snow our first real snow of the season last week. It's been an unusually warm winter so far, but last week we finally got some snow, and my dogs actually love snow, so I took them out in it, and they had a good time. They'd be making snowmen if they could, I'm sure.
Yeah, when I was a kid and it snowed, we went out and played until we couldn't feel our hands and feet anymore.
Yeah, well, in Georgia, we only got snow twice a year if we were lucky, and it only stuck around for a couple days at most, and it was just a light dusting, right? But even so, schools would close. So, yeah, because nobody's used to driving in snow in Georgia, right? They don't have the snow tires, and my father had chains, but he always had a hard time putting them on.
Well, in Seattle, nobody knows how to drive in the snow, but that never stops anybody. There's always a huge number of accidents on the first snow every year.
Well, that's why they close the schools in Georgia. So, because the school buses, they don't want any school bus accidents. So I used to get up early in the morning and watch for the little announcement at the bottom of the screen on the 6 o'clock news, if my county was closed. All right, your talk has started. And now I can ask about something I've been wanting to ask about, but didn't want to say anything before the talk started. What's up with the hats? That was a cool idea. I like that. Hats? Yeah. Where did you get the idea for the hats? Where did that come from?
Oh, well, Seattle used to run a sketch comedy show, and it was in the 90s, and they were rerunning it. So I decided to record it for nostalgia reasons. And since I was watching multiple shows at one time, I noticed that the host never wore the same shirt twice. It was always a loud shirt with a dramatically different pattern. And as far as I can tell, over 50 episodes, he never wore the same shirt twice. Wow. So I was thinking, well, I should do that. I should just start, switching my shirts through the talk. And then I thought, well, I've got all these various hats. I wonder how many hats I actually have. And so basically, I never throw anything away. And I wound up with this big pile of hats and thought I could make use of them. So
that was my
next. I thought, my talk is for the less experienced deprogrammer, and for the more experienced ones, I thought I'd try not to be totally boring.
Yeah, I totally love that that you did that. That was a surprise. I was watching, and then I saw the hats change. I was like, what just happened? I just wasn't expecting it. I wasn't expecting the first hat either. But my next question was, okay, you say you wound up with a pile of hats, so that implies that you're not collecting them intentionally, or are you collecting them?
No, I'm not collecting them. It's just, the fedora was a gift they handed out to all the groomsmen in a wedding I attended. So I wound up with a fedora, even though I've never worn it. And, the helmet is for when I went on the racetrack one day and I had to have a helmet. And, my D-man hat and my 757 hat, you just kind of wind up accumulating those things over time.
Mm. No, I was curious because I know we did have a member of the D community years ago, the guy that did DSSS. You remember the package manager and build tool, Gregor, I think his name
Gregor,
was.
yeah.
Yeah, yeah,
Oh, that was a long time ago.
yeah. I know he always had hats on. I believe he was a collector, and I have a
Oh,
friend.
yeah.
Yeah, I have a friend in Iceland who collects hats, and he's always asking for them. But anyway, I just thought that might be something you did. All right, so um, now I can ask about this. I was looking at the compiler spelunking features that you listed on here,
Uh-huh.
and I think there are some, unless I'm mistaken, a couple of those command line options don't show up in the help list. Are they all in the list? Do you know?
I put in a PR to document them, and some people objected to it. So that PR went nowhere.
I
so
see.
I tried.
Yes, because these are all new to me. I wish this dash B.
Yeah.
Oh no, dash. Yeah. Okay. I'm sorry. Go ahead.
It used to be for my own debugging purposes only, and the compiler long ago was written for a 16-bit machine, so every byte I could squeeze out of the release version of the compiler was a win. So all that debugging code and all that was only there for debug builds. And I got so used to that I'd forgotten that memory became a lot more available. And eventually I realized that these debugging switches should always be available. And so I just enabled them in the release build. And then I finally thought, I need to document these because they're so darn useful. And so I tried to document them.
Well, we should probably document them on the website at least. Yeah, those are awesome. I was surprised to see those. And Ricky sent a question already, but I'm going to hold it. I'm going to hold it until the Q&A, Ricky. So I mean, I can ask it now if you want me to, but I'd rather do it during the Q&A. If you're going to email them to me anyway. Yeah. So the talk hasn't got to this part yet, but you said something in there that I didn't know, and that was, I may have heard this a long time ago and forgotten about it. It was that the while loop is rewritten to for each, or for
it's
each.
rewritten to the for loop.
For loop, yeah. And you said that was Andre's idea. He convinced you to do it. Tell me that story.
Oh, well, originally the while loop had its own semantic routines, and all the way going back to the code generator. And I'm talking to Andre, and Andre says, you know what you really ought to be doing is not defining the while loop with all this stuff, but you define it as a rewrite into a for loop. Because then no errors can creep in when you have duplicated semantics and different implementations. They wind up naturally diverging as maintenance is done on it. But if you define it in terms of a modified, or if you define it in terms that can be expressed as a for loop, all you got to do is then rewrite as a for loop, and then you can delete all that other code you had that implemented the while loop. So then you only had to worry in the compiler about getting the for loop right. Because if you got the for loop right, then everything that rewrites into a for loop is going to be right. So it simplifies the compiler, and it reduces the chance of creeping bugs getting in where the while loop actually behaves in some tricky way different from a for loop. You don't want those kind of things. Tend to happen when each construct is defined on its own. So by getting constructs defined in terms of each other is a large language simplification issue, both for the user and for the internals of the compiler.
Well, I guess this was not a new concept for you. I mean, D was already doing some lowering before in other features. Yeah. So, what was your? I mean, did you have any? Was there any philosophical? It's like library versus uh, in the library versus in the language. Was there any philosophical thing about? Were you looking at features independently as contained, self-contained blocks?
Yes, I was.
Yeah.
I was doing too much of that, and Andre just kind of. You're right. I was thinking, why didn't I think of this before?
Mm-hmm. No, I was just wondering if it was a paradigm shift for you. Yeah.
It was a paradigm shift for me. Yeah. And it sounds so stupid that I didn't think of it before, but I didn't.
Well, it seems like an interesting way to build a language. You define your fundamental building blocks and then add your features, expand your features on top of those.
Yeah, it's a great way to manage complexity. It's like over time, the code base itself develops a lot of redundancy in it. And I put in a refactoring pull request just a few days ago where there was a virtual function in the implementation. And that was part of the early implementation of the compiler. And later on, I had added a higher level construct, but I'd never gone back and replaced that virtual function call with using the higher level construct. And when I was looking at the module info implementation, I noticed that was the only use of that virtual function was in implementing the module info generation. And if I rewrote it in terms of the higher level construct I had, I could actually simplify the compiler by getting rid of a virtual function. So there's kind of an ongoing technical debt issue that accumulates, and every once in a while you want to look through and see, oh, here's two functions that do almost the same thing. Can I rewrite them so that I have only one function that performs both tasks? Or maybe I can redefine the tasks so that I can use the same function for both. And every time you can do that, you simplify the code base and you reduce the number of bugs in it, because D is large and complicated enough that when you change the way something works or add the way something works, you often will forget that you didn't catch all the places where the behavior has to be tweaked. But the more you get those behaviors to have or to share an implementation, the fewer places you have to remember to tweak for the behavior change. Yeah. So constantly on the lookout for things like that in the compiler. What functions can I eliminate by merging them into other functions that do something similar and that really should be the same routine? And in fact, the behaviors should match. And by doing that, you sometimes discover cases that you hadn't considered in one branch, but you had considered them in another branch. So by merging the routines, you eliminate a bug by treating things that should behave the same way, they then actually behave the same way.
Well, I have a follow-up on that, but Ricky asked me to go ahead and ask that question now. And Ricky, I hope you're still listening, because I'm going to go ahead and ask him the question. His question was, it starts off with Walter likes trains confirmed. What is your favorite type of steam locomotive? For me, it's Climax, a type of Shay.
Oh, I have to say, I guess I'm partial to the big boy.
The big boy, is that a specific train?
That is a specific locomotive, and it had a name and a model number, but it's the most gigantic steam locomotive ever built. And the people who are building it just nicknamed it the Big Boy.
Mm.
And the name stuck, and they kind of threw in the towel. It's like, D was originally named the Mars programming language, but everybody called it D, so I gave up and started calling it D.
Mm.
So the Big Boy, I like it because it's completely ridiculously large. And I remember reading about one of the last ones in existence. They were taking it to a museum, and it was, steaming its way on the tracks. And the locomotive was so long, it would force the tracks apart on the turns.
Mm.
So the train had to be followed by a railroad gang, putting the track back together after it after it passed. But that was built during World War II to haul coal and stuff over the mountain passes in the West. And it was kind of the pinnacle of steam technology. And of course, I like all the steam locomotives. I like the little ones that they used on the logging tracks, the narrow gauge ones. They're just kind of neat. Simple but marvelous machines. And they would around in the Northwest, they just build these temporary tracks up the sides of hills, and then run these narrow gauge locomotives up to bring the logs down, and then they'd tear up the tracks and put them down someplace else. And near where short ways away from where the house is, there's the remains of one of those roads cut across the side of a hill, and you have to know what you're looking for to see the where it had been dug into the side of the hill. But it's kind of cool seeing that stuff. And every once in a while, you'll see a gigantic tree stump from the one of the original trees in the area, which they're all gone now.
Mm. Yeah, I never got into trains. I was really into them when I was a little kid, and my uncle loved them. My uncle was a train fanatic, but he tried to get me into them, but I never did.
Well, if I was an engineer 100 years ago, I'd be working on steam locomotives, and if I was an engineer, 60 or 70 years ago, I'd be working on piston aircraft because I love piston engine airplanes. It's so cool.
It's the engineer in you.
Engineer, quite literally.
Okay, so Adam has some feedback on what you were saying earlier about looking for opportunities to combine functions. He says the problem with combining functions is then if they do legitimately diverge, you end up with one messy function instead of two clean functions.
Oh, well, that's true too. I find if I have a function that consists of too many conditionals in them, too many special cases, like you have path A through the function and path B through the function, and even a path C through the function, and there's not a whole lot of overlap. And definitely split them into three functions, cleans up the code, and makes it a lot easier to read. So yeah, that's kind of a judgment call. Or maybe split the function up into 2 or 3 functions, and the 2 or 3 functions only handle the differences, and then there's a main line which handles the common case. So of course, it's always a judgment call of when it's time to merge behavior and when it's time to split it up into multiple functions. And to me, that difference is when the function starts becoming difficult to understand because of all the if statements in it. Ideally, your function should be written with no control flow in it. Just a straight line A, then B, then C, then D, then E. And if you can rewrite your logic into simple control flow, or the simplest possible control flow, you have a much better chance of having a bug-free program. And that's why I like range programming so much. And with the universal function call syntax, you can have A.B.C.E, and that's how the control flow happens. I read a file, split it into lines, sort the lines, write the lines back out to a file, and that can be done in D. And there's an example in the runtime library somewhere of making that work, sorting the lines in a file, and there's no control flow at the top end. It's all A.B.C.E.F, and you can look at it and satisfy yourself, yes, that's a correct program. I learned long ago in the 80s that every if statement in your code is a bug. And you can say that as in the language specification too. Every clause in the language that is a if this then that, you have makes your language less than perfect. And every switch on your compiler is a bug, because your compiler should be compile my code. That's conceptually what it does. And if you've done everything right, that's the only thing you have to say is compile my code. No switches, no options, no nothing.
So maybe you should make a separate compiler for each switch combination.
Well, oftentimes when people can't agree on the behavior, the answer, somebody always suggests, well, just add a switch to the compiler to change the behavior. And I really, really try to resist adding a switch to change the behavior, because having a switch, like an on-off switch on the compiler, instantly splits the language into two languages. And if you have two switches on the compiler, then you have 4 languages. And if you have 3 switches, you have 8 languages. And you can rapidly see how this gets out of control and becomes impossible to test, because it's a combinatorial explosion. And how can you possibly even test all that stuff? And it becomes very confusing for the users, which switches or which options do I need to compile this and all that. So a good compiler design has no switches, and a good language design has no if clauses in the specification of how the language works. And of course, I've failed at both miserably. But I look at like the thousands of switches GCC has and go, well, at least we don't have thousands of switches.
Well, I have a question from Adam in the live stream, but before I get to that, there's a question from Anonymous in the email. How many hats do you have?
I think I ran out, which is why I changed hats every 2 slides instead of every slide. So it's roughly about that. A couple of the hats were just too horrible to actually attempt to wear. So now, note that I never bought these hats for the purpose of having these hats. They all had one reason or another. I'm not a collector. I'm a hoarder of stuff.
So Adam, I guess the first comment might be connected to the question, so I'll read both. He says, with the scope success lowering, follows me. Jitsi follows me. Nice. With the scope success lowering, the try flag finally lowering works, but is liable to generate suboptimal code, adding exception handling stuff where it could have been injecting a nested function call at exits. So does the lowering make it harder to implement it well, since some of that high-level intention from the original code is now lost to the code gen?
Oh no, that the lowering of scope was, Andre's idea, because Andre's original proposal on this was for C++, and he did it with macros that rewrote it into C++'s constructs. And I was looking at that because sometimes it's hard to figure out how to implement the scope, the 3 different kinds of scope. And if I worked out how to do it with the try catch finally, That's all I needed to know. All I needed to know with scope was how is it expressed as try catch finally, and then I could forget about scope. And uh, yesterday I complained about exception handling. Well, one of the reasons I complain about exception handling is in the implementation, it's a rich source of bugs. But the only thing I had to implement was try catch and try finally, because the try catch finally statement is an amalgamation of those two constructs. So all I had to get right was try catch and try finally. And if I got those right, then I know that the scope constructs work. And that worked out really well for me, because implementing try catch and try finally is there's a lot of tricky logic in the back end and in the transformation to the AST to make that work right. And the implementation has changed over time because I found better ways to implement it, but I never had to go back and revisit the scope statement because it was literally rewritten in terms of try catch and try finally. So I never had to be concerned about that. If I got the try catch right and the try finally right, then I knew that the scope was going to work right. And so that has paid off for me quite a bit in code I didn't have to write, complexity I didn't have to deal with, bugs that never appeared. So the scope rewrites were really a big win.
Okay, we are now officially in the Q&A session. And by the way, I didn't announce the Q&A winner for the daily prize yesterday. I did do that. I did the random draw after the stream ended, and it was Alexander. So I might have said that earlier to Ricky, but the stream wasn't full then. So I'm going to do another drawing at the end of the day for the daily. So if you ask a question, you'll be eligible for it, and for the grand prize. And so right now, Brian. Oh, and by the way, guys, please, if you're going to ask a question, put the capital Q, capital N, capital A, colon in front of the question. If it gets too busy, we'll go to email only. Brian, his question is, you said one of the reasons for syntactic sugar was to help reduce bugs. What, in your opinion, was the sugar that reduced the greatest number of bugs? And bonus question, why was that?
Oh, easily the scope thing. Easily. Boy, did that reduce bugs. Because, like I said, implementing exception handling is complicated. It hurts my brain. And there's a lot of work to get it right. And by not having to implement it 4 times, once for the try catch finally, and then scope success and scope exit and scope failure, not having to implement it multiple times was just a huge win for me. So getting rid of bugs, that was the biggest win.
Ali has a question. Why is scope success seemingly more complicated than putting code right after body without using any try-catch block?
Because you're you can have go-tos out of your bodies, which exit the try body, and you need to have finalies hook into that too. So that's the trouble with it, is there's more than one way to exit a code block. You can exit with a go-to or break or continue statement. So what the try catch and the try finally does, especially the try finally, is it intercepts all those exits from the block. So by implementing try finally right, then the scope success is going to automatically work correctly. And those rewrites I showed in the slides, you'll actually find them as comments in the compiler, because it's showing the rewrite of the scope statement into those, and that is literally what it does. It rewrites it into those forms, and then it forgets about it. Also, a lot of the for each loops come in multiple variations, and they all get rewritten into simple for loops. And then the simple, well, I only have to implement the for loop right. and I can forget about all the other loop constructs after that.
Steve has a question, and Ali and Steve both said it's a nice talk, by the way.
Oh, thank you.
Even though the lowering helps the compiler avoid dealing with different types of the same construct, you want errors to be on your original code. How does the compiler deal with that?
That's a good question. Yeah, it first checks for the errors before doing the rewrite. So yeah, it hasn't really been a problem. I can't remember where it was a problem where it showed the error in the rewrite rather than the original code. Usually it checks for the ones specific to the before the rewrites. Yeah, like the scope guard stuff just checks for the errors before it does the rewrite.
You said this was a paradigm shift for you, looking at things this way. Has that colored the way you look at adding new features to the language now?
Oh, absolutely. Because if I can, in creating a new feature, if I can specify it in terms of a simpler feature, then I have much less documenting I have to do of it. So you see the same thing there. So most definitely it simplifies the specification.
Okay, guys, keep those questions coming. I guess, how are you thinking of implementing pattern matching? Have you thought about that?
Yeah, that turns out to be not quite so easy to rewrite in terms of low level stuff because there's some extra semantics on, and those extra semantics also make it more difficult to write as a library module. See, when you write something as a template in a library module, you are constrained to rewriting it in terms of the other capabilities of the language. When you want semantics that step beyond that, then you're going to have to write a custom thing in the compiler for it. An example of that is the D's associative arrays. It turns out that you can implement associative arrays in the library, but to get the exact same semantics as the one in the language, it turns out that you can't make that work with the library template because, you know, the way the associative arrays are done, it's not a simple rewrite. So I know Andre wasn't happy about that. It was one of his motivations for telling me that things ought to be done in terms of simpler language constructs so that they could potentially be implemented as a library routine rather than in the core language, which I think was a really great insight. But by then, the associative arrays had already been implemented and had been in use for years, and there was no going back on that. So that was, and he really tried to implement them.
Ali is being a syntax contrarian on my requested Q&A syntax here, but that's okay. Why can't local variables be ref in D?
Okay, internally the compiler is allowed to do it, and I did that as a simplification of the language for the user. I wanted to try it to see if we don't really need a ref for a local variable, and I think it's worked out. And it enabled me to make the semantics of ref special. A ref originally did not mean a pointer, a reference cannot escape the stack frame. But since I had restricted ref to only being usable in function parameters, it turns out that I could repurpose ref to be a key component of memory safety by saying, if you pass a parameter by ref, the parameter cannot escape. if I'd allowed that on local variables and struct members and things like that, then refs, I could not have done that with ref. So by restricting what it could be used for, I enabled a new capability to be added to it without breaking any code. So that worked out pretty good. So I keep thinking someday I'm going to be forced to allow ref on local variables and struct fields, but so far I've managed to avoid it.
Steve had something going back to the AA. Whoops, what is that? Here, I'll just click it and then copy from there. He has something called the new AA that he started work on.
I'm not recalling that.
Yeah, he hasn't. I guess he hasn't announced it. It's just.
Oh, okay.
I guess now. Looks interesting.
I don't remember a discussion like that. Huh?
A template library version of the AA implementation used by the deprogramming language.
Yeah, Andre would yell at me, "We can do associative arrays in C++ and they work fine. Why can't we do them in D?" And I go, well, because the associative arrays were defined before D had templates. That's why.
Ricky has hashtag library implicitly nullable types win.
I'm not sure what.
When are we getting implicitly nullable types? What are in the library?
Isn't that what some types are? I mean, to me, one of the purposes of some types was so you could have non-nullable pointers.
Void func nullable bang int, and you call it with func3. You give it a parameter of an integer constant
that may or may not contain a valid value. Well, I think some types should work for that, shouldn't they? Because then you can create a sum type with an integer and as one field, and then a quote unquote pseudo null as the other field of the sum type, and then it's either the null value or it's an integer value, and you can make that work with null or with sum types.
So no implicit casting to nullable.
No implicit nesting?
Casting.
Yeah, that's right. Then you have to use the pattern matching to test to see if it's the null value or not the null value. That's what the pattern matching part does.
Ricky expands. He says basically implicit wrapping for constructors for function parameters. There's a lot of use cases. Do you have the live stream chat open?
Or do I have what?
The live stream. Do you have the live stream chat open?
Oh, every time I open that window, I hear the audio from both this and that.
Yeah. Okay.
And
I see. Okay. Yeah.
So I had to just disable that.
Right. That's fine. Yeah, we have more comments from Adam here. Max says, "Where's Goofy?"
Where's Goofy? It's in my background.
No, he's not. I don't see. Oh, okay. Yeah, it's clipped out. It's clipped out on Jitsi. Yeah, I see his foot right there. Yeah, there's his foot.
There we go.
Other side.
Other side.
Yeah, there he is. His foot.
Oh, yeah,
his
that's
foot's
right.
There.
On this side there. Okay, you see Goofy now?
Yeah, got his foot there. And no, Max, nobody had asked
for it. Is always there,
Mm.
He's waiting for a chance to screw things up.
Okay. Any more questions for Walter?
Just a sec here. There we go.
Oh, that's the real Goofy. Okay.
That's the real Goofy, not the
The picture.
Actually, we're just beaming Goofy in here for the picture. Yeah, go back to the chair.
Hello, Gary. Any more questions for Walter?
Now's your big chance.
Oh, Mike's going to have something in 1 second, he says. Okay, here we go. Walter, being a runner, I wonder what the best aha moment was when you went on a run in programming.
Oh, I've had so many of them. I can't think of one in particular, but I remember multiple times I had a problem that just seemed intractable to me. And when I was running, it would just suddenly occur to me what the solution was. It was like, oh my God, So for anyone who hasn't, well, when I started running, my body never wanted to run, and it was always agony to get up and do it. But through a massive application of willpower, I kept at it. And after about a year, suddenly I realized that I was looking forward to going running, and I enjoyed it, and it had become effortless. And it was then that instead of, thinking about struggling through the run to finish it, my mind would start wandering when I was running. And that's when I discovered that it was really where I did all my best thinking, had my best ideas. It's where I write my presentations. It's where I solve the difficult problems. It's really where I do all my real work is when I'm out running.
Ali, I was laughing at Ali's answer to that question. He says, I can answer, C can import C.
That might have been one when I was running, because for so many years I thought, oh, that's impossible to do that. People would ask, why don't you just compile C? And I'll go, oh, that's too much work. It's impossible. Well, not impossible, just completely impractical. And one day, I don't remember when it was, I suddenly realized that I actually didn't have to implement a C compiler to make this work. All I had to implement was the C parser. Because the D semantic routines are close enough that I can just, hijack them to do the semantic work on the C stuff. And that's not always. As Adam pointed out, some of the semantic routines have alternate paths through them for the C versions of the same construct. But once it gets past the semantic routines into the back end, it's all identical. It's all the same code. And I knew how to write a C parser, so it didn't take very long to write it. And there we had it.
Well, I have a question back to the running. When you're thinking those deep thoughts, solving those hard problems, does it ever distract you? I mean, not distract you, but blank you out from what you're doing? I mean,
oh yeah,
yeah. Where you're running along, suddenly you're meters ahead from where you were.
Oh yeah, I've suddenly realized I was a half mile further down the road.
Yeah, right. Yeah.
Which I found that if I try running through a trail in the woods, that doesn't work. Because the trail is uneven enough that I can't get into the zone. I'm always watching for rocks and roots and, the abrupt changes in altitude on that. It has to be on a level road with nothing I have to dodge. And of course, no cars.
Yeah, I was about to say the same thing, because I don't run, but I walk. I walk a lot. And I often think when I walk. And when I'm in the city, I can lose myself in thoughts. But when I'm hiking on a mountain, I can't do that because I can, break a leg or something if I'm not careful. So.
Yeah, I've never been able to get into the zone while driving, and I don't recommend anyone try because you can't zone out when you're driving. But one of the things that concerns me is, one day I'm not going to be able to run anymore, and then what's going to happen to my programming? So I'm a little concerned about that.
Get yourself.
I actually cut back my running because I was worried I was wearing out the joints in my knees and hips and things like that. And because, like football players, their bodies are ruined by the time they retire and they live in pain the rest of their lives. And so, I'm not running marathons or anything like that. I kind of tried to figure out what is the most cost-effective distance I can run. Okay, where I get the health benefits, I get the thinking benefits, but I'm not getting too much of the wearing out your body problems. And so I figured it was about 2.5, 3 miles was the right distance for that.
Well, I have not run since I left the Army in 1994. So.
Oh. Well, if you do run, just remember it'll take a year before you start enjoying it. That's a long time.
Ali has another question. Is @Live still not working because you reduced running?
No, it's not working because well, actually it does work. It just works on a subset of the language. But the reason I haven't been working on it is because, well, import C, and then there's this long list of other issues people want me to address. So yeah, I find that a little frustrating because I think @Live is going to solve the last leg of our memory security issues. We've got pretty much everything else under control. It's just the ownership borrowing needs to be done, and then we've got it. We can proudly say D is a memory safe language without needing to use the garbage collector.
Ricky is pushing DLLs again. You're saying @Live is important. He's pushing the DLLs as his number one bugbear, I think.
I know, and I was actually working on them. I think we discussed that briefly yesterday.
Yeah. Was there any hope of syntactic? This is from Ali. Was there any hope of syntactic sugar for @Live, or perhaps @Live could be syntactic sugar for future features?
I tried. One of my goals of implementing @Live was it does not add new semantics. It actually subtracts semantics. So it takes your existing code. It does not modify the way it behaves. It just puts a restriction on that code. And so @Live does not introduce any new semantics. What it does is removes semantics. Like it removes the ability to create 2 copies of a mutable pointer. And if you think about it, all of the @safe scope and return annotations do the same thing. They don't add anything. They all remove something. So I think that is an interesting approach. I don't think anybody else does that, but I'm actually kind of pleased with it. It only subtracts things. So it will not change the behavior of a working program. Your program may not compile with it until you change it, but it will never change the behavior of a program that does work with it. Like you could take a program that works under @Live and remove @Live, and it will work exactly the same way. It just adds a layer of checking on top.
Okay, everyone, it's coming up on time to call it here, so we can have a 20-minute break or so. I'll give you time for one more question if anybody's got one. And while we're waiting to see if there's another question, Walter, you want to give us some parting thoughts?
Parting thoughts. Oh. I keep thinking of Robert's parting thought, which is D is the greatest language ever.
That's just going to become the default for everybody now. You know, say
Well,
anything
for
before you
everybody,
go.
yeah.
D's the best language.
Yeah, I mean, I wanted to create the language I wanted to write programs in, and D is the language I want to write programs in. It was a big success. Um, as far as that goes, it's exactly what I want to write code in.
Okay, so we do have one more question, and Ricky's asking. We're not selling
Uh-oh.
D figurines, Ali. You'll have to talk to Steve about that. Ricky asks, "Are you coming to BeerConf today?"
Is that today?
Yeah, well, it's going on all weekend. Yeah, it's been going on all weekend since Friday night,
Okay.
my time. Yeah.
I might drop in. I'm actually pretty tired because this is my second day with no sleep because of the time zone problems with this. So
Yeah, don't talk to me about time zones, Walter. So
that's the problem with these international events is the time zones.
absolutely.
You can never pick times that work for everybody.
All right, I am about to pick the winner of the prize, and it is Brian. Congratulations! That's your second win this weekend. So,
Yay, Brian!
So when I email you, I will email you for two things. All right. Yes, you're welcome. Okay, everybody, let's go ahead and take a break. Hopefully, we'll have Larry, Brian 2, Ricky 0. We'll have Larry here at about 10 after for his talk on testing text editors. And we'll see you then. Walter, thanks for coming in this morning. And we'll talk to you later. Yeah.
Bye.
Bye-bye. Okay, and we are back, and I've got Larry here with me. He was nice and early, so uh, I hope you guys are
Yeah,
having. Oh, I'm
I
sorry.
don't see it on the live stream.
Yeah, there's a lag.
Oh,
There's
there's
a
a
delay.
lag.
Yeah,
Okay.
so you'll see it in a minute.
Okay.
Right now, I'm looking at you looking at the screen a couple minutes ago. Yeah, so that's
Yeah, the desktop's over here, but it's got a really big screen, so I can see better because I could read the chat better on
Hmm.
my big screen. Laptops have such a small screen, I can't read anything.
Yeah, that's I keep my my Kindle the Kindle app on my tablet large text. I need to get my
Yeah.
eyes checked.
Yeah.
All right, everybody, welcome back from the break. I saw a few of you guys in Beer Conf. I want to remind everybody that at the end of the day today, after the last talk, Brian's talk, we're going to run his workshop in the live stream because what it is, it's 15 separate videos, and you can watch them anytime you want. They're aimed at teaching how to write an 8080 assembler, and you don't need to be too experienced with D to pick them up. So if you want to work through them at your own pace anytime, you can. But I'm going to be running them in the live stream in sequence after the conference, and Brian is going to be around to answer the questions. So if you're here at the end of the day and you want to take take the chance to ask Brian questions while you're watching those videos before you start practicing it or whatever, that would be a good thing to do. So I just want to remind you of that, and I will announce that again probably a couple more times throughout the day so I can make sure everybody knows about it. But right now, we have Larry Hemsley here with us, and he's presenting his research on the text editors and IDE plugins. And so before the talk starts, why don't you tell everybody a little bit about yourself? I know you do that in the video, but this is for the benefit of the Q&A video later. So go ahead and tell us a little bit about yourself and a summary of the video, the talk.
First of all, I'm really looking forward to Brian's talk, and I really liked Adam's live stream yesterday, so I like that kind of stuff. This is basically just me trying out all the different editors because I really like trying new things like new operating systems, new compilers, new text editors. And I got the idea because people asked on the forum, which I've read daily for a long time, what text editor they wanted to use. And so what text editor could they use? And they got multiple different answers. And so I've been trying out different text editors. I didn't really realize there was so many of them. And I didn't realize that you could do D with Emacs at all. So, but it was an experience for me because it was a nice experience because like I said, I like trying out new things. And so I was just trying to get them all configured correctly, and which was really hard sometimes. And sometimes they didn't work. And, and I started with some of the new old editors that Mike mentioned in his presentation earlier in the regular conference, the not online one, and which I enjoyed a lot because I just like those kind of things. So.
Well,
I don't know what else to say about it. It's sort of boring, actually. So
it's really informative, though. I learned a lot from that video that I wasn't aware of. So.
And the other thing is I realize that most people that are watching this have already picked their favorite editor and are not interested in any new editors. But that's not the point. The point is to try them out and see how they are, if they're working correctly for doing what they're supposed to do with decode.
All right, your talk has just started for me. The countdown has just finished, so it's running.
Am I supposed to watch the chat on that?
Yeah, on the talk.
Because there's nobody on the chat on that.
Yeah, not right now. So I'll keep an eye on it. I'll keep an eye on it. And
All
if anybody asks anything, I'll let you know, and you can type an answer into that.
Okay.
Okay. So yeah, what you did when you started this project, you went through all of the text editors and IDEs on the DWiki. Yeah, that was your source, and some of those you already had copies of on your local drives or whatever. Now, how long have you been in the D community? It's several years now.
I've been trying to remember when I first started, because what happened was when I retired the first time, is when I actually got interested in computers and programming. And then I just divorced my first wife, or she divorced me actually. And so I wasn't planning to get married. And so I got married in 2002 to my current wife. And so it was sometime after that. So I do remember the very first conference in Seattle, and the one after that in Oregon, and the one on Amazon. I've watched all of them I could. So I've also read all the books. So and like I said, I've been working on the forums every day. I read the forums. That's one of the things I do when I check my email, is read the forums.
Well, you were you have a degree in biology, and you worked as a clinical lab technician for a long time. Did you always have the programming bug, or did it come to you later?
No, that's a really long question. I mean, that's a really long answer to that question. Actually, I didn't. Just the opposite. My dad was a mainframe programmer, systems analyst. When the machines were really big.
Yeah, before my time.
And
but yeah,
I didn't like them. I didn't like the noise they made, and I didn't. When I went to work with him, I didn't like them at all. So I was anti-machine. Unfortunately, when I first started in the lab, everything was manual, and I loved it. And then they automated everything. And so then I got interested in fixing machines. And then when I semi-retired, I found out I had a knack for fixing computers. And so I was fixing computers for friends and relatives and things. And then someone said, why don't you get certified? Why don't you get A+ certified? So I took a class in that, and then I got Microsoft certified, network certified. Then I decided I was going to take programming classes for some reason. And I signed up for a C programming class, which was not the easiest language to learn when you start. So
it's not, no.
But I found it really interesting, and I'm interested. So I'm interested now. So
yeah, I had the bug very young, but I wasn't able to act on it because my parents knew I wanted to learn to program because I wanted to make games, and they didn't want to invest all that money in a PC back in the early 80s to just so I could make video games. They thought it was a waste of time. But
I can relate to that.
Yeah, so I did learn as a hobby though, but I didn't take a course, but I struggled through it by myself, but I eventually got it, and I find it in some ways fulfilling. It's probably the best hobby I've ever had. I've stuck with it longer than any other hobby, longer than guitar, longer than everything else. Would you feel the same way? I mean, were you was it among the top activities of your life? And what do you find? What draws you to it?
It is now, but it wasn't at the time. But in the mid '80s, I broke down. I have two sons, and when they were younger, I bought them a Commodore 64, and it was basically so they could play games on it. But I found out that it had a basic interpreter with it, and so I wrote programs. I wrote basic programs. I actually wrote one. The first program I ever wrote was one that took 500 samples from normal people and calculated the normal distribution, for normal ranges for chemistry tests because I was a lab technician.
Right.
And and I bought all the Commodore books too, so I'm great for buying books. And but I really didn't get the programming bug. I mean, I really didn't get it really bad. I mean, I really didn't get it really as bad, as it is now.
Mm-hmm.
Then, because I was still working in the lab and I was still interested. I'm basically a scientist. I'm not a programming math person.
Right.
My older brother, who's 18 months older than me, is a math person.
Mm.
And everything he likes, I don't like, and everything I like, he doesn't like. So that's how we grew up. So he liked computers. He was a systems analyst. My older sister married a software engineer. So what can I say? I really wasn't interested in computers until way later.
Yeah, you weren't interested until you were.
Yeah, and that now the only other hobby I have is fishing. So I go fishing.
Yeah, that's one I never stuck with. So, a lot of fishermen in my family, but I am not one of them. Yeah.
My brother doesn't like to go fishing, and I like it. So, like I said, everything. We were only 18 months apart, and it was really strange because we were like opposite people.
Mm-hmm.
It's just been really strange.
So how long did it take you to go through all of these IDEs? I mean, had you gone through some of them already, or did you do them all for this talk, or what?
I've well, I configured the TextPad editor that I used when I was taking a C class. I configured that for D really early on.
Mm-hmm.
And the Zeus editor I configured really early on, and I've looked at some editors. I've looked at like Visual Studio and Visual D, and I've looked at Visual Studio Code with Code D, and I really liked Dext and the Delang IDE.
Mm-hmm.
And I looked at the Poseidon D, which I was really surprised to find out that it was still being actively developed.
Yeah, that was the one that
actually
that jumped
a really
out.
Nice editor, although the new version doesn't work real good. So
yeah, that one.
The newest version, like I said in my talk, doesn't really work really well. But the old version works really good. And the guy that develops that I think he's Chinese. He lives in Taiwan, and he actually wrote a tree setter parser for the auto completion on that, and the auto completion really works good on that editor. So,
well, I know somebody in the Discord who probably wasn't aware of that, who just did his own tree sitter grammar.
Actually, it's on his website. I mean, he's on GitHub. So I find it interesting that he took it over because there was no current free basic IDE because it wasn't being developed. It's kind of a weird story, actually. But I was glad to see that he still did the D version too. And it is actually written in D, and it uses the IUP library. So,
IUP is the one that
he wrote his own parser. So,
yeah, IUP is the one that's developed at TechRio, the TechRio. Yeah, so yeah,
it's the same one that the
Lua guys, yeah,
Lang IDE uses.
Do you remember an editor called Crimson Editor?
I'm sorry, what was that?
Crimson Editor. Have you ever heard of that?
No, I have never heard of that one.
Okay, yeah, because I mean, it's not on the wiki because it's defunct. It's been defunct for years. But when I got into the D community, that was the editor everybody was using on Windows, and I gave it a go, and I loved it. It was it was kind of like what Sublime Text and VS Code later became. It was
Yeah.
primitive compared to those, but it was a one man project, and that just became my favorite editor. Even after he stopped maintaining it, I kept using it for a while, and somebody else forked it and created something called Emerald Editor, I think it was called, but it just didn't. It just wasn't the same. But what do you look for in a text editor for your daily work, or do you prefer an IDE? What are the
Well,
features that?
that's kind of a big question because I really don't do much debugging, and so a debugger isn't that important to me.
Mm-hmm.
And actually, I find when I was taking Visual Basic and using Visual Studio, I was amazed about the code completion, but really code completion just gets in my way now. So basically, when I learned to program, I programmed with a text editor and the command line, and I used Borland's command line C compiler and a text editor, basically,
Mm-hmm.
And so I really like the text editors that have a good terminal on them, an internal terminal that comes up. Like Decode has a really nice one, and the Linux program Kate has a really nice one too. And I was just looking at the IntelliJet IDE last night, and they have a really good terminal too. So that's really all I need is a editor to edit with and a terminal.
You just hit the points that I look for too. It's I don't debug so much with a debugger. I debug with WriteLine or printf or whatever when I only go into the debugger when I need to, and I'm happy to do that from the terminal.
I debugged with printf for a long time.
Yeah. And I got to have that terminal at the bottom of the window, So that's why I switched from Sublime Text. I've kept a license of Sublime Text since version 3, and I still use it occasionally for quick one-off things, but I'm pretty much full time on VS Code for just about everything I do now.
VS Code, yeah. VS Code has a good terminal in it.
Yeah, and
the first one that I ever used was on Windows was the Decode one. Chris Miller wrote.
Mm-hmm.
It was a really nice editor for me. I mean, it's that syntax highlighting and a terminal. What more do you need?
Yeah, right. Chris Miller was a really prolific contributor to the D ecosystem.
Yeah, his website, is still active.
Yes, it is. I saw that when I was researching the talk.
Although you have to convince your browser to go to it because it doesn't have a security thing or something.
Yeah, right.
Stupid thing. It's ridiculous.
Yeah, I nabbed a screenshot. I guess you nabbed a screenshot from the same place there of Entice from his.
No, actually, that screenshot from Entice was actually the Entice that I have on my computer. I still have it on my computer.
Okay.
I also have Decode still on my computer, my Windows computer. I just don't code on Windows very often. So.
Is Linux your main platform or Mac?
I switched to Linux. I don't know. It's been a while. It's been a long time. I've been on Linux for a long time, but I do most of my tinkering around with code on Linux now. But I still have those. When I first bought a computer, it was a 386 with 1 megabyte of RAM. I downloaded a lot of shareware and just tried out different shareware.
Mm-hmm.
I just like different software. I was trying to find different software that I liked.
Mm-hmm. Mm-hmm.
And so all of that stuff, when I find something I like, I just leave it. And if I don't use it anymore, I archive it. I archive it on a flash drive now. So I used to archive it on a CD-ROM, CD-ROM.
I have kept a lot of stuff in the physical world, but I, for some reason, have been really slack about keeping things in the digital world.
Well, I really like open source because of that too, because I try a lot of stuff out.
Mm-hmm. Yeah.
But yeah, I still have them around, and I'm sure you were around when the Tango and Phobos. I don't want to call them a war. It's a war,
it was
but
a split.
it was a controversy for sure. about which one people really liked. And that was the first time I ever posted on a forum. Was someone wanted to know if they could use both, and I posted that you could use Junction on Windows, and basically it's a link to whatever folder you want it to be a link to.
Mm-hmm.
And so you can link it to either Phobos or Tango and use whichever library you wanted.
Mm-hmm. Mm-hmm.
That was the very first post I ever posted, and that was the second one. Was actually a critique on the early manual for Tango, and the Tango people didn't really like my critique of it. So, but a year later, I bought their book. So, you know,
I was one of the co-authors on the book.
I still have, like I said, when I proposed this topic, is that I still have the D1 that I downloaded like in I think it was 2008 or 2000. I got remarried in 2002, so somewhere between 2002 and 2008 is when I started looking at D.
Mm-hmm.
And actually, what I was doing is I got tired of Borland C compiler, so I was looking for other compilers online when I ran into the Digital Mars website, and I actually paid the $15 for their CD for the Digital Mars C compiler.
Mm-hmm. Mm-hmm.
And what I really liked about it was on the CD it came with an editor.
Yeah.
You know.
Yeah, custom built editor.
Yeah, custom built editor. It was nice.
Mm-hmm. Well, I'm kind of picky about my. Well, I don't want to say I'm picky, but I'm not the kind of person to try many different things. I just when I find something and I like it, I don't want to move on. I'm there.
Well, yeah,
you know what I mean?
Yeah.
So I don't go look for something better. And so I tend to stick with whatever editor, grabs my fancy, and then until I have a reason to not stick with it anymore. And it's that same reason, I guess, that I stuck with D, because it scratched all my itches, I mean, so I was.
That's why I still use it.
Yeah,
it's a lot better than C.
Mm-hmm. Mm-hmm.
I mean, I like it a lot better. And I took a C++ class too, and boy, that was just horrendous. I did. I don't even want to talk about it. I liked C. I took C because my brother told me that C was the closest thing to assembly as you get in a programming language. And I took several assembly languages classes too, like for the Motorola and for the Atmel processor. It's because the junior college I was going to, they had a deal with a microprocessor thing going on, so they had different ones.
Okay, you've got some comments in the video chat here.
I'm gonna have to read something.
Okay, I can read them to you. You have Marcello Mancini says.
No, I have it up here.
Okay.
Enjoying your talk here. If using Dub, IntelliJet doesn't care about the compiler. Yeah, I know that. I just found that out last night, actually. Am I supposed to type in there?
If you want to answer, yeah, you can say something to them.
Yeah, I just found that out yesterday because I wrote in my talk that the IntelliJet didn't, and so I was looking at their issues that they posted, on their GitHub page.
Mm-hmm.
And I found out that you could use other compilers.
Mm-hmm.
So I'm just saying, yes, I found that out yesterday. I don't type real fast.
Oh, that's fine.
Ooh, helps if I spell correctly too.
Okay, I have a question for you about, given all of this testing you did and this data you've compiled on all the different editors, what's your opinion of the current state of the editors in the D ecosystem overall? The state, what state are we in?
I think we're in a really poor state. If you really
Okay.
want to know the honest to God truth.
Mm-hmm.
I think there's gee, how do I say this nicely?
Don't be nice. Be honest.
I think there's something wrong with the idea of making a D plugin for an editor that wasn't developed for D. And I was just looking, like I said to at an IntelliJet yesterday. I mean, last night. After the conference, because I wanted to check something out.
Mm-hmm.
What I wanted to check out was about the DMD thing, but I found out that you could actually use LDC as long as you're using Dub, which is nice. But the plugin is written in Java, because IntelliJet is a Java editor.
Right.
And the Mono D plugin was written in C#.
Mm-hmm.
And the Visual D is probably written in C# too. I really don't know because I haven't looked into it.
Well, it has a significant component written in D. So
does it?
Yeah.
And the Dex editor is written in Pascal, and I'm pretty sure that's because he's familiar with Pascal, and Pascal has a really good graphics library, which D does not have a really good graphics library.
Mm-hmm.
That's just written in D for D. So I think that.
So that's important to you then. Is it that the
well, I think it's important for getting it more mainstream into people that are writing applications for like Windows or Linux.
Mm-hmm.
They're going to need a graphics. You're going to need a graphics library and then an editor that like a form editor like Chris Miller. He wrote a really good one, but it was just for the DFL. Well, actually, it was for DeWitt too. I mean, DWT, the D widget library, or
the D widget toolkit. Yeah, the SWT port.
Yeah, that's what it's called. The D widget toolkit. You could use either one.
I didn't know that. I didn't know Entice Designer worked with DWT. That's news to me.
Well, the later one did. The early one was just for the D form language.
Yeah.
So
Well,
I think something like this is important. That's why people use C#, because Visual Studio is the IDE for Windows programming.
Yeah, I see. So your thing here is not that D should have an IDE written in D, but it's just that an IDE written in D means we have the foundation for other types of GUI libraries for people to write. I see that. But in terms of editors, I mean, the trend has been polyglot. I mean, that's just the way it's been going.
I understand that. Yeah. And with the interop with C and C++ now, I mean, I can see the reason why.
Yeah.
But the really big thing that I found was that a lot of the plugins are developed until they're done developing, and then they're not maintained anymore, and the editor moves on, and the plugin is no longer really working really well. That's what happened with Mono D.
Mm-hmm.
Mono development. I happen to know this because I talked to Alexander. Not talked to him, but I emailed him about why his plugin wasn't working with the new 6th version of Mono development, and he basically said that they changed the API drastically, and they basically lost him. And I've also noticed that the newer Mono development doesn't have C and C++ either, because they lost that group too.
Mm-hmm.
because they changed the API drastically.
We have a couple of comments in the live stream here. Steve
Yeah.
Schweighofer says that Vim is the best editor. And
Yes, well, you know what? I've never really liked Vim, but with playing with Vim with this project, I really finally understand Vim. I finally got used to it.
Hmm.
Because I didn't start out on Linux. I started out on Windows. So
I've tried, but I just I can't.
no,
And
it's actually Emacs still bothers me, but
well,
I'm getting too old to remember all those control and meta keys.
I've gotten enough Vim down that I can SSH into a server and do what I need to do with Vim. But we have another comment here from Adam to remind us that D has a cute GUI library that the live stream shut off yesterday. And yes, we all know about Simple Display, Adam. Yes.
Yeah, I really think that if Adam really put his mind to that and got it really going, because he mentioned in his talk yesterday that he develops until he gets it to where he is happy with it.
Mm-hmm.
I think he did a really good job, but it needs to be better.
Well, I said earlier that Chris Miller was a prolific contributor to the D ecosystem, and I don't think anybody has been more prolific than Adam over the years. I
remember his first D conference talk, where he got up there with no slides and tried to explain really well, bare metal programming in D.
Well, I have to interrupt here. It is officially Q&A time now. We are in the Q&A session. The talk has ended for me anyway.
Yeah, it has.
So if you have a question for Larry about his talk or anything semi-relevant, then please go ahead and either email me at the Q&A@dlang.org, QN as in November, A at dlang.org, or type it in the chat with the Q&A : prepending the question so I can make sure to see it. So any questions for Larry, go ahead and shoot.
That's actually what I was thinking last night before I went to sleep, was about graphic libraries for D.
Mm-hmm.
And I was thinking about the mini GUI and what's it called? D GUI and DLang IU and all those ones that they've worked on, that has been worked on.
Mm-hmm.
I'm not too familiar with the D GUI, but I'm planning to take a look at it.
Adam also says now that Vim doesn't require anything to work well with D. By the way, it just works out of the box. Of course, Steve says
I couldn't get syntax highlighting out of the box.
Well, Steve says it depends on what you want.
When that NeoVim shot with the tag tree and everything on it, I would take the tag tree and the other thing off and just leave the terminal personally. And I kind of like the relational numbering, line numbers, because in Vim that's kind of important, because you can jump around in the lines, and to know how many lines back you want to go or forward you want to go.
So I'm curious, to those of you in the live stream right now in the chat, what's your go-to IDE or editor for D? What are you using the most?
You know what? I use if it's a larger project, I just use Jenny. It has the debugger works sufficiently for me, and it comes out of the box with D, and you don't have to do any configuration other than minor stuff.
Steve,
but when I'm just dinking around on maybe one or two files, I use Sublime Text. I still use Sublime Text, but I keep an external terminal open so I can compile.
Brian Callahan says he uses Vim, and I have firsthand experience watching him use Vim now that I've seen his workshop videos, which you'll all see later. Steve
I noticed that Adam was using Vim last night.
Yeah. Steve has a question for you. Do you prefer console editors or GUI ones?
Oh, I prefer GUI ones, you know. Like I said, I started out on Windows. I programmed on I learned all my, I went to all my classes on with a Windows computer. So, you know, I just recently even found out that the Vim even existed.
Uh,
I changed the Linux. I changed the Linux about 5 or 6 years ago,
hmm.
and I really like Linux a lot better. But I've tried three or four different Linux versions now.
Hmm.
My desktop has Arch Linux on it, and my laptop has Zorin on it. Actually,
You know, I'm trying to.
so
I'm trying to remember. I think my first when I first started programming, the first language I learned was Java. It was Java 1.1. I believe it was
yeah,
late '97, and that was I was using, I think, Notepad for that until later I started using Eclipse. But my first C and C++ environment was Visual Studio. Uh, I was able to
yeah.
get my hands on a copy of Visual Studio 6.0,
If
and
you're a student, it's really easy.
yeah, and it was
6.0 was the one I started on too. Actually,
that
was
was
Visual
that was
Studio.
good. That was before they changed it so much. But
Yeah, before they
yeah,
got really fancy with it. I don't know. No, I usually just use Jenny or Sublime Text. It depends on the project, really.
hmm. Adam said,
Jenny is my default code editor. If I double click on any D code, it comes up in Jenny. You know.
we have Adam says he used to use gedit when he was new to Linux, and about the same time he was new to D. He said it was the closest thing he found to what he was used to at the time, which was Windows Notepad.
Yeah.
And
You know why I like TextPad? My first Java class, I used TextPad because it was on Windows and it comes configured for Java actually to compile and run Java programs.
hmm,
But why I bought a license for it was because you can start it as administrator and make it your default text editor in Windows so that Notepad does not open when you double click on a text page, a text file.
hmm.
Because don't like Notepad at all.
I don't anymore.
Yeah.
I didn't know the difference back
That
then.
editor just
Yeah.
drives me nuts.
Um,
G edit is actually my favorite editor if I'm just looking at text files, and it's a really nice editor for programming on too because it comes now it comes with a lot of syntax highlighting, and it has a terminal, and it's really pretty nice actually.
well, Sublime is my default text. I mean, I don't have it configured as my default text editor, but if I'm going to open it up for quick editing, that's what I use. And in fact, I'm
Well,
using
that's
it
what
right
I
now.
use for quick editing too.
Yeah, I'm using it right now for the names, the question names,
Yeah.
the prize lists. We have a lot of stuff here about gedit. Okay, guys,
Oh
you're giving
yeah,
me
it's changed a lot.
yeah.
Adam says here it seems to have changed a lot since I used it back in the 2005.
It
It
looks
looks
weird now.
weird now because they changed the menu. Uh, if Adam wanted to have the old menu back, he should just use Xed, which is how the old G editor used to look.
Mm-hmm.
I have both on my computer.
Mm.
So,
I know I've seen them. I'm just not familiar with them. Okay, guys, right now Steve is the only one who's actually asked a question for the prize, so he's going to win by default. I'm sorry, not Steve. Brian asked one. That's right. No, it was Steve. Yes, Steve. He's the only one. He's going to win by default unless I get some more questions here. So let's get some questions for Larry.
And then, so when I'm just looking at text files, though, I just use Xed actually. I just double click on, and Xed comes up with the text files. Like I said, I like using different software. So, and I like trying out different operating systems. So, I'm pretty good about changing things up. You know.
Hmm.
I mean, my brother gets frustrated if he has to use any editor besides the brief editor or whatever editor he's using. Personally, I prefer being flexible.
Well, I spend a lot of time if I'm going to sit down for like 2, 3, 4 hours of programming or writing. I don't even use writing software for writing anymore. I have a license for Scrivener, but I don't use it
Oh yeah.
anymore. I just write. I use Markdown for just about everything I do now, and I do that in VS Code. If I'm going to sit down for 2 or 3 or 4 hours of typing any kind of text, I'm in VS Code. I use it for Markdown. I use it for D. I would be using it for C or even Java today if I were, doing those. And I can't say I use it for D much anymore. I don't do so much programming now because I'm too busy. But it is my go-to editor for spending time. And I am thankful to Jan for his for their work on
Yeah, his
uh,
his
their
code D,
yeah
his serve D and code D is really nice. Does a good job.
yeah
I'm
they
glad to see that he's expanding to other text editors too.
mm,
Although
yeah
he admits that the text adapt is not quite ready yet, or the Sublime text is not quite ready yet. And like I said in my talk, I've used DKit for years, so
okay
I
no
haven't
more
tried that out.
yeah
I'll probably try it out someday though.
Yeah, DKit. I'm trying. I didn't use DKit. There was another plugin I used for Sublime, and I can't remember what it was. Uh,
There's been a couple of them, but I did notice that the last time I tried to update DKit, it didn't update.
hmm.
So I'm pretty sure he isn't maintaining that anymore. But it works good. So I'll probably try out Code D and Sublime Text in a little while someday.
Hmm.
I got it on my list of things to do.
More questions, guys. Oh, go ahead, Larry.
I
Sorry.
have used so many different Office softwares too that like I've used the Windows one and the Linux one and the SoftMaker one, but I prefer just typing everything in a text editor and then putting it up and formatting it
Yeah,
in
absolutely. I still
the
have Office
Word
installed
document.
because I need Microsoft Word for. I do a lot of editing of papers that people send me. I have
Oh yeah,
connections with this university where I used to teach a couple people private lessons when they were in programs there, and they gave my name to all their classmates. And so now for 10 years, at certain times of the year, I get strangers contacting me, asking me if I can edit their thesis or their dissertation or whatever, and so I need Word for that. So it's worth keeping the subscription for that. But that's the
I
only thing
worked
I
I
use it
worked on
for.
it. I worked on a master's degree in biology, and I had my little sister type out the it wasn't my thesis. It was a preliminary study of the literature that on the project I was working on, and she did a really good job, but I wouldn't have done that good of a job.
So for future viewers of this Q&A session here, Adam wants everybody to know that if you use the mini GUI and you have something to say about it, please let him know, because he finds, quote, "it needs work," end quote, kind of useless. But if you have some details, like it sometimes uses if checked and sometimes if is checked, that's something he can fix. So if
Yeah,
anybody has problems with mini GUI, please be
he
detailed.
mentioned that last night about if you have any problems, and I'm
Hmm.
planning to. I haven't really checked it out, but I'm planning to check it out that in the DGUI library and see how it works. I've looked at the DLang UI extensively because I was interested in the IDE.
Hmm.
I really did like that the DLang IDE, but he hasn't done any work on it since
Well,
2017 or so.
DLang UI has a new maintainer now.
Oh, does it?
Yeah. and I
Well,
don't.
the UI does,
Yeah.
but does the IDE have a new maintainer?
Oh,
Because
I assume. I guess Adam would know. Does Grim. Is Grim going to do? Has Grim said he's going to do any work with the D-Lang IDE, or is it just the UI he's maintaining? If anybody knows, Ricky or Adam. Yes, Grim is working on the IDE too. Cool. So.
well, that's good to know.
Yeah,
Actually,
and
because
if
I really like that editor as an IDE, as a D language IDE. I really liked it.
well, you can he doesn't hang out in the forums too much, but you can find him in the community Discord server. He's there a lot. Yeah.
You know, I have Discord on my computer and I never even open it. So
Yeah. Well,
I don't know.
it took me a while to get into it, but I fairly frequently check in there now. So, but
Well, I might do that, but like I say, I've been reading the forums for a long time, but I don't really post very often. You know, I was really thankful for their help on the Zeus editor, though, getting the debugger working. It's only partially working, but it works. It works better than it did when I first started.
I didn't realize Zeus was still going with D support, because I know that was like one of the big options back in the early D1 days.
Yeah, I actually have a license for it that I've kept active.
Mm-hmm.
I have a persistent license for it actually, and I actually bought it because I was anti-Microsoft at the time. I'm
Mm-hmm.
still sort of anti-Microsoft, but I didn't really want to use anything like Word or anything that was made by Microsoft, so I bought it. And that was at the same time that I was using Visual Studio and taking Visual Basic in three semesters of Visual Basic. So, you know, but I wanted a C and C++ editor. It's a really nice C and C++ editor. It's a really nice IDE actually. It's just out of date for D quite a bit.
Yeah, that's kind of a problem for some of those. It's like even Code Blocks, I think, doesn't always keep up with D.
Code Blocks comes out of the box working with D, but like I said, I downloaded the brand new version. They just brought out a new version in it, and the configuration didn't work for D.
Mm. Yeah,
which I find really frustrating.
I used that for a while for C when I was trying to recapture the old Visual Studio 6 days.
Yeah.
All right, guys.
It is reminiscent of Visual Studio 6, isn't it? I've had Code Blocks on my computer ever since it came out, but ever since I started using Linux, but I don't use it very often.
Gary in the chat says he's a noob, so he uses Visual Studio Code. So
yeah,
that is a noob-friendly thing. Absolutely.
Yeah, Visual Studio Code is really nice. There is one thing I don't like about it, and that's because it's built on a browser basically with JavaScript.
Mm.
I don't particularly care for that, but that's just me.
Yeah. Well, I
like things like Jitty that are made,
Well, VS Code, I remember when it first came out.
Made, in a browser. They're made.
Well, when VS Code first came out, that was one of my problems with it, and it wasn't very performant compared to Sublime. But eventually, they closed the gap.
Eventually, it's gotten really good. Yes, yeah. I have to agree with you there. I have it on my computer. I was really sad to actually to hear that Atom went out. They archived Atom.
Oh yeah.
Which was the Linux version of. I mean, it was basically the same thing as VS Code, but it was written by the GNU guys or whatever. I don't know how to say that. GNU. How do you say that?
GNU.
GNU. Yeah, the GNU guys.
Mm.
And it didn't have any Microsoft stuff on it, so I liked it a lot better. But
yeah, every time I hear that word.
They say they archived it so they could work on their new GitHub coding thing, their code base, or I don't know what that's called.
Yeah, I have a sister who's 5 years younger than me, and when she was about 9 or 10, and I was a teenager, there was a kids show on TV with these puppets, and one of the characters was called Gary Gnu, and yeah, he was a Gnu, and his tagline when he came on the news, he was a newscaster, and when he came on his little segment. It says no GNU is no GNU is good GNU with Gary GNU. Drove me crazy, and I still think of that all these years later. Every time I hear somebody say GNU. All right, everybody, we're gonna call it here. We haven't gotten any more questions. So, Larry, it's been a pleasure talking to you. It's really nice to meet you, and I would like you to please go ahead and give us some closing thoughts before we call it.
Well, I think I've already mentioned the closing thoughts, and I think that needs a graphics library, and they need an editor that's, for D.
Well, that works. Yeah.
What else can I say?
We could borrow Robert's closing line now that he uses every time.
D rocks. Yeah.
Well,
I agree with that. I agree with Robert.
We can do that. All right, Larry. Take care, and I hope we get to do this again sometime.
Yeah. Maybe someday.
Yeah.
It was a lot of work though, so I don't know.
I know that. Yeah. All right. Take care, man. Bye-bye.
Okay.
And everybody, we got to pick a winner, which is Steve. So Steve was the only person to get a question for the prize. So Steve, if you want to keep your prize, you've got another one yesterday, I believe. So that's 2 now for you. So we can do that, or you can pass it on to Ricky to maybe break his curse. So let me know what you want to do, and I'll contact you later. So everybody else, be back here at 25 past the hour. And yes, he's donating it to Ricky. All right. So I will contact you, Ricky, to tell you, to let you know what to do. And it was a rigged drawing. Now you made me forget what I was going to say. Oh yeah, Mike Shaw's talk is next. So we will have him here at 25 past. So everybody have a nice break. See you when we get back. All right. We're coming up on half past the hour, and Mike Shaw's talk. I expect he'll be here in a couple minutes. I forgot to send him the link to the Jitsi and the details to get in. So I just sent it a couple minutes ago. We should see him shortly. I have the worst memory. I keep forgetting things all the time. Mike's talk is a follow-up on the DConf London talk. I assume some of you have seen that. Hi, Mike. How you doing?
Good. How are you doing, Mike?
All right. Just forgetful. So
You're balancing a lot of things at once here.
yeah, and I'm getting old too. So why don't you tell everybody? I was just saying that your talk is a follow-up on the London talk. So why don't you go ahead and take it from there for me?
Yeah. So for folks who don't know, I'm primarily a teaching faculty. So I teach for a living. And one of the things I love teaching and talking about and have worked in is graphics. So this talk, in a way, almost wrote itself because the D community, after my last presentation, gave me a bunch of hints and tips. And I think even at the BeerConf, kind of a lot of folks refactored my ray tracer, and I wanted to share some of those refactorings and just talk about why D is an awesome language and allows you that low level access and to optimize code, and doing it with a ray tracer is really, really fun, I think.
Mm-hmm. Yeah. I had that the Peter Shirley books. I bought them because I haven't done any graphics programming in so long, and I was thinking, man, I'd like to get back into this again. And so I got the books, and they're still sitting on my Kindle. So haven't done anything with them. I do that all the time. I just don't have the time for it, but I really want to get back into it again. So what brought you to D in the first place?
Yeah, so I had probably looked at D since, even in the mid 2000s, I kind of saw people doing DirectX work in it when I was first starting a program. But it really was about 2016. And this is kind of shown as an Easter egg, or maybe this is a spoiler in the previous talk. But Ali gifted me, his book on D programming. And then it just kind of sat around, and I kept looking at it. And as I was learning other languages and have been sort of involved in the C++ community, and I kept looking at D and said, wow, this is just so much easier to do half the things in this, D programming language. And I'm getting, much more benefits. So, really over the last year, I've been ramping up on D and have enjoyed it, and be happy to talk about later, but you're going to be teaching courses in D now at university because I think it's just fantastic for that.
Yeah, we've had a few people do it. Yeah, okay, yeah. He's talking to you. Ali's talking to you. He says, hi, Mike. We're really happy to have you in the community. Yeah, he's not happy to have me around. I know that. But
got both the mics here. We're
yes.
lucky to have you, Mike.
We're going to get confused talking to each other. There's too many mics in the world. There really are. Even in Korea, it's funny. I was walking down the street one day, and there were these young guys, this young guy with a couple young girls, college kids behind me. And the guy was making a joke. He sees the foreign guy, and he looks over. He's like, hi, Michael. And it was just a joke he was making with the girls. And I was like, do I know you? And he's like, no. It was a joke. It was a joke. Because Michael's such a common name. Even in Korea, everybody knows it.
I don't know if I told folks the story, but I played on a youth soccer team many years ago, and we had 5 of our 11 players were Mike. So, last names was our
that's
name.
it. That's the way it's got to be. I'm Parker to so many people. Yeah, even though I'm not in the military anymore. Yeah. So, did you have a background in programming as a kid or in high school or anything before you got into the educational field?
Yeah, so I actually got my start. I was playing games for a while, and then probably when I was 12 or 13, I said, "Hey, I'm kind of tired of playing games, but want to start making them." So I picked up a programming language. Dark Basic was actually the earliest language, which was game programming language in BASIC. Just kind of self-taught from there, from user forums, whatever tutorials I could find. what I found out is, as I was, learning to program, the best way to, really understand what was going on was to teach others. So I started contributing a lot to the forums and eventually their newsletter.
Hmm.
So if folks look hard enough, they'll find, articles under my handle. And eventually I got comfortable enough using my name at one point. But yeah, that was really it. Didn't have any, programming courses and so on until university.
I see.
Um,
Yeah.
but games and graphics programming was always the hook.
Yeah, I think by the time Dark Basic came along, I was, knee deep in C and Java, and
Mhm.
I never really looked into it. But I remember thinking it looked cool, and I wish we'd had it when I was a kid. So that's how I feel about Scratch today. Actually,
Mhm.
yeah, that's pretty amazing. Um, so does this is your family technical, or are you the go-to technical guy?
Dad is very much.
Uh-huh.
So he's an electrical engineer by degree. That's what he got his associates, and then eventually his bachelor's. So he's very much a tinkerer. So he always
Mm.
had electronics. Even to this day, he's still got the museum in the basement of all the old, equipment. So, me and my brother are very fortunate in that way to have the electronics. We had a computer in our room,
Mm.
which again for a long time was gaming, and not a lot of kids had that. So we were able to explore and teach ourselves programming, and that was great.
Your talk has begun, so we'll keep an eye on the chat there, and if anybody has questions, we'll let you know. Yeah, my my father was never very technical, um, and I remember, when I was in Korea, it was the late '90s, and I was trying to teach him how to use email over the
Mhm.
phone when he had a modem connection.
Mhm.
So he'd hang up and connect to the internet, and then call me back a few minutes later. It didn't work. I was, but he finally got the hang of it. Yeah, but I'm the only one in my family with any technical chops. Um, I like what you did here with this video. How you took the existing ray tracer and showed all these features that helped you find performance. Now, have you been interacting with people, um, students or viewers of your YouTube channel, answering questions about D, or coaching people about D? Any of that?
A little bit. So certainly on YouTube, I've started a video series, which is really kind of a from scratch, assuming very little programming knowledge, um, to take folks from start to as deep as it can go. It's going to be a long running series of probably hundreds of tutorials, hopefully,
Hmm.
after years time. So there's certainly been interaction there.
Hmm.
I've been lightly involved or watching the Discord, I suppose, as far as the D community.
Hmm.
But really, this next upcoming semester, I'm going to start teaching software engineering in the D programming language.
Right.
Um,
No, I was asking that because I mean the things that you point out here are pretty common gotchas for people coming to do, especially if they have a C++ background, especially the bit about classes and
Yeah, well, I should say, when I gave the first presentation in London,
Mhm.
the D community, I forget who mentioned in this talk, but they said, they're going to be brutally honest, but extremely helpful and nice about it.
Mhm.
So some folks pulled me aside or gave me questions and said, "Hey, did you know about these things?" I said, "Oh, I never think about those things because I'm such in the C or C++ mind, where there isn't that distinction between, say, classes and structs is the
Right.
common example." And I hadn't done too much C sharp or other languages where these things are true. So, um, I think for this talk, it was important just to, kind of show those gotchas because I think they're going to get a lot of new folks. But, it's a great part of the language. I like that there is a difference between
Mhm.
classes and structs.
Yeah, I mean, these are the things that you'd be talking to people about when they're starting D. So I wonder what were the well, aside from these things that you point out here, but in your own uh, experiments and ramping up process when you first started picking up the language, what were the things that got you?
Yeah, that's a good question. I mean, I certainly had to be careful with things like allocations, but I found that was relatively easy to avoid. I think that's the thing. folks ding the D language for, but performance wise, as folks are going to see in the talk, that's actually quite easy to catch, which was one
Mhm.
thing. So that's certainly something that I've been delighted by. I think there's other things, I had to get used to coming from a C++ or C mindset of anything goes. Things like casting, default initialization, all these sort of things that are, um, sort of the defaults and in my opinion, the right defaults. I had to sort of get used to. So those were a few things that immediately come to mind that again just had to shift mindset a little bit.
Mhm.
And you have to think a little bit too about some other things. D allows you to make decisions about parameter passing and these types of things, I guess, which might be new to folks as well.
Mhm. Yeah, I think the D1 days, D was so simple, so basic compared to what it is now, and it was just there wasn't a whole lot to trip you up. And but today we've got quite a bit more that can get in your way. Have you looked at applying attributes to any of your code in the ray tracer or anywhere else?
Yeah, not in this particular talk. It's something I am certainly
Well,
thinking about.
not in the talk, but I just mean, yeah, in
Yeah.
general. Yeah.
Yeah, in general, I mean, we're seeing this certainly with the Rust community or programming languages at large, right? Having at safe be a default. So that's certainly something I should probably start doing as a best practice. I think I've noted that or seen that maybe in the spec that at safe is a good guideline. Um, or no GC or these types of things, especially in the domain of graphics. So these are things I'm certainly going to want to be teaching students, those types of attributes.
I'm looking at the profiling slide right now. You use this profiler, and I believe you mentioned that there's a GUI to read the profiling log file. Was that you that mentioned that in your talk?
Let's see. I can't remember if that was in my talk. That might have been in Max Houghton's, who I mentioned.
The
Let's
trace
see.
log, no, profile viewer.
Oh
That's
yeah,
it.
yeah, the
Yeah,
profile viewer.
yeah.
Oh yeah.
Because I had never heard of that, or if I had heard of it, I'd forgotten all about it. I always looked at those profile logs. But what is this? Where did you pick that up at?
Yeah, I think this is. I mean, this I just found by sneaking. I mean, as I was sort of researching and doing the talk. I think I just found this on the wiki page. Someone had documented because I kind of wanted to see what's the state of the built-in tools with the deprogramming language versus, I could have written this talk and just used perf or Intel V code or these other sort of GUI based, or I guess perf maybe not as much, but there certainly are other GUI visualizations and things you can generate. But so I was quite surprised and pleasantly surprised to see the tools built into D for profiling.
Well, to my knowledge, there's not a lot of information out there on how to use the profiler output. So did you struggle with that at all, or?
Yeah, I did have to, and I think we're looking at the slide, and I'm kind of talking through the profile, um,
Yeah.
and I did have to kind of, what I'm showing here. It's a little bit subtle, but it's line 614 because you get a huge sort of dump of all the other profile information about the functions that are called and sort of the tree, but it's really the part at the bottom that you probably want that's going to tell you what the hot function is, how many times that function's called. So maybe that could be updated or tweaked, I suppose,
Yeah.
in the output.
Yeah. Well, we need some information out there. I remember probably in all the years I've been around D, probably the only time I've ever looked into the profile switch in detail was when I was writing the Learning D book, because I needed to write about it there. And I was on a tight deadline, and I just didn't have the time I needed to dig into it. And I was just pulling my hair out over this for a little bit. I made the best of it I could, but you did find it very useful. Absolutely. What was the most surprising to you about the performance gains you got? What part of it was?
Yeah, I mean, just to think that I think at one of the first slides I show, I'd rendered a HD image 1920 by 1080 or so
Hmm.
in the naive way, 20 or 30 minutes or something like that on, a laptop or whatever. But to get it down to, a little bit of a spoiler alert for the talk to, 30 seconds and to know that there's still a lot of room for optimization there.
Hmm.
I mean, this was just in my mind, the example of, showing how software's, uh, a very iterative process, especially when it comes to performance stuff. And again, I didn't do anything too crazy here,
Hmm.
or what folks also taught me to do in the D community, but just kind of paying attention to class first struct. Actually, one thing that was surprising, but shouldn't be, was just the difference it can make to just put dot parallel at the end of a for each loop, and just that just worked. So
And
no synchronization, no worries. It
and
just
that's
worked.
another corner of the ecosystem that hasn't really been well explained. And I think Ali did a lot of explorations with the standard concurrency, standard parallelism in his work, and he's talked about it a little bit. I think maybe wrote about it or gave a talk about it. But there's you're digging into corners that are kind of dark. That and this is kind of bringing a little bit of light to them. We have a question here from Ricky. He emailed it to me outside of the Q&A time, but that's okay. Would you love to have an at local no GC, a new attribute? So at no GC prevents surprise allocations, but allow to call GC functions.
Ooh, interesting. That's a great question. And this probably gets into, like, I think Java, again, I haven't done Java in a while, but it has a way you can actually call the garbage collector. What is it? System.gc or something.
Mm-hmm.
So if that's, I think that could be particularly useful here, especially if you're thinking about, spawning threads or something that allocates, and you want to have control over where there is a cleanup or a collection. That could certainly be useful in this case. I guess in the case of this ray tracer, I'm not particularly allocating a lot, and it's very much a data parallel program.
Mm.
But I don't see the harm in adding that. I guess I need to think a little bit more about that. Certainly having more control over when garbage collections occur and what the sort of scope or the range is, I think would be very interesting.
Mm. I've got another question from someone else in the email, but before I forget this, one thing that surprised me about your performance gains was the standard.random. Because, okay, I mean, the concept of not initializing on every run, I understand that, but I just didn't realize that there's so much going on under the hood there that it would be a performance problem. Did you look into what the root of the problem was?
No, and after seeing Walter's talking, well, I guess I looked into it as far as the specification and talking about which is going on in the talk. What random's doing, and this idea of, and it sort of makes sense. Okay, if I'm going to generate a series, some array or something of random numbers, that's likely what these number generators are doing.
Mm-hmm.
Right. So there is certainly that work and maybe an allocation taking place, and however much data you have to loop through. But I would like to, after watching Walter's talk, either dive into that with a debugger, or maybe output the assembly or something, and see if I can see what's exactly going on.
Just
there.
look at the source. I mean, I'm going to look into Phobos.
Source, yeah.
I keep telling myself I want to look at it, because when I was editing your video, I said, when this is all done, I'm going to go look into this, because I would have imagined that it's just teeing up the first number and not doing any more work after that until you start stepping through the range. So I'm really surprised by that. But yeah, it's every time I turn around, I'm learning something new or surprising about D that I didn't know after so many years. That's amazing to me too. So we have an anonymous question here. Which of the profilers did you find easiest to use and most useful? We have a postscript. This assumes that more than one profile is going to be shown. It sounded like more than just the built-in one was or is used.
Yeah, for this talk, I'm only using dash f profile or dash profile. perf is useful. Perf I have used. I don't show it in this talk. And the advantage that perf is giving you, the built-in, or not built-in, but the tool on Linux, it can do sudo apt-get install perf. It'll tell you other information like cache hits, misses, branch predictions. And it's generally pretty fast because it's using the hardware counters on your actual hardware. So that's my sort of go-to, or, if I was going to tell someone to learn one, to use that tool. So that's probably pretty useful. Although, as I'm saying this and watching the talk, the dash profile equals GC, just knowing where the allocations are happening, that's super, super useful. So, thank you to, whoever implemented that feature in the compiler.
Okay. I'm curious about this. Is it just the way that circumstances turned out that your two talks for DConf are related to ray tracers, or do you just have an affinity for ray tracers in graphics? Is that the area of graphics programming that most attracts you?
So I'm actually research-wise, and as far as students who I work with, I'm actually sort of becoming a geometry person. I've had kind of a weird computer science path. So my graduate work and PhD was sort of in concurrency and program analysis, so these things like static and dynamic analysis, which were super interesting. But I always had a passion for graphics. I kind of transitioned after I graduated to doing more real-time graphics stuff, OpenGL, with computational geometry. It happens that this particular talk, I started teaching a new course on ray tracing. And I said, I'm going to do it in D because, it's going to help me learn the language better. And I think it's just the right tool for the job. That's what it sort of came down to. And, the reality is I could probably keep doing talks on ray tracing because I keep finding something new, but I think the community might get sick of that too. So I don't think so.
No, I don't think so. I think it's an interesting topic, but I always think that in some ways I'm kind of lucky that I was already out of my graphics programming mania by the time that Minecraft came along, because I could see that would have, if I'd had the time that I had when I was doing all that stuff, that would have consumed me, because that just really, something about that really called to me, appealed to me. I want to make that, and a lot of people did that. Ray tracers felt too mathematical for me. I used to play around with POV ray back in the day, and I had a book on ray tracing, and it never appealed to me. But that Minecraft style graphics really appealed to me. Did you ever do any voxel blocks like that? And I know those are not true voxels, but that's what they got the name. But did you ever work with that? Those kinds of engines?
I've done a little bit, and it was more related to, the same stuff they're doing in Minecraft is what the sort of medical visualization community does a lot for, these sort of CT scans. So from that perspective, but even with, Minecraft or ray tracers, Minecraft's a really nice style of game that you can probably get anyone to sort of build, I guess, in a weekend, or get a prototype. I shouldn't say a weekend because it's a little bit more complex, but so that's, Minecraft is pretty cool, right? You don't have to generate super cool graphics. It's just blocks, right? That are textured, which makes it sort of a nice project. But circling back to ray tracers, what sort of drew me into this is really the Peter Shirley books. Hey, build this in a weekend. It's not that scary. The math has always been sort of a barrier, and it's taken me, years to get to this point where I feel comfortable with, whatever the linear algebra and so on. But I would truly encourage folks to try the Peter Shirley books, and you don't have to get it right the first time. Just follow along the steps in whatever language you like, preferably D. I'd recommend. But I think that's kind of it's a manageable project, and it's not, it's that right line of, it's not something super trivial, but it's interesting enough that you can complete it in a reasonable amount of time. And that's what made it a nice talk, I think, for, DConf London and the follow up here.
Yeah, I think, my thing about the voxel stuff was that you can build anything with it, you know. And again, if you're going to make a normal 3D game, you've got to have the 3D models. If you're going to do ray tracing, you've got to have either the models or some kind of way to describe them. And but just with the blocks, you can just go crazy, build castles and bridges, and I just love it. But we're talking about ray tracing. I'm sorry. I get going on graphics, and I just
No, I love this
that
stuff.
young guy
Yeah.
comes up out of me again. But I just saw your slide on the classes versus structs, and you talked about this earlier. You think it's a good distinction, but having solved that problem there in your that performance issue there in your ray tracer, you know, that's a lesson that everybody has to learn in D eventually. And then you have to, I don't know if you saw yesterday, I can't remember who I was talking to now when we talked about this. I like to ask people, it might've been Dennis. I like to ask people their philosophy on class versus structs in D. And for me, it's always structs first, unless I absolutely need inheritance. So have you begun to develop a philosophy on that yet?
Yeah, and I saw that talk, and that's pretty much the same thing, right? Start simple. If you need to add some complexity, you can kind of refactor from there. So structs are preferred, and that's the way I'm gonna teach it. But what a nice way to teach it, because then you can start with the simple stuff with structs, and I know you even taught me some of the nice things about structs. About not having the constructors that you get for free if you don't have
the
a
initializers.
The initializers. Yep.
Yeah.
So that's
the struct literals. I'm sorry.
Struct literals. Yep.
We have comments from Ricky in the video chat. That op binary wasn't fully resolved. You don't want to be comparing the string operation with an if statement. You can do it via static if or a template parameter specialization and overload them, which will make it a bit cheaper.
Yeah, I think, and even in my abstract, when I was looking this there, I said I'd use static if and show that off, and that would be the exact one spot I had in mind. So good catch, Ricky. Yeah. So Ricky's up for the prize here.
Not yet. It's not Q&A time.
Okay. Ask it again, Ricky. Yeah. Frame your answer as a question. Yeah.
Yeah, we've got certain constraints on Ricky right now. So, so what has been the most how do I want to phrase this? I don't know if I want to say interesting, but in Korean they have this word that can mean interesting, as in interesting, like, oh, this is an interesting book, and it can also mean like fun, like at an amusement park. And it's just one word, and it's just this one concept. And I guess if I could say that in English somehow, but I guess I can combine interesting and or fun. What's the most interesting and or fun part of this experience of this ray tracer with D so far?
Yeah, I mean, that's a great question. I think how fast you get feedback is certainly something appealing. Right. So if you do the Shirley book or follow along with these slides, the very first thing you do is generate some colors and show them to a screen in a really simple image format. And if you want with D, right, you can use the RDMD, and that kind of hides all the nasty, compiling and linking stuff that might be a barrier of entry for beginners. So I really just love that you can get feedback along the way very quickly and very visually. When learning something, I think that's very useful to beginners or even advanced folks, right? You want to be able to visualize and see what's my code doing. And that's something you can do with graphics.
Well, here's a question for you. You talk about the feedback cycle. What is your pain threshold for compile times?
It's pretty high. I would say.
So you're no Attila. You're no Attila.
Yeah.
Attila's like 2 seconds is too long.
Yeah. Which I strive for, but as we're seeing in the slides, seconds and so on. But I mean, that was a great part of this talk. Getting it lower is certainly better. And I guess that threshold, we're going to see it towards the end where I get to the point where I'm loading, the scenes from JSON. So yeah, mine's high, but and I tell my students, when I was at PlayStation for a brief time for an internship, a build of a game was like 2 hours or so. So, you go get your lunch and whatever, So it's maybe not that high anymore, but higher than Attila's, I guess.
Yeah, well, nobody's going to be making jokes about D that they're going to go get their coffee while they're compiling. Yeah, so that's
Right.
for sure. But Steve has a comment here in the live stream. He says, "I found structs are easier to explain to students. As soon as you have classes, you need to deal with polymorphism and memory allocations." And he says that he's been teaching 10-year-olds. I think they're 10 or 11, something like that. D. So that's.
Yeah, 100%. I mean, even for university students, right? What and I'm someone who likes to explain things from scratch. So, structs are great. Let's get folks rolling. And then, when you talk about memory allocations, then you start have to talk about, what's actually going on and context switching and these things. 'Cause I want folks to understand at a deep level and not hide anything. Slowly, that's a slow process and has to be done sort of carefully, but yeah, 100%. It opens up a can of worms that may or may not be needed. Right, all these features.
And the kids Steve's teaching are all 12 years old now, at least. So it's been a while since he's been teaching. That's something I'm curious about. The universities I've been at in Korea, I haven't seen their computer science programs too well. I've been limited in my interactions just in my classes, but in your classes, your students, I would imagine that in 2022, the majority of them have a pretty solid foundation in programming of some kind before they get to your class. Is that a true assumption?
That's usually true. Yeah, they've been doing a lot of Java, object-oriented design, these types of things.
Self-taught mostly?
I would say it's a mix. Some are. We never expect them to. We try to make it a level playing field for everybody, which is always a challenge itself too, which is great. I wish everybody could learn programming in high school or sooner, right? But yeah, usually by the time they get to me, especially if it's a graphics course, they've done it at least 2 years of programming, I would say.
Oh, so you don't teach any freshmen?
Not as much. I have, and I do like doing that. But yeah, usually I get them when they're a little older. So mine are 20 plus, I guess, years of age.
Well, because I know way back in the day, I mean, you couldn't depend that your computer science students would have had any major experience with programming, but today it's just everywhere. What about in your school days? In high school, did you have programming classes?
No, unfortunately. I mean, we had web development, which, is always kind of a mixed bag as far as, what you actually learn. We were typing in HTML and Notepad, which got the job fun, but no.
That's where I started.
Yeah, and that's a place to start. But nothing as far as, what a loop is or an if statement or, any of those sort of basics.
Yeah. So, what about on the graphics side? I mean, graphics programming is probably, I would guess, the biggest hobby for hobby programmers. I mean, if you're a hobbyist programmer, it's probably graphics. Of course, these days, people are going off into AI and other stuff as a hobby. But do you find a lot of your students have a solid knowledge in graphics before they get to you, or are they complete noobs?
That's a good question. And I try to survey this. So I think there's a good mix of folks who play around with, 3D applications, talking about geometry and textures. These are familiar terms. As far as graphics programming, I think, I get some students who maybe play around with some game engines, Unity 3D, Unreal Engine sometimes. So that, or even Pygame or these types of things with Python, I think is pretty common. I rarely see folks as much these days who come in knowing OpenGL or trying to teach themselves a low-level graphics API. I'd say that's less common.
What about I'm looking at the slide for Dub right now. Dub is kind of I mean, I love Dub. I think it's great, but I mean, my use case is very simple. And there are people who have more complex use cases who have trouble with it and who aren't happy with its current state. And I'm curious, has your experience overall has been pretty positive, but I mean, have you encountered any pain points with Dub at all in getting up to speed with it?
Probably not so much. I haven't built any, projects of significant size.
Mhm.
I mean, the fact that Dub does exist and is part of the infrastructure is going to be super important going forward
Mhm.
for the D community and the growth of the language. So I don't have any super pain points, meaning I haven't, deployed any commercial software where, it's very useful to have, your release builds, debug builds, your profile builds. I know these are all, things that can be built in. And I still am someone who does like to just build things from the command line because I just want to know how everything works as well. But I mean, overall, I can say about Dub is I'm happy we have it. I'm happy it's because that's a big pain point in other, C++ or other languages not to have that.
We got some more comments in the video chat, and it's about your use of, I guess, the release flag, which disables bounce checking, right? So Steve says, I recommend leaving bounce checking on. Note that release turns them off for non-safe code. So using release, you should also do -bounce check equals on. It may be worth the memory safety checks.
Yeah, that's probably true. I mean, in general, safety by default is probably a good thing.
Mm-hmm.
Or I shouldn't say it's probably, in most cases, we would like safety because it's easier to remove safety, I would say, than to add it back in later.
Mm-hmm.
So it's nice that D has some of these compiler switches to make that sort of easy. But yeah, I agree. We probably should leave things on to make code safe.
My graphics programming knowledge came from books, came from internet communities, and in internet communities, you have a mixed bag of skill and expertise. And the one thing I picked up there that was really, really harmful to me in the long run was this insane focus on performance. And, I mean, just doing things that I didn't need to do because, I need the performance. Did you ever fall into that in your graphics programming travels?
Yeah, I fall in and out to that sometimes because I mean, I'll give you the example in like C or C++, right? They say, if you're writing a game, you should never free memory.
Yeah.
You know, it's one of those things. I understand the sentiment. If the sentiment is about, hey, one, big allocation at a load screen,
Mhm.
and then don't do dynamic memory allocation. I understand that as being the sort of and that probably is a good thing. But I think it's often taken, when you read a forum or something, like why free memory, and I think that can be kind of harmful. I mean, I think
Mhm.
if that's the thing that's stopping you from getting a game running at 60 frames per second, you should maybe fix elsewhere. There's probably
Mhm.
optimization to be had elsewhere.
Mhm. Okay, the talk's wrapping up. Yeah, I get a comment from Gary. He says, "Great talk." Um, yeah, I mean, it took me a long time. Have you ever looked at the Andre Lamothe books from
Oh
back in
yeah.
the? Yeah,
Yep. I have a few on my shelf. Yep.
yes, I've got a bunch of them, and it took me a
Really
long,
big.
yeah, it took me a long time to get to stop myself from doing the bit shiftings instead of multiplications and divisions. I mean, that's how crazy I was on that stuff. Just every little thing. All right, the talk is done. We are now officially in Q&A mode. So, if anybody has any questions for Mike about his talk, about his job as a professor, about his graphics programming experience, anything related to that, please shoot. Just
Yeah.
don't shoot
Let me
us.
know. Yeah. Yeah. And I guess let me know if you want ray tracing round 3.
I I already raised my hand on that.
All right.
Yeah, maybe hopefully in London again. Yeah,
Yeah. Yeah.
fingers crossed. Um,
Yeah. I'm excited to hear about the next DConf whenever that's official.
Man, this is the worst part of my job. knowing that we're talking about DConf already and not knowing if we're going to do it or not going to do it, who's going to do it, where's it going to be, dying to make the announcement. Oh man, I'm going nuts by that. Did you, we only saw you a short time in London. We saw you on the day of your talk, and I think you came in on the last day of the hackathon there for a little bit. How did you enjoy your trip there? Did you stay long or?
London was great. Yeah. I mean, the day before, to be honest, I was watching the live stream and polishing up my talk and getting renders. I thought it was fantastic. I mean, to sort of sell the audience or anyone who's listening, I mean, the talks were high quality. I mean, the talks for DConf Online have been super high quality. There's just so much to learn, and to put faces to names with folks on the Discord was really brilliant as well. So it's been a lot of fun. I'm planning on coming back wherever it is, London or elsewhere.
We have a question here from Anonymous again. I know who it is, but we have a vote. He provides a vote for ray tracing part 3, so that's 2. Given you've written ray tracers in multiple languages, what were the pain points in D compared to the other languages?
That's a good question. I mean, I'll tell you. I mean, basically for this talk, the performance was where I had to be careful, right? So all these little things where I was allocating, even thinking about where could I actually parallelize something, which at the end of the day becomes relatively trivial in D, right? Doing dot parallel or these types of things. I think there could be some of the same pain points regardless of the language that you use, when it comes to the level of, maybe the next step is to start using SIMD intrinsics and see if that makes dot product operations faster, or these types of things. It may or may not, but I think those types of operations will be the same sort of pain points. I can tell you certainly that things that were nice, at the very end of that talk, just having a JSON loader or XML built into the standard library to start making this a more data oriented ray tracer. That was just wonderful to grab these tools right off the shelf, not have to download any external libraries. So I really appreciated that part. I'll plan on continuing teaching ray tracing in D, the next iteration of that course. And it sounds like as we get more votes for the next conference. Oops, looked like I lost your volume for a second, Mike.
I'm sorry, I muted my mic when I was typing. Silly me. I was saying you've got sorry guys. You've got another vote for the ray tracing part 3 and the live stream.
Right.
Yeah. We have a question from Gary. Since D is not quite as popular as C or C++ in the university curriculum, have you been able to find and collaborate with other instructors at other universities that have implemented D in their curriculum?
That's a great question. I think it was, I'm going to blank on the last name. Was it Chuck?
Allison.
From Allison. Yeah, Chuck Allison. Yeah. So I haven't reached out. I know that was one, and I think Chuck had given some talks or even hosted a DConf
yes.
a while ago.
2015, one of the ones I missed. I missed 2.
Yeah. But what I'll say to that, even C++ isn't very popular these days in university curriculums. No one wants to teach it, right? It's too hard, and that's one of the problems. And when I mean too hard, I mean picking out the subset of the language and being willing to teach students debugging and these types of things. So I think D is going to actually be an easier sell. I'm sort of leading the way on that. There is some traction, I will say, in Boston, which me and I think some others in the D community can talk about, in January or so. I think folks are going to take a serious look at D as far as teaching it in a university, and then likewise using it as a tool in production. I see that coming. I don't know when, but I think folks are tired of teaching C++, the ones who are willing to do it. Sometimes it's the right tool for the right job, and then you absolutely should use it. But that's why I pick D for some courses. It's the right tool.
All right. We have 2 people now in the queue for the prizes. Any more questions for Mike? Mike S.
We got to give you some questions, Mike.
Turn the tables.
Yep.
Nah, they shoot them at me sometimes. Yeah, I might have to ask you in for one of our D community conversations later on down the road. I've got a long list of people I need to talk to there, so I've got you on that list.
Yeah, absolutely. And likewise, I really enjoyed your, talk on the history of D, and
Thank you.
so that's, awesome stuff. All these talks, and this is to everyone listening, all these talks that people are putting together, students are going to see these, and new folks. It's super awesome what's going on in the community right now.
Yeah, and it's still amazing to me. I mean, we take it for granted, but it's still amazing to me that we have this platform that we can use for this completely free. I mean, can you imagine 25 years ago thinking, this would have been a pipe dream? It would have been fiction, science fiction. And now here we are producing videos in our homes and uploading them for the world to see, to promote whatever it is we want to promote. And I absolutely am fascinated by that every day. I mean, people are fascinated by Chat GPT right now, or whatever it's called. But to me, it's still YouTube. This is the amazing thing to me. Is this a question? When using either C++ or Java? Oh, no, this is a quote. Okay, this is from Carl Sturdivant. Well, there's a quote from Chuck, and then there's Carl Sturdivant. He's been, Okay, he's been in our forums before too, so they're quoting stuff from the back of all these. But come on, guys, more questions for Mike. Don't make me do all the hard work. It's not hard work. It's easy. Talking to you, no problem. Questions. Don't you want to get your name in the hat, Ricky?
Yeah.
You got to get your questions in during Q&A time, man. You asked one before it was Q&A time. You don't get the prize unless it's Q&A time. Well, what's next for you? What's next? Do we need to know the linear algebra and matrices do we need to know linear algebra to program in OpenGL?
Yeah, in particular, I mean, if you know dot product, cross product, and are willing to use a library that'll take care of the special matrix transformations for translation, rotation, and scale, you can get quite far.
Mm-hmm.
And I think this is even getting maybe to one of your questions about what's next is I'm thinking a lot about library building for actually thinking about, and again, I can't promise anything, but teaching OpenGL in the D programming language instead of C or C++. That is something I'm thinking about, and then helping contribute as far as a library on the math side to make this approachable and lower the barrier of entry for beginners interested in graphics.
And you just stole my next question from me right there, because I was going to ask you about a math library, because we used to have, I cannot remember the name now, there was a math library in D. It was a port of a C++ library that was popular at the time, and I think several people were using it for their little projects, but it's not around anymore. And that's one thing we're missing right now is a good solid math library. I've got a question here in the live stream from Ali, but before I get to it, in your courses, do you use a custom library, or are you using external libraries?
Depends on the class. Most of the time for OpenGL, GLM, which is the OpenGL Mathematics Library, that's sort of the popular go-to one.
Yeah.
For my game engines course, students are building from scratch, so they just implement from scratch.
Ali's question: do you think double dot parallel loops really helped? I really don't know, he says.
It's a good question. I mean, certainly from what I profiled, right, there was some performance boost. With parallelization, if we're just launching, and in this case, lots and lots of threads, right, there's overhead to launching the threads, certainly, for the amount of work done per pixel. And the general rule I've always sort of learned, and I've seen some empirical research on, is 2 threads per core is about what you want. So I think it did help. Is that going to scale always, or I wouldn't say that was for the amount of pixels, 10,000 times faster or whatever. But I think it did help in this case.
Okay, and Ricky says GL3N. That's the library. I couldn't think of the name. GL3N is still in good shape, so that's
awesome.
Good to know.
Awesome. Yeah, this is I learn more from the folks attending DConf every time, so that's the fun of giving a talk here.
Yes, it is, and it's one of the great things about talking in person too, because I mean something always comes up that you weren't aware of. That happens to me at every DConf that I've been to. All right, so we are about 30 minutes away from the next talk, so we need to start winding down here, fellas. So any more questions for Mike before we wrap it up? And while we're waiting to see if there's any more questions, why don't you provide us with some final thoughts beyond the conclusion of the video?
Well, I got to put this for the highlight reel, but I got to say, D rocks. so you can compile those in a short.
I might as well just stop asking the question.
Yeah, but I guess, what I will say is, I'm really exciting to be working in D, thanks to the community. I hope the community is ready. There's going to be about 120 new students learning D, so I'm going to send them to the forums and around, but I think that'll be exciting. And yeah, I encourage everyone else to make little YouTube videos, whether you think they're useful or not. I think it's just useful to see some programmers writing D, and we can all learn from each other that way.
That's great. And I should say that his tutorial series on his YouTube channel is really good. So if you know anybody who's new to D or is just learning the language, please point them at his playlist there. And, you talk about these students coming in. I think some of the coolest projects come out of university students' experiments and tests with the language. We a lot of our old stuff in the D1 days was driven by students who had all this time on their hands because they weren't doing their homework or whatever. But so, all right. Ricky says, let us know more closely around that time, and we may be able to do something with Discord roles and stuff. So that'll be cool.
Absolutely. Yeah.
All right, Mike, it was great to talk to you again, and hopefully we'll see you at DConf next year, wherever that may be.
Yeah, likewise. Thanks for running the show, Mike. And now I get to sit back and relax for a few hours here.
And I get to pick a winner for the prize. Let me see, who's it going to be, if I can remember how to run it. All right. Gary, congratulations. You have won a prize, and I don't think you've emailed me yet. So if you can please email me at qna@dling.org, then I will get back with you on how to claim your prize. Congratulations. All right, and it is break time. I'll see you all back here at 40 past the hour for, I believe it's Steve's talk, is it? Yes, yep. It is. Model all the things. All right, everybody have a nice break. Bye-bye. Take care, Mike.
Take care, Mike.
Just muting the
Okay.
YouTube.
We are live. And we got a few people back in the stream. How's the DConf looking right now?
It's a lot quieter today than it was yesterday.
Oh.
A lot more people in the stream, a lot less people in the DConf. It's still, I guess it's overtime with the World Cup. So.
All right, yeah, bad timing this year, the World Cup, man.
Perfect.
I wish,
timing, yeah.
if I'd known I was, if I'd been a World Cup fan, a football fan, I would have known and would have scheduled a different date. Are you a big fan at all?
No, I don't. No fan at all of soccer, football, whatever you want to call it.
Yeah, I've been outside of the States too long now. I can't call it football, soccer anymore. And I measure distance in meters now. So.
Yeah.
Yeah. The Hegpets says, I mean, really, the World Cup could have rescheduled around DConf. Just saying. Yeah. That would have worked for me. All right, Steve, I think everybody knows who you are, so we don't have to introduce you, but you could tell us a little bit about the talk before it begins.
Yeah, so the talk is basically something that I've noticed just writing Decode over many, many years of how you spend time when you're shaping your APIs, that the decompiler has such great tools to model the data and the data that you want to pass back and forth between things with UDAs and structs and everything. And it's if you kind of go full bore into that, if you try to use those features, the code actually ends up looking pretty darn nice. And the things that I'm showing in there are basically sometimes I'm comparing to an existing project, and what it might look like if we used a more model-based API than the other way. And sometimes I'm just showing off code that I'd either dreamed up in one case like 5 or 6 years ago, and never actually implemented until this talk, just to see what it would be like. Or stuff that one of my projects I've been working on for like 4 years, I think, that I use in my one of my day jobs. So it's pretty interesting how nice the code can look and how much the compiler can do for you if you give it the right tools.
Well, has this topic been on your mind? I mean, I know a couple of these projects are older projects, but I mean, has this been on your mind as a concept, as a topic for a while? I mean, I know you were.
I'm a big fan of it. I think for the last, I want to say like 3 years, I've been dealing with projects that don't use this concept and probably should. And I think I've always like when I wrote the IO pipe library, for instance, I rewrote that API 3 times, I think, because that's just the way I am. I'll take a project, I'll work through it, say, okay, this is what I want to do, and then I get it done, and I'm like, okay, it's working, and I hate it. So I'm gonna have to throw it all out and start over again. But I always like to have the API being really nice to use and easy to understand. So that's like one of my things that just bugs me. And so I'm always looking for better ways to represent an API. And this is kind of where that led. And I figure I accumulated enough of that baggage that I could make a talk out of it.
Yeah. I remember we used to have modeling power as one of the selling points on the homepage. And I don't think it's something people talk about so much, the users. At least I don't see conversations about our modeling power anymore. So anyway, I think this is a good talk to introduce some of these concepts to people who don't know D particularly, or people who do know D, but don't know how to take advantage of some of the things you show. And
Yeah.
I think it ties in pretty well actually with Attila's talk from yesterday.
Yeah, it's very similar to that kind of stuff.
Yeah.
Oh,
I love it. I love it when people submit related talks that complement each other.
Fancy anime introduction. I haven't seen that one yet.
Yeah, I was trying to do everything a different one for each talk, and I don't know if I did any repeats or not. I wasn't paying too much attention to it.
Remember, I think the first year this is like always the one that came up.
Yeah, because I didn't pay attention to it that year. I don't think I said it. I think I let YouTube pick them the first year. Last year, I set them. So, excuse me. Unfortunately, it's been about 2 weeks since I last saw your talk, so it's not fresh in my mind right now. And I was
I must have been an early sender.
You were the earliest, I believe.
Okay,
so, no, you were second. Mike was first. Mike Shaw was first. That's right.
Oh, by the way, this is my first talk where I actually used a green screen.
Yes, yes.
So you're going to notice that.
Yes, and it came out well. And the talk has started, and I didn't post the link in the live stream. Look at me doing it again. I'm really on top of the ball tonight. All right. So we are under.
I do have the live stream open so I can respond to chat directly.
Okay, cool.
But I don't have it up on the screen. So
yeah, so I'll
if you see anything, let me know.
Yeah, I'll ask questions. I gotta verbalize them for the Q&A video anyway. So you start off with the basics, with the interfaces and the classes. I can't remember if we've talked about this before. You had C# in your background, right? Not Java.
I've done both.
Okay.
I have done more C# than Java.
Mm-hmm.
At one of my previous jobs, the server was built out of C# and I used .NET remoting, and it was really fabulous. Mm-hmm. I still, the generics are just nothing like templates, so I don't prefer it. And this was all before async await and all those other things. And now that if I go back and look at that, it's awful to me, that async await API. But yeah, Java, I did a decent project in Java, but mostly it was C# or D or C++.
Okay, I'm curious because I have a pretty good background in Java, but I don't know, my knowledge of C# is superficial. But and I asked that because if you are coming to D from Java, it's natural to reach for interfaces and classes right off the bat. But then the first thing, but then the first thing you run into is that you have destructors in these classes, and you might think, oh, this is different, and you're not going to be aware of how to use them. But if you come from C++, you're going to expect to use the destructors, and they don't work out as you expect. C# has destructors in their classes or finalizers.
It's been like 13 years since I really used C#, so I don't remember.
All right. So you call this the original?
Yeah, because the interface is the original modeling system. Because basically, you have an interface. It's like, this is the thing. Here's the things it can do.
Yeah.
So,
well, I was struck. Because I think you didn't list destructors on your list of disadvantages here, and to me, that's a big disadvantage
Well, destructors are still there. Oh, for interfaces.
Yeah, because you have to apply them to a class, and your class is going to have a destructor. So, if you're not using the destructor, it's no big deal. It's not a problem. But as soon as you start using it, there's a whole world of pain.
So
there.
there's a when you have a destructor in a class, most people don't really know what to use it for, and it has a specific use, and you almost never should use it. But the specific use is if you have resources that you allocated that aren't memory or GC allocated resources, then you have to clean those up in the destructor. And it really should be, so if you have, let's say, C allocated memory, that's a really good target for saying, okay, I'm going to clean this up. This I own this now. The GC isn't going to clean this up for me, so I have to do it. But you can also use it for, let's say, closing files or sockets or whatever. Now, you probably shouldn't rely on that as the thing that cleans it up. You should clean it up before your class goes away. But it's good to have it there as a last resort. And in fact, my first real D project that I used at work was like a little agent that I would run on remote systems to initialize them. It worked on Linux and Windows and everything using Tango. And I relied completely on the GC to clean up all my files, sockets, everything. And it worked fine, really wasn't a huge problem. But of course, those resources are a lot more limited. So you do want to clean them up a little bit quicker. Yeah.
Well, I mean, I just, interfaces and classes just such a natural fit for Java programmers, but they don't have if you don't have the C++ background, then you're not going to know what a destructor is, but you're going to think, when you do find out about it, you're going to think it's like C++. And
it's more like a Java finalizer than it
exactly.
Is like
and
than a destructor.
Finalizers are verboten in Java these days. You're not supposed to use them anymore.
I don't know.
Yeah,
I would assume it's the similar thing that that you have for Ds, like for cleaning up things that aren't Java allocated. Like if you have a Java class that is a wrapper for, a JNI socket or something like that, you got to clean it up there, and that's what that's for.
We got a kind of a compliment here from Adam. The code font in your slides actually looks kind of okay. I usually hate fonts.
Yeah, no. I spent a lot of time working on that font. It's basically so an Apple Keynote, which is what this is. If you copy and paste from your console window to the Keynote, it copies the syntax highlighting. So that's what I would do, is write my code in a VIM editor on the console, then select it, copy and paste it, and it'll copy and paste highlights and stuff too. So it's pretty nice to be able to do it that way. I think in a future talk I might actually write some code to do the presentation, but this time I just wanted to get it done.
I did my London talk in a vector graphics program. So
nice.
I was trying to learn how to use it more efficiently, and that was a good way to get into it. I was gonna, the duck typing. That was the next thing after the classes and interfaces. Now it seems like something that would be a good way to teach children. This seems like a good concept for your students to learn. Have you taught them anything about that yet?
Oh, there's one big barrier for my class, and that is that we're only meeting once every 2 weeks. So there's not much I can. There's two things. We're meeting once every 2 weeks, and the other thing is that this is more of a exploration. Like, it's not like a real rigid school class, that you would say, okay, we're going to do tests and homework assignments and stuff like that. We did do some homework assignments, but most of it was all optional. It was like, here's some things you can do in the meantime between our 2 weeks, but most of the kids don't do it. So, so like what I'm trying to do is just introduce them to concepts, and I consistently would introduce them to a concept. And as I was explaining it, I had my notes. I'm okay, I'm going to go through this, and this. And I would get probably about 25% of the way through what I thought I was going to talk about, because they would just have so many questions. So I don't think they're at the level yet to talk about, complex typing and things like that.
It seems like it's a less complex thing, I think. And the idea that if it quacks like a duck, or walks like a duck, I mean, it's such a concept
but
to
I
get
mean,
across. But I know what you mean.
only,
Yeah.
the only thing is now we're talking about templates.
Oh wow. Fun.
You know, if you're dealing with duck typing, you're dealing templates.
Yeah, that's true. That's true.
So I didn't want to go there.
Yeah.
All of my code is simple structs and stuff like that I show them.
Well, if I'm watching this video on YouTube somewhere down the road and I haven't seen your talk yet, how would you summarize your strawman structs library to me?
All it is it's obviously a proof of concept. I literally just wrote it for this talk, but it basically allows you to provide a model to then do your template constraints with. So instead of, you see the left side here, it's all like, oh, does this work? Does that work? That's just a bunch of stuff, that to try and then reconstruct, oh, what does this type actually look like? Whereas on the right side, it's just like,
clean.
That's the thing, I can read it immediately. And it doesn't matter that the code underneath is really complex to generate all those little things over there. It's kind of like, you don't think about you can, but you don't always think about, what is my code generating in the exact assembly? Like, I don't care. I know what it's supposed to do by reading the D source code. I don't need to read the generated assembly to prove that to myself. So that's the kind of idea, is like your model is like your high level code, and then the individual checks or the low level things. So
well, have you, since you recorded the talk, have you thought about how you're going to handle infinite ranges?
Not completely. So the difference between the thing about the infinite range is, you'd have to say an infinite range is either something that doesn't know. So an infinite range is something that has the empty is an enum, right? So it's compile time always true. And I could invent some mechanism to say that, but the thing that was really tricky was it's really the random access range could be an infinite range, or it could be a bidirectional range.
That's what I'm talking about.
That's two different API pieces that have to be correlated. Like either has length and has up and is a or it doesn't have length and it's an infinite range. So it was kind of like these two checks that have to go together, and I'm not sure how I would couple those together. But I mean, obviously I could come up with something. The thing is, you have all the power you want. I can create a dummy type that then signals to the strawman library, oh, this is what this means. This is grouped with this other thing. So you could see that with the any type. I could say, the type this thing returns is also the same type as should be in this function parameter. I don't know what it is, but it's got to match, and that's how that works.
Yeah, I haven't looked at the code yet.
The code is really gnarly, actually.
Yeah, I was gonna ask how it looks on the inside.
It does work though.
Yeah.
But like I said, I just wrote it for that Boston D meetup talk I gave like 5 or 6 years ago was just an idea I had. And then I was like, I want to try and implement that, because that was kind of like a modeling thing, and see how it would actually work. And I just got it working so I could make the slides. It wasn't like intended to be like, oh, go and use this library now. So yeah, it needs a lot of polish, but I mean, the concept is solid, I think.
Yeah, and I notice you're at the core implementing it with mixins. Are you using mixins extensively in your decode?
Yes. So when you're doing compile time introspection, you have to use mixins, because there's a lot of stuff that comes back as strings, and they're actually a lot of times easier to work with, especially. So one thing that's great about a string mixin is you can use all the string manipulation functions you want
Mm-hmm.
to generate your code. If you're just handed an alias, it's not as easy. Now you have to deal with templates necessarily.
Well, where I wanted to,
functions.
Where I intended to go with that question is, I mean, everybody's going to use mixins to some degree in their when they're meta programming, but are you using them extensively in your decode? I mean, to the degree that you find you have to debug them. We had this conversation yesterday in the chat.
I know
about,
what you're saying.
Yeah. So have you reached that point yet, or are you still just using them?
When I use them, I use them as sparingly as possible. I love the new feature too that mixin can be an expression instead of having to be a statement.
Mm-hmm.
I think that's not that new anymore, but that makes it really nice because you can put more of your code as actual code instead of having to build this giant mixin. There's also, you can now mix in types, which is great. So there's I want to do the least amount of stuff with the string mixin, if I can help it. And there's some other tricks you can do, like declaring an alias for a type and then using that alias inside the mixin instead of trying to name the thing that's coming in. That helps a lot. So you try to make your mixin code as simple as possible, because like you said, it's almost impossible to debug. But like, if you want to look at a library that uses extensively string mixins, but also provides a decent debugging experience, you look at Vibe diet templates, because they basically take a completely different language and convert it to D.
Right.
But then if you have errors in that generate bad decode, instead of pointing you back at the mixin code, it actually points you back at your source code in your diet template, which is kind of cool. So there's ways to make the mixins friendlier to debugging, but it's not perfect.
This GitUp2 library is something else you developed for this talk, yeah?
Yeah.
To use the strawman, yeah. And I was going to ask you, you say it's a whip, and I was going to ask you if you have any plans to go anywhere with this, but then I see your commit message here is a commit for posterity. So that that doesn't sound like it's going anywhere. Are you planning?
No, I think that it's. I think that I might release that. That was a cool little project, and I was surprised at how easy it was. If you look at the code, it's super simple. So it's easy because I can just wrap getopt. If I was going to do it for a permanent thing, maybe I would rewrite what getopt does instead of like just forwarding the call there. But yeah,
Attila said yesterday that something like mirror, the goal would be to get it into the library at some point, so that we would have painless metaprogramming in the library. Would you like to see something like your strawman stuff in Phobos, or does it belong outside as a third party?
So there's always a cost, and I don't really talk about the cost in this talk, but other people have talked about it. But whenever you're doing lots of fancy mixins and templates, there's always a cost to doing that in compile time. And I am not sure how much compile time, like using a strawman struct, would add to the compile time versus just using the individual things. So that's something that would concern me about just putting it into Phobos and having it just go to town. I mean, we recently had a guy on the forums, or I guess he wrote a blog post that was identified in the forums, where he's converting his D game to Jive because it just takes too long to compile.
Yeah,
and
I saw
it's
that.
really just from all the incremental templates usage, and it gets to the point where it's like, okay, well, I've already designed my code to use all these templates and have all this stuff in here, and if I want to make it faster to compile, I have to rip everything out and redesign it. It sucks. So I mean, I really think a good answer is we just need to make templates faster, or need to make introspection capabilities like that mirror library to make that faster. And I think a better CTFE engine would be a huge help there.
Adam says, the only time you have to use mixin is to generate new identifiers. I hope I interpreted the E correctly.
I think something like that. The only time we have to use mixin to generate new identifiers. Yeah, but sometimes if you want to access pieces, I mean, yes, you can use the traits get identifier and traits get member and all that stuff. And sometimes that's okay. Sometimes it's like in the get_opt example, I didn't show it on the slides, but I'm basically creating a giant mixin to call get_opt with the right values. And generating a list of arguments is not something you can do at compile time. You have to generate a mixin and then call it that way. So there's places where you have to use it, but like I said, I like to not use it as much, and at the same time, because we're using strings, you can use CTFE and just write a normal function. Mm-hmm. That's really, really nice. And providing a better way to just write a normal function, like with the mirror thing or with some other feature, like maybe the type functions or whatever, I don't know. That would be really useful in reducing the amount of weird template code you got to write.
I'm not sure what. There's a comment here from Spoofer. Once projects get to a certain size, we should embrace object files and traditional incremental compilation. It's convenient to build everything all the time, but not the only way.
Yeah, I think that you can do that to a certain degree, but you also can't do that when you're using templates today, because if you're using a lot of templates and templates are not in that object file, you need to generate them for the new compilation. So, if you have for instance, I don't know, some data structure, linked list, right? S list in Phobos. If you have an S list of int, maybe that's already in Phobos in the object in the library file, fine. But if you have an S list of your specific type, that's not going to be in there. So you need to generate that as well. And you can do, I mean, one thing I would say is if you use Dub, you're already kind of getting a lot of that for free, because it's already building the library separately that you depend on. But yeah, splitting it up into different object files, it would be a benefit. And I think Adam had a great idea based on his blog on packaging the object files with the already compiled templates or the already processed templates as a separate piece that then you would avoid some of these weird linker errors, because avoiding linker errors is always a huge a nice thing. Linker errors are just like, I think Andre in his book says, it's encrypted Klingon. That's what it tells you the error is.
Years ago, I when I first saw opt dispatch, I thought it was like one of the most awesome things ever, and never had a need for it in the stuff that I do. Does that show up in your code at all? How often do you use it?
Oh yeah, I've used it extensively in the SQL builder. Everything is an opt dis. There's literally in the data set type, there's two functions. They're both opt dispatch. So
does it work as advertised?
Oh yeah, no, it's great, because what you're doing is you're modeling. You're creating a type based on the original model, but the original model just kind of driving how your new type works. And using opt dispatch, you can just generate the functions that are used. You don't have to generate all of them. Like I think I don't know if it's already gone past. I think so, but yeah, the like the black hole and white hole, you're generating a class based on an interface, but you have to generate all those functions that you even if you don't use them. With op dispatch, you only have to generate the ones that are used. So it's a pretty nice feature.
Yeah, so it's solid, and you haven't seen any corner cases or.
Oh, you know, one thing that does stink about op dispatch.
Okay,
is,
here we go.
And this is really a more connected to the design of the compiler. Is if you have an op dispatch member in your code, in your struct, it will try that op dispatch, and if that op dispatch fails the compiler, it pretends that it's not there. So if you put a bug into your op dispatch by accident, like maybe you forgot to import something or whatever, it will it's like you didn't. It doesn't even try to call it, even if it would match the function parameters that you're giving it. And so that can lead to some very weird errors, like maybe it tries to call, some other function somewhere else because op dispatch didn't compile, so maybe I'm going to look for a UFCS function. And that can get really annoying. And plus, it also overrides things it shouldn't override because of that. And these are problems that have been tried to be fixed in. I think Rosvan has tried to fix someone, and somebody else tried it a while ago. But it's really hard to do it because the way the compiler treats compiler errors and how it. I mean, this is not something that I know because I don't know the compiler very well, but I've read the comments and they say that this is just too hard to do because of the design of how the errors are gagged and treated. So it's unfortunate.
Adam says op dispatch rocks, but you do have to be careful with it so you don't accidentally trigger duck typing.
Trigger duck typing. Yes, you have to use liberal template constraints. So you basically want to say only you don't want to leave it up to the body of the op dispatch not building. You want to kind of have a template constraint that says, I don't want to override this function. I'd let it go to the UFCS function if this if it exists.
So in your experiments with putting this together and testing it out, did any bumps in the road stand out to you? Or
which part?
All of it. The straw man, not this. I wasn't asking about the SQL builder, but the straw man and using it and developing it.
The GitOps I wrote in like a day. That just almost wrote itself. It was really nice. And one thing I did forget to mention on the GitOps, there's a guy who wrote a similar type of library written from scratch. I think it's called argparser. It's in the code.
I've
you should
heard
check
of it.
that out. It does basically everything that my GitOps 2 does, but it's just got way more features, and it doesn't depend on GitOps. So I do like that library. I would recommend it, but I meant to mention that, but I forgot. But the strawman I struggled a lot with. At first I was like building it. I was like, I can't make this work. And then I just stepped away from it for a bit and came back and was like, oh, this is dumb. All I have to do is take this model and build what I would have written as template constraints. And then it was easy, then it just went easy.
Did you go running?
I wish I could run. I used to run when I was younger, but I don't know, something about my knees. If I run for too long, my knees start hurting and I can't do it. So I can do like biking or elliptical or something like that, but I can't do the running.
Yeah, getting out of it is easy. Getting back into it is so hard. I've never been a runner, but I did go to the gym not so long ago, and I just can't get back into it since I haven't been going. Well, what are you going to pursue this further? I mean, in the immediate future, or are you putting this aside for a while to work on something else? What are
which part?
The strawman.
Strawman. I wasn't intending on pursuing it unless people are interested in seeing that done. I definitely could spend some. I have a lot of other projects I want to get finished. So it's just, for me, it was just a toy thing to demonstrate something, and it certainly could be turned into something more robust. But I do, I think it's something that people might like. People might like to use that.
Yeah,
I don't know.
I like what it does, but I'm curious. I mean, I'm looking at this in one way. We're presenting this stuff as like, this is awesome. This is these modeling power. It's really cool stuff. It is cool.
Yeah.
And you got Attila's mirror, and but then you stop and you think, okay, we've got both of these talks at the same time. That means there's some kind of demand for this, and everybody's looking at it. So what does that say about these metaprogramming? We all talk about how great these metaprogramming is, but what is it about it that we need to come up with these simplified interfaces to put on top of it? And why don't we have them there already? I mean, is there a message here that we need to do something, to change something, or is the message that it's working as intended because it allows us to do these things? How do you see this?
So I see it in a few ways. Like you said, one of the things that seems to happen is, and I talked about this in my 2019 talk, is that everyone ends up writing a serializer in D because it's made for that.
Well, I've never written a serializer in D, but okay.
Well, yeah. But you always, it's so easy to do that you end up doing it instead of having to rely on somebody who wrote this really complex, fancy piece of code. It's like you just do a for each loop over the members and you're done. It's that kind of thing where it's like, it's almost trivial, so that it's like, do I really need to make a library for this? And that's one piece of it. So I think that's why we always have all these new things that are the same as the other things that other people have written, that basically accomplish the same thing, but in a slightly different way, because it's like, oh, I could just do this and I don't need to look for something else. Mm-hmm. But on the other hand, there are some pieces that, the language could be better with. If there was a way to interface with the compiler to say, make it look like this, like a C++ concepts type of thing, mm-hmm. that would be something I think people would use and find value from. And the template constraints is one of those things where I look at it when, like, for instance, I tell my students, here's this function, write line. This is how you output stuff to the screen. I don't want them looking at the signature for write line in the documentation. It's just, they will never understand what's going on there, because there's just so much stuff with template constraints and different character types and UFCS. There's just so much stuff. So I'd rather just tell them, call this to write stuff to the screen, and maybe you don't have to think about it. But making the template constraints more approachable like that, I think would be a huge benefit, at least to the documentation. Like, another thing that I didn't really talk about with Strawman Strings is you can document that model. And there you go. There's your document that says, you can go right into DDoc. Here's what a range looks like.
Is there a future dip authored by Steven Schweighofer on for struct lambdas? I guess we could call them anonymous structs.
No, probably not. I'm the type of person who likes to throw stuff, over the wall at the compiler developers and let somebody else catch it and run with it. I'm not making those dips, because I have no. I leave that to, like, Timon and Paul and Walter and all them to figure that out, because I'm just a poor user that says, oh, what if we could do this? That would be cool. And then they come and say, no, it'd be bad because X, Y, Z. And they're like, yeah, you're probably right. So
Adam says he likes the struct lambda idea too, and he has a code example there. Will probably be easier for you to look at it than for me to read it to you.
Let's see.
Above it, about the anonymous structs and enums. More anonymous structs and enum usage in D would bring me joy.
Yeah. Yeah, no, that would be cool. It is one weird thing where it's like, okay, I want to use this struct as a model, but before I actually call the function, now I need to, declare this struct. It's kind of
the talk is over now for me, so we're going to be entering the Q&A
Ricky
officially
just
now.
Said it sounds a lot like tuples. Yes, it does sound a lot like tuples, but tuples you can't put UDAs on. In at least the D tuples that are currently in the library.
So if you have a question for Steve, please go ahead and email me at qna@dlang.org. Or if I know you and your email already, just go ahead and ask a question in the chat with Q&A : prepending the question. I have one more question related to the struct lambda thing. I mean, that's a wish list item that's appropriate for the talk because it was on topic. But what else is on your list?
On my list of things to do?
No, things you'd like to see that we don't have in addition to the struct lambda.
Yeah. String interpolation.
Yeah.
Please. Okay. String interpolation would be amazing. I did mention in my talk as well. And I was happy to see Attila mention that as well. So I would love to see that happen. Especially I'm really excited about the possibility of not just making a string, but using an actual argument tuple, generating an argument tuple that you could then use for things like my SQL builder would be fantastic for
that. Ricky says we should support tuples with UDAs because that is a great use case.
Yeah, I agree. I think it would if we got actual first language defined tuples, it might be essentially just a struct underneath. I don't know. It could be something where you have a struct with tuples. The other thing with the UDAs, and you see this on enums too, is you can put a UDA on an enum, but you can't, because it's not a declaration list. You can't do things like, I want to assign this UDA to this batch of enum members. So if you have something that's an expression more than a declaration block, then UDAs aren't as nice. You have to repeat them everywhere for everything. It gets a little bit tedious.
Adam says the yet another interpolation dip. Yeah, might not be formally written, but the ideas are all solid, and we should just dispense with the formal drafting and write the code.
Well, Adam already wrote the code. He already made changes to the compiler so we could try out our dip that came before it. And that the part that he didn't do, that when we had our dip that we were proposing, one of the big things that was controversial was that if you used it as a string, it would automatically convert to a string. And that was the only part he didn't write, and that's not even in the yay dip, whatever you call it. So it's already there. I don't think it was even that much code.
Okay, guys, we don't have anyone yet for the prize. So, I'm tempted to say if nobody asks a question, the prize defaults to me. But I'm probably not going to do that. I can get them anyway. Give me questions, guys. Questions for Steve. Questions or more comments, but preferably questions. How long did it take you to get all this done, to put the talk together?
So I'd say, like I said, writing the code for the get op 2 took me about a day. That was fun. Writing the code for the strawman took me a few days, and mostly just struggling to figure out the right design for it. And then my SQL builders, like I said, it's been there for a while.
Right. How long have you been maintaining that? How many years?
It's been like 4 years. It's not published on code.dlang.org, but it is published. I had it private for a long time. It was basically for my company. Yeah. I use it internally, but I do want to eventually publish it. I just haven't fully documented it, which is something I'd like to do before I put something out there. So that didn't take me too long, just writing some examples or taking the existing examples that I have in the unit tests.
Mm-hmm.
The thing that took me the longest was editing the video.
But you know
I want
what?
to say, I'm not joking, like 10 or 15 hours to deal with the video. Setting it all up. It's such a pain in the butt.
You start doing enough of them and you get more efficient at it. And then you upgrade your editor to an editor that you didn't understand a year ago. And now it gets faster, but it's still time consuming. And I said this to you in an email and I will repeat it. Yeah. Thank you for editing your video.
Well, I didn't want some of the crap that I edited out going through, because I just did it all in one take.
Yeah.
I just recorded the whole thing in one take, and if I messed up or stumbled or stuttered,
you fix it in post.
I'll just jump back and do it again. And then I had a bunch of problems with the green screen, because I've never done the green screen before. Had to look up how to get that to work. And but yeah, I want to give kudos to Mike Shaw too. He puts out a lot of videos with the green screen, and he must have a studio or something that.
Yeah.
But yeah, it's that was definitely the difficult part.
Adam says it is hard to ask questions when you're as addicted to chat as I am, because so often I've been involved in these projects in some way already.
Yeah, right.
Gary says Minlo is a popular font for editors on the Mac, similar to how Consulus
that is what it is. Minlo.
Yeah, when I'm on my Mac, I like Minlo, and I like I like Helvetica. Not Helvetica. It is Helvetica, right? That's the Mac font, right? Helvetica.
I don't know.
I think it's Helvetica. That's the one I like on Mac. It's sad that I have to have a preferred font on each system I use. You know what I mean? Why can't we just have it all around?
Yeah, I don't know. I'm not very picky about it. The only thing I like is I'd like to have the L's not be, look like capital I's.
Yeah, okay. The Helvetica is the Apple one. What is it? Don't they have a newer version of it? Is there only one version of it? I'm talking to Adam. Sorry.
Yeah, I don't know.
Mike says over the last year, his video editing process has gotten quite streamlined. I'm curious, Mike. I should have asked you this while you were in the stream with me and in the Jitsi with me. Which video editor do you use? I just upped my game a few months ago and started using DaVinci Pro, so I'm feeling it now. Adam, Kden left to edit OBS Studio and Kden Live. Or do you edit your videos? You just Adam says I don't edit. Okay, guys, questions. I'm sorry, I'm getting us off topic. Questions for Steve. Free Linux editor. Okay, with Kden Live, I see. Let's go, guys. His talk was great, but surely he left something for you to ask.
You're all now enlightened. You have to ask me questions.
When are you going to write a book?
Oh boy. Another thing that sounds like it's going to be a lot of work. You wrote a book.
Yes, I did.
I remember your book. It was a good book. I liked it.
That was.
But yeah, that's not something on my horizon for sure. I would like to do more YouTube videos. Honestly, that's something I really want to get into.
Hey, we think
that. Yeah.
We have a question. Great use of user-defined attributes, e.g. required. Any other attributes you use? Anything for static analysis?
I'm not sure I understand that I use for static analysis. I mean, like,
I guess
the other built-in attributes?
Or UDAs, maybe? Processing the code? You have a required attribute.
Oh yeah.
that you use. So are you using any other attributes like that? Are you doing?
Oh yeah. No, I have a bunch. Anytime I have something that I want to affect the way that a serializer works, or that you're basically talking to your library through the compiler. You're telling your library, this is this other special way I want you to handle this thing. It's not like a normal field member. I want you to treat it this way. So, for instance, in the SQL builder, if you have a column name that can't be, or that either can't be represented in D because it's a keyword or something, or you have it, you want to call it something different in your code, which I had a case like that. Then there's a UDA that says, okay, really just call it, the column name in the database is this, but I want to use it directly as this other name. Or if the type is different, like sometimes in one case in my SQL builder, I have I had an existing database which was built on using PHP, and one of the legacy things is an active or inactive flag was the guy stored as a character, like a one character varchar or one character string. And so I wanted to, it was either A for active or I for inactive. Like, I don't know, just weird. So I wanted that to come out as a Boolean. So I created a type that parses the A or I and creates a Boolean, or takes a Boolean and spits out an A or an I on the way back. So, there's different ways to do those things, but I've played around with a lot of stuff. Different ways to do those things. That's the other thing about D. It's such a wealth of possibilities. You almost don't know what to pick.
Mm-hmm.
So there's very many. I use UDAs all the time. It's one of the best features of D, especially when you're doing modeling. Yeah. Sorry.
No, go ahead. I don't want to interrupt you. I thought you were done.
I am done.
Okay. Spoofer asks, what kinds of things would you like the most help with, or that the D community needs help with?
I don't know. I think the D community needs more polished tools or tutorials, or that's the whole thing, the ecosystem. Like, I feel like people come to D and they find this language and it's amazing, and they're used to something else in a different language, and that thing just doesn't exist, and they're not going to build it. They're going to say, okay, well, maybe I don't need that thing, and they work on stuff for a while, and then they just lose interest because it's not.
That was my DConf talk.
Whether it's an IDE or certain kinds of tools, debuggers, like the debugging situation in VS Code and on Windows is just horrendous. Like I can't even use it with my kids, because if you look at a string, it's just going to show you a pointer and a length. They're not going to know what that means, So those are the kinds of things that I think would really help D adoption.
Well, one thing that I've recently I've had my eyes opened to, and I mean very recently, is that, in the past, I've always looked at contributions from the community, where do we need people to contribute? Where should we direct volunteers? If somebody says, I want to help, then, hey, go do this, go do that. But I think I've kind of had my eyes opened that that's really not an efficient thing to do. It's not the best use of anyone's time or skill set. And what you do is, when somebody says, I want to help, what can I do? You say, what do you want to do? And say, go do it. And I think, we've got a lot of things that need doing, but nobody's going to do what needs doing unless they really want to do it. The people who want to do it are the ones who are going to stick through to the end. And so, I I have dreams, I have goals to see about how we can bring this stuff into action from next year. So what the community needs help with is getting people motivated to contribute to the projects and the repositories that excite them, the ones that they are eager to see, to use, the ones they're eager to use, the ones they want to see work when they're not working. So I think that's what we need help with. So I think if you see something in the community that is broken and you are the guy to fix it, then fix it. You know,
Yeah.
And we'll, you know, I mean, we've had contributors like that over time, and we haven't. I don't want to go into a long spiel about this. I'm sorry. Yeah, the hard part is keeping people motivated and keeping them following through to the end. But yeah, I just let us know. You know, come to a meeting, come to a foundation meeting. You know, email me, email Razvan. You know, let us know what you're interested in and how you'd like to help, and we can find things that fit your interests and your skill sets. I think that's the way.
I think also like one of the best things you can do is learn more D. Like if you're coming in and you're like, okay, what can I do to help? I don't know much. Like learn more D, and so you can kind of understand some of this other stuff. And that's one of the things, like one of the reasons I want to make a YouTube series on this is, and Mike's doing a good job of this too, Mike Shaw, but there really is there's a lot of tutorials on, oh, you know C, this is how you do this in D. You know Java, this is how you do this in D. You know Rust, you know Python, whatever. Maybe not Rust. But I mean, there's many things where it's like, if you know this thing, here's how you would do the same thing in D. But there's not a lot of tutorials. Is, oh, you don't know anything about programming? Here's how you would do it. Here's how you program. But we're going to use D to do that. And I really think D is a great language for learning, because you can have what I call like basic D or you know, simple D. You know, you don't have to deal with memory management. You don't have to deal, you know, arrays are just there. Everything's there. And you just learn that part of programming. And then as you need more, you know, functionality, features, or you want to learn about classes, or you want to learn about templates, whatever, the feature is there. You just add it in. So I think that would be great.
All right. I think we're going to have to call it here. We're starting to eat into the break time. The next talk is going to be on the hour okay, we've got one last question from
is it African or European small?
All right. We're going to have to call it here. And Steve, any closing thoughts before we go?
As always, you know, D rocks. I really, you know, the biggest thing I hope people take away from the talk is to open their eyes as to like what types of things you can do with the compiler. The decompiler is super powerful, you know, and enlisting it to write your code for you is like one of the best things you can do. You know, to have it to say, here's what I want, just go do it, and your library that you use to write that code is going to be useful over and over and over again. I can't say enough how awesome it's been to like the SQL builder just say, oh, you make my struct, here's my data table, and then everything works. I don't have to do any other fancy code stuff. It's all done for me already. And so yeah, go use that feature of D and see how it works for you.
All right, Adam. Adam's surprised there. I don't know if you heard him. He answered your question with the appropriate answer, but I didn't repeat the question though in the stream for the future viewers. What is the average airspeed velocity of an unladen swallow? Steve did give the answer, and I put you on the list, Adam. So you're on the list. So I'm running the program right now. Let's see who it pulls up. Guess. Congratulations, Adam. You've got a prize. So No Ricky. Ricky didn't ask any questions this time. All right. We're into the break. It's going to be about a 15-minute break this time. And Brian Callahan will join me at 5 minutes before the hour to give a introduction into the workshop that he's going to be doing, well, that he's already recorded and that we're going to be running here in this live stream later on today. So, Steve, thanks for joining me here. It was really good to talk to you again. Hope to see you in person next year.
Yeah.
And everybody have a nice break. See you on the other side.
Yep. See you.
Okay, we are back from the break, and Brian's having a little technical difficulty there with the audio. Can you hear me now, Brian?
Yep, I can hear you. Can you hear me?
Yes, sir. Fantastic.
Perfect.
We
I
are
don't know what happened.
set. Yeah, the timing was really off there. I just sat down and was getting ready to turn the Jitsi instance back on, and I realized one of my dogs made a mess.
Oh,
And I couldn't wait. I don't get it. He goes to the pad. We have this pad where they pee, right?
Mhm.
And he goes over there and he gets on the pad. He gets his nose right up over it, but the rest of his body's hanging off every time. It's driving me crazy. I don't know how to fix it. And it's like, what's wrong? I'm on the pad. What do you want, man? When I scold him about it, So how you doing today, Brian?
good. How are you? I know.
I'm
Must be what, 4 a.m. where you are?
Yes, it is.
Something like that.
It is 4 a.m. But I'm a night
Wow.
owl anyway, but
Yeah.
it's not a big
Well, I'm
deal.
also the last one, so you'll
Well,
have a bit of a reprieve once I'm done.
yeah, I'm gonna go when this is done. I'm gonna go grab some beer from the local convenience store and hop into DConf while I'm running the live stream for your workshop. So I'm gonna hang around
Perfect.
and watch that for a little bit. All right, so Brian, go ahead and well, the talk itself is an introduction to the
The
workshop.
workshop.
So Steve, beer conf. All right, yeah, that's Ethan's thing. Ethan always shouts that out. So I don't know how to ask you to introduce the talk.
Well, the talk is an introduction to a workshop, so it's a meta intro.
Yeah. So it's what do you want to say about any of this stuff before the talk begins? Is there anything that you'd
Just hope that everyone enjoys it, and I'm kind of trying to reach multiple different audiences here, right? So on one hand, I do want to find the people for whom writing something like this would be a little bit of a stretch. Maybe they've learned a little bit of Python, maybe they've coded one or two somewhat complex programs in the past and are now looking for, right, the next step up in terms of challenge. But thinking about something that Walter said earlier about how we just need more videos out there on D and live coding sessions, or just, you're writing a project, so turn the webcam on and start doing. Hopefully, a little bit of encouragement of that, right? I just took the plunge and did it.
Mhm.
I know Adam also always takes the plunge and does it as well. Much appreciated. But also, one of the goals here is maybe us being reflexive and saying, yes, D is a very, or can be a very complicated language that can do lots of things. That's one of the things I like so much about D, is how it's incredibly expressive. There's almost always more than one way to say the same thing in D. Um, and it's multi-paradigm and all these other things. But could we focus down maybe the way that we introduce D to new people, and think about what core features we can really sell that make D interesting to someone who might either be new to coding or just new to D. And those might be different things depending on the audience. So I'm kind of thinking in terms of the newbies in the coding world. What things exist in D that may or may not exist elsewhere that would be good for us to show off, and kind of good to bring in those new people and get them excited about everything else that D has to offer.
Okay, everyone, the countdown is on. It's probably almost finished by now. Yes, it just finished. I've got the link there in the chat, so if you guys follow it and watch Brian's introduction to the workshop, and I've got some questions for him about that while you guys are watching. Steve says about what you just referenced about the bringing people in, and that yes, 100% agreed. I just talked about that. He and I were just chatting about that in the last hour. Okay, so the first thing I want to talk about is I was extremely happy the minute I saw your video submission for the talk, because I have been thinking, I'd like to do something on day 2. We've had the live coding session now on day 1 for this is the third time we've done it, all three editions of DConf Online. And I've been, what can we do on day two? What can we do that could round out the conference and, just balance that last little hour and a half or whatever. And actually, I'm not sure the total runtime of your the workshop videos. I didn't calculate them all up, but it's somewhere in the neighborhood of an hour and a half to 2 hours, I think. It's probably maybe a little over 2 hours. I'm not sure. But anyway, I was thinking of something to do. I just couldn't come up with anything. And then I saw your pitch for a workshop, and I'm like, hell yeah, that is it. So, yeah. How long has this been on your mind?
For a while, ever since I made that series of blog posts.
Right.
So like I say in the talk, when I kind of first discovered D and finished all the porting to OpenBSD, I thought to myself, all right, let's try this out. And I don't know, I like assemblers. They're a thing that I can code up pretty quickly and kind of forces you to experiment and play around with lots of different pieces of the language. And kind of as I think someone mentioned, it was either earlier today or it was yesterday, about the difference between being a blog guy and a video guy, and maybe that's a generational difference. But I had lots of people reach out to me saying, could you please turn this into a video? I would definitely watch it. And the inspiration actually came from BSD conferences. So workshops are incredibly common throughout the BSD conferences, and I've done a couple there as well. So I've kind of hopefully refined the format a little bit and figured, well, I haven't seen any of those at a D conference, so let's try it.
Well, you mentioned a few minutes ago that this is for a varied audience, and I'll tell you right now, I'm in that audience because I have read compiler books and whatever. I've never actually sat down to implement anything, and this was like a really good project. And it was I kind of had to catch myself a few times when I was in the editor editing your videos. I had to stop myself from watching them long enough to edit them. So I'm think I'm going to work through this if I have the time to do it. Yeah. I didn't read the blog posts. I remember you announcing them in the forums. You did announce them in the forums. I remember that, but I didn't read them at the time. But yeah, the video makes it just look so easy, and yeah.
Well, I hope so. The magic was a little different than I had anticipated when I started actually doing the recording. I have a big television right in front of me, so I had a pre-written version up on the TV, and you can probably see in the video I keep looking up because I'm looking at my own code, right, to help me both not make mistakes, which of course I did during the workshop, but also to make sure that I covered everything I wanted to cover.
Yeah. Do you teach this topic at all? Have you done?
So I don't teach compilers or assemblers. I teach mostly cybersecurity and web development. But in my cybersecurity courses, I do teach a red teaming course. So I teach a whole course on pretty much everything from reverse engineering through to shell coding, through to and including ROP chain attacks. So I do have a lot of experience teaching students when it comes to assembly.
Okay.
Because a lot of the stuff we do in that red teaming course is you have to be able to reverse engineer and read through the assembly of binaries to find their exploits and to then actually perform those exploits.
Well, your selection of the 8080 assembler syntax, was that, or not syntax, instruction set, how much of that was nostalgia and how much of it was practicality?
So it's a little of both. So the 8080 and the Zilog Z80, they technically have different syntaxes for their assembly, but they're binary compatible. And that was a purposeful design choice of the Z80 people. The Z80 came after the 8080 and was kind of an enhanced clone of the 8080. So the idea is anything that you had previously assembled with an 8080 assembler, you can just move over to a Z80 and it will just run. Yes, the Z80 has more instructions, but it will just run. And you can actually still purchase Z80s brand new from the factory. The Z80 is actually still in production, even in 2022, something like 50 or so years after it was first released,
Mm.
which I think is really cool. But the reason for the 8080 syntax in particular is because it is easier to parse through. The 8080 syntax is much more regular. The Z80 has lots of parentheses, and that's how you do things like dereferencing. And you kind of have to parse through a line, see if you have parentheses, see what's inside those parentheses. And you have none of that in the 8080 syntax. So it just makes for a much more simplified parser. And you still get an assembler that will work on a CPU that you can still buy brand new from the factory in 2022. So there's a little bit of nostalgia, a little bit of like this is a real thing you can do on a real machine that you can still build today.
Steve in the chats, in the live stream chat, says, I'm ashamed to say I haven't seen the blog posts. You should announce them all on the forums. And I think you're missing a word there, Steve. You should announce them all again on the forums.
I can do that.
So, yeah. My introduction to assembly, I've talked a couple of times now throughout the conference how I, never was able to get a computer as a kid. I did go and program BASIC at the local Sears when they had the little book out on the table next to the computer. But I didn't. My introduction to assembly was much later. It was Kip Irvine's book. Do you know the one I mean? Yeah. And I didn't stick with it. And I wish I had. I can work my way through when I need to. But was there ever a period in your post Z80 times when you were writing assembly regularly or reading assembly regularly?
Well, reading, yes, because I mentioned, teach
before
courses where, but no, the assembly was just something that after I started teaching, it's just that I just thought it was a neat project, right? Because I've always liked compilers, assemblers, linkers, and I've always enjoyed coding in places where I probably shouldn't have been coding. When I was in high school, I remember not ever paying attention to my physics course, but I did code an entire RPG engine in TI-83 BASIC.
Oh my God.
So, and part of that was really being fascinated in how I could make the machine be reflexive, right? Have the machine program itself in the creation of that game engine. So I think I've always just been interested in languages, and I've always been interested in the different programs that can take human readable source code and turn into machine code. And I know from experience, lots of people think that that's some, mystery black box that's really, really complicated. And it doesn't need to be that complicated. It can be, but it doesn't need to be.
Yeah. Steve came back here. He says, I'm ashamed to say I haven't seen all the announcements on the forums. So touche. You mentioned I think it was the talk, or it might have been the workshop video, but I think it was the talk. You mentioned that the implementation that you did for the workshop is different somehow from the one you did for the blog.
Yeah, so the blog's implementation has no object-oriented coding whatsoever. And while there's no inheritance or anything fancy with any of the objects, I did want to make a point to try to showcase as many different pieces of D that will probably be graspable even for newer coders as I could. So I made it a point to make an object that represented the input source code, another object that represented the output binary, and then I have a third object which the parser will put make into tokens, and the object stores all the tokens and then does action based on what tokens you have.
That's interesting. I've had an idea, one of many ideas that I'm probably never going to follow through on because of the lack of time. but I'd love to have some kind of simple video game like, Asteroids or Pac-Man or whatever, with 3 implementations. One, all D, but one of them C style. One of them just pure C style coding. One of them pure Java style, just heavy on the classes, heavy on the GC, and all of that. And one more of a idiomatic D, a more practical style that I would normally use in my D code, and just show the comparisons in how does the GC impact a game like this compared to doing it C style. I'm sure the difference is going to be minimal, but I would just love to be able to present that to people who are learning the language or who are skeptical about the language or like that. Did you said in the workshop video you're not concerned at all about performance right now and about optimizing. Do you have any? Are you just going to leave it alone after this, or do you have any ideas to optimize further on down the road?
It depends on how busy I get with everything else.
Right.
Right, but the key here really was about proving that these things are not as complicated as I guess the mythos surrounding them makes them seem.
Yeah.
Right, I say I forget if it's in the intro video or in the workshop itself.
See, you're just as confused
right.
as I am.
Yeah. I recorded them all, and you tend to
At the same
forget
time. Yeah.
where you said what. I have this same problem in my lectures too. Students will come up to me and said, "Well, you said this," and I'm sure I did, but I don't remember what day I said it, but I'm sure I said it. But right, so this assembler is never going to win any awards for efficiency.
Right.
But it does work, and it does work correctly. If you feed it assembly code, it will give you back the correct binary code. Right. One of the things I do just for sake of ease of implementation is right. Most assemblers traditionally are 2-pass assemblers, and this one's also a 2-pass assembler. And I explain kind of the reasons why the 2 passes are kind of the traditional way of implementing assemblers in the workshop. But I also say to myself, well, if I'm successful in parsing the source code through the first pass, then I must be successful in parsing the source code through the second pass, because I'm never going to change the source code. So I never bother to save anything except for the symbols that I need to actually do the second pass. Right? I don't do any work trying to save any tokens. I don't do any work trying to remember anything I did other than the labels and their addresses. Because if you can parse it once, you can parse it twice. And that's going to help reduce the complexity. And then if someone later on wants to go back and say, okay, well, we can save a whole lot of time by not actually parsing it twice, parsing it once, saving all the tokens, and then just iterating over those in the second pass, then I would say that's a worthwhile goal to achieve kind of as the next step for them in their coding journey.
Hang on just a second. I'm sorry. Sometime during this session, I'm going to have to toggle all of the workshop videos to public. I've got them all set to unlisted right now. Beginning to get set up for that. Where are they? Here we go. Okay. Yeah. So I'll get to that in just a little bit. So when you were learning to program, and I don't know, I'm sure I'm older than you, but I mean, what era were you learning to program in?
So I was a child of the late 80s and the 90s.
Okay.
But I went to a school that must have thought computers were going to be a one-time thing, because they bought a fleet of Apple IIe's. And when I left elementary school in, well, I'm going to date myself, 1998, they were still using the Apple IIe's.
Yes.
So that's kind of my first interaction with computers, were those Apple IIe's that were at my elementary school.
Okay. So what kind of projects did you make when you first started programming? What kind of projects grabbed your interest early on?
Yeah, so I was entirely self-taught until I was well into adulthood,
Uh-huh.
actually well into college. Um, it was mostly gaming.
Right.
I thought to myself, how could I distract myself, as I'm sure lots of teenage boys did
Mhm.
back then. One of the first things I did gaming wise was, and again, I'll date myself here. There was one of the first MMORPGs, Ultima Online. I was a big player of Ultima Online. And my friends and we had our own private server. And
A
I
shard.
remember, yes, a shard. Oh God. And I remember getting my own setup on my own laptop and playing with all the source code and the configuration files to be able to do things that you couldn't do in the actual official game. And then that turned into, well, could I make a whole game from scratch, in which I kind of lost my whole high school physics education to. Um, and then from there, I kind of got swept into operating systems. I became very interested in, well, how does the hardware actually do anything? Right. I can worry about the high level stuff later. I became very interested in, well, how does the hardware actually do anything? And then I got swept into the operating system world.
I guess the technical term is free shard. So
Yeah. The ones you did not have to pay whatever the monthly
Yeah.
subscription rate was back in the day.
The Run UO, that was the big one for a
Yeah,
while.
that was one.
Yeah.
There was Sphere, I think, was another one.
Yes, I remember that one. Yeah, I remember these because I was Ultima Online. I paid like $70 for it in Korea. It was I was shocked at how expensive it was, but I was dying to get my hands on it, so I paid for it. And when I was in my early Java days, this was late 90s, early 2000s. I think it was 2001. Dark Age of Camelot came out, and it was probably by 2003 that there was a free server for it. There was something called the Age of Light, and it was written in C#. And I started making my own version of it in Java, and it was a lot of fun. That was a really fun project to work on. If I had been proficient in D at that point, if I had known about D at that point, I would have done it then. Yeah, I was curious because we were talking earlier. I was talking with Mike about how I think back in the day, people didn't always have the computer background when they got into their CS courses. But today, you can pretty much expect everybody's got the background to some degree. They've learned some kind of programming in one form or another. How do you find it is with your students? Do they all have solid backgrounds in
Oh yeah,
programming?
no, my students can run circles around me in the coding space pretty quickly.
Mm-hmm.
But they also grew up with it in a way that I don't think we necessarily did.
Yeah, that's the thing. Yeah.
That was the other thing. And there's a lot more, right? Particularly thinking about my cybersecurity courses, there's a lot more to what I actually do and work on than coding and the coding side of things. So I think while they think they can run circles around me, the truth of the matter is I've also run those very same circles, and I do know what they're up to. But I have always been very proud of just how good they are, not just when they come in,
Mm-hmm.
but how hungry they are to get better and how much better they all get in the very short time period of a semester.
Mm-hmm. Ricky has a early question here, and I guess I'll waive the rules here and go ahead. It's not Q&A time, but I'll put them on the list anyway. He says, I really love the idea of making workshops. Oh, it's questions for me, actually. Making workshops commonplace going forward. Mike, can we make that happen at both online and in person? Yeah, so this was something I was planning to address during this session. I think it's a great idea to do this. And, I said earlier, I was looking for something that we could do on the second day of DConf Online, and I think this is a perfect format for it. So I absolutely want to see this going forward. And I think we've got Adam locked into the live coding thing. I think, people will have to fight him to take his place on that. He doesn't come to me, by the way. I go to him and I say, Adam, can you please come and do the live coding session? He says, I'll think about it. And that means yes. So I think I'm going to go to you first next year for the online workshop.
That's fair. I'll say this. I will be happy to do more workshops, but I also want to see other people put me out of business.
Okay, good.
Yeah. Right? Because it's one thing if I do them every year, and I'd be happy to do them every year.
Mm-hmm.
But everyone else is going to have different projects that they find interesting, different ways of approaching how do you code these things,
Mm-hmm.
and different takeaways, right? Because my goal with this workshop was, could we get everyone to walk away from this conference with an actual tangible program in D?
Mm-hmm.
And while I might be interested in assemblers and linkers and compilers, you or anyone watching might be interested in other stuff that would be an even more enticing thing to walk away from a conference with. So by all means, feel free to put me out of my misery.
Yeah, so I'll be looking for people to do workshops in the future if we can get them. But as far as in-person workshops, I don't know how that would work for us because that's probably going to require a separate space from the conference room, and there's that's going to be something we'd have to work out with Symmetry and or whoever is hosting us in the future. So it's something I'd like to consider, but yeah, I don't think it's something we could we'd have to put a lot of thought into it, I think so. And by the way, we are now officially in the Q&A session, so the talk finished for me. So, and since I'm in charge, that means it's finished, and so we get the Q&A session now. So, any more questions for Brian? I think it's pretty safe assumption that the questions aren't going to be about your talk that you just gave, but about the upcoming workshop. So, are you okay giving away spoilers?
Sure, and I think you mentioned a couple times I will be monitoring chat for the duration of the workshop.
Yeah, so let's let me talk about that. The workshop, he gives you homework. All right, so if you're watching it in the live stream, I'm going to show it right here in this live stream. I'm going to replace the Jitsi window with a YouTube window, full screen, running the playlist, and so you can watch it. Episode 1, episode 2, all the way to episode 15. So you're probably not going to get any work done if you're watching it this way. But it's there anytime you want to go and learn how to write an 8080 assembler. But now is the time to watch it and soak in the information. And Brian's going to be available for questions. So now's the time to watch it for information from Brian. So what was I going to say? It completely flew out of my head. I was about to say something before I said this. Okay, but Mike, I'll go ahead and ask Mike's question while you're answering that. I'll try to rewind. Great introduction. Have you incorporated D in any of your university teaching?
So that's a really good question. So in the formal classes, no, although I do teach a web science course every spring, so actually coming up in the next semester. And because of some new initiatives we've been doing at RPI, I actually found myself with an extra day that I didn't plan on having and have not had in semesters past. So I was thinking of doing interesting other things that exist in the world of web science and maybe demoing Vibe or something like that, which is one of D's network and web handling libraries. But I do use D in research, like I kind of mentioned at the very end. So I do have a kind of a multi-compiler project coming up with a bunch of students next semester, and DMD will be part of the mix. So looking forward to having students come in future DConfs and tell you all about their research they've been doing using D.
That is awesome. Adam, excuse me. Adam says, have you seen the Ben Eater videos on YouTube? I found myself asking how the hardware actually did a few specific things recently, instruction decoding in particular, and those actually demystified it.
Yes, I have seen those. I'm sure his video series was one of the kind of in the back of my mind inspirations for this workshop. I think they're great. Both his breadboard video, which I think is based on a book, and then he also has his was it 6502 series of videos as well. Both are great. Both series are great.
I've never heard of them. Ricky has a question here. Perhaps a project for your students could be to refactor DMD BE. Did you mean the BE, the back end? You didn't mean FE, and contribute documentation?
Yeah, so documentation is always a good thing. Well, I don't know how much I should spoil my future research. But I will say that we will be looking into DMD's code generator and seeing if there are potential security things that can be exploited through the code that DMD generates.
Oh.
So there might be some back-end work being done over the next couple of months.
That sounds interesting. Now, I just wanted to make sure you weren't didn't have a typo there, Ricky. Yeah, DMD. Yeah, I don't hear people talking about contributing to the back end very often. So, Walter, that would be fun.
Good. I'm glad you think so, Walter.
Yeah. So cool. Yeah. All right. Keep the questions coming. What was the okay. He says, though, I'm not sure how that could be a security issue.
How what could be a security issue?
The code generation, I guess.
Oh, because if the code generator issues instructions that are easy to exploit ROP gadgets, then libraries built with D can have ROP chains built against them, which would require some refactoring and rethinking of what instructions are generated. For example, that's just one example.
Okay. So I want to get back to the workshop. Did you I assume you developed the whole assembler beforehand.
Yes.
But it looked like you changed some things midstream while you're recording.
Probably.
Okay. So what was the was this like a boring task for you implementing this assembler, since you've already done it before, even though you were different?
Boring? No.
Okay.
Right. Everything is a new challenge. Right. And again, I was really challenging myself to show off as many beginner friendly pieces of D as I could fit into to that assembler. Kind of where the changes came in were, I had the finished product in front of me, and in my head I'm thinking, well, I can't do that part until later on. So one thing that I almost kind of flubbed on was having the parser do string handling before we ever talked about the DB instruction. So I actually had to kind of remind myself mid-recording, don't copy this part, pretend that part's not there. Do the everything else part, and then at the very end we'll go back and talk about string handling. So any kind of seeming changes were either something that was probably either too complex in the original assembler and wasn't needed, or reminding myself kind of in real time, oh yes, I should hold off talking about that thing until we actually introduce the part where that thing becomes relevant.
Well, hopefully I didn't introduce any errors when I was editing, because I didn't have time to review the edits. But
me too. I'm convinced for at least one of the parts I gave the wrong episode number.
Oh,
but
I didn't catch it if you did.
I don't think that's the case, but I tried really hard to make sure that I always began every video with what part it was.
Right.
And I think I did it in order from 1 to 15.
I'm pretty sure you did. I don't think, I don't remember hearing that. I mean, I saw a couple of places where you backtracked or repeated yourself a few times, so that I just, I edit it out, cut things down, trim things down. But I'm just hoping, sometimes when I get into the zone, when I'm doing my edits, I sometimes get a little too far into the zone and make the wrong key presses. And I usually always catch it and get the, I do the undo before it goes. But hopefully I didn't do anything like that this time. Yeah. DMD ARM would be nice, says Steve.
Yeah, DMD ARM 64 would be nice. I agree. In the back of my head, I have thought about if we could set up DMD to output code for the QBE backend, which is a tiny little backend written in C, which can output x86 64, ARM 64, and RISC v 64. I don't know exactly how I would do that. I'd have to look more in the back end. But that's kind of been on my, if I had an infinite amount of time and no job to have to do, that would be one of the things I'd look into doing.
Adam says he's far behind he's just watching, he's about 10 minutes behind where the video is, but he's saying in the talk, you said, how do you pronounce your university name? Rensselaer?
Yeah, Rensselaer.
Okay, Rensselaer. As in New York, down by Albany. That's not horribly far from me. It's about a 3-ish hour drive, he says.
Oh, well, do you want to come up and talk about D to my students?
Oh, there we go. And it's on. Yeah. Yeah. Let's see.
I am not shy and I am not shameful.
Well, it would be good to have Adam come talk to your students, I think. Walter says it would be great to have another who could do major work on the back end. And he's not shy either. Any more questions for Brian? Ricky says just buy a tank of milk for Adam and he'll go. Yeah, beer conf for Adam is milk conf. He calls it. Yeah. So, okay. Yeah, he says not in the winter, but maybe someday.
That is fair.
Yeah.
We did get a whole bunch of snow over the last week, and I'm sure we will get plenty more over the next couple of months.
And apparently there are a handful of D programmers in the general radius. So
interesting.
Yeah. And
maybe we can have a DConf at RPI in a year or two.
Hey. Live stream any live coding teaching done for the students if possible, says Hegpets. Mike Shaw says lots of us in the Boston area and growing. Anybody want to import yourselves to Korea? Or export yourselves, I guess, expatriate. Yeah, we've just lost some D programmers from Korea recently, so we could get some more back in. Questions for Boston. Questions for Brian about the talk, about the workshop. Keep them coming. Ricky, Mike, Adam. Did I forget to add anybody to the list? Okay. So, how many hours a week do you teach?
So I teach a 3-3 schedule. So it's, what is that? That's 12 hours in the classroom a week, plus office hours, plus research, plus everything else I do on campus.
Right. So you spend the better part of your days on the campus then?
Oh yeah, no, I'm there every day. I'm always busy doing something. And if it's not directly class related, it's probably research related or any of the other number of job duties that I have on campus. But keeps life interesting.
One thing I've been fortunate in my teaching career has been that I'm just completely freelance, and so I had an agent. Actually, they actually have agents for English teachers here who send you to companies. So corporations, Samsung. I'm talking about the big guys: Samsung, Hyundai, wherever. Mostly teaching executives and management, that kind of thing. And you get to pick and choose your schedule. And if I want to, if I work, 8 hours a week, I work 8 hours a week, and that's it. It's a lot of fun. But these days, that stuff's behind me now, and I'm just independent. I just have these people I know that I've built up relationships with over the years. I'm not working with an agent anymore. But I don't know. I've been doing this so long. I don't know if I could be tied down to a single office or a single school in any kind of job like that. Do you? I guess you enjoy teaching quite a bit to keep doing it.
Yeah, no, absolutely. I mean, I enjoy the student, right? They make it fun. They really do. And I know some of them are going to watch this and then tell me that they heard me say this. So I guess I'll have to deny it when they say that to me, that they've watched this. But no, I mean, they do. They genuinely make the job exciting and interesting and fun. I tell people all the time that, like, being a college professor can be tough. Like any job can be tough. And it sure takes a long bit of your life before you're considered qualified to do it. Right. In my case, getting a PhD. But I wake up every day and I get to go have fun and teach the people who are going to do everything I do better than I could ever dream of doing it. And so I know I'm going to put, that little sliver of the world in good hands, when my time is up.
Well, I do miss the classroom. The classroom was so much more fun than sitting around a conference room, with a handful of people. But trivia. Okay, this question's, I know the answer to this, and I don't know if anybody else does. Trivia for what acronyms mean in Korean companies. What does LG stand for? And it's not life's good. I know what it means. Anybody want to take a guess? LG. Lucky Gold Star. Yeah. Actually, it used to be, there were two companies merged. One of them was called Lucky. I believe the other one was called Gold Star, and they merged into LG many, many years ago. Not Lucky Gold, it's Lucky Gold Star. Yeah, I'm pretty sure of that. If I'm wrong, I'm not
Wikipedia
wrong.
will tell you.
I'm not wrong. Walter asks, what's your PhD in?
So my PhD is in actually a discipline in the social sciences and humanities called Science and Technology Studies, which focuses on kind of the social development and social issues surrounding science and tech. And my particular specialty is in tech.
Somebody had lots of audio tapes from Gold Star. Oh, Alexander, interesting. I didn't know they had audio tapes. Questions for Brian about the workshop? Walter says it sounds fun, your major. I've never heard of that. Or your PhD, not your major, your PhD.
Yeah, no, it's I mean, it is broadly globally popular, but it's not, it's never going to be as popular as computer science or physics or, the ones everyone thinks of off the top of their head immediately. But it is globally known and popular.
Yeah, the group I'm associated with at Yonsei University that I do all the editing for, they are focused on city revitalization. And that's something I didn't even know was a field of study. But they have a test bed in the southern part of the peninsula, and they've taken trips to Chicago and New York to study work that's done there. But I'm always amazed, not amazed, but I'm always interested to hear about all these different fields of study. People are getting their PhDs, and I'm always amazed. The amazing part is that people stick with it so long.
It's a war of attrition.
Yeah.
having done it personally, it's a war of attrition.
Yeah. I wouldn't have the motivation or the patience for it. Any more questions for Brian? We've got a little bit more time left before I'm ready to call it. So I'm running out of steam over here. So sorry I'm not more entertaining.
No, but thank you for all the work that you've done over the last, well, more than just 2 days.
Yeah.
You know, the whole thing, top to bottom.
Thank you. Yeah. I'm glad everybody continues to contribute to this. You know, it was something we organized at the last minute 2 years ago, and I didn't expect that people would keep contributing to it. So thank you for contributing. Walter asked, have you looked at Dee's inline assembler?
I did only enough to complain to you one time about if you could implement the GCC extended assembly. And you said it sounded like a good project for somebody else. And I have not gotten around to it after that.
And Steve, that actually is an accurate description of me, because when I was in the Army, I was in the 2nd Infantry Division as a medic, but we were the Warriors, the 2ID Warriors. So. Any more questions? All right, while we're waiting for some more questions, you want to give us some parting thoughts?
Well, I hate to say D is the best language, since I think I've heard that line before.
You might want to check with Robert about trademarks.
So I suppose I'll go with what I said before. Put me out of business. Put me out of my misery when it comes to these workshops. Not that I'm not happy to do them. I'm always happy to do them. But the community will get a lot more out of it, and will be much more successful in attracting new people if that's something that gets spread around amongst a larger group of people. And it's really easy to do. The hardest part is sitting down and turning on the camera, as I'm sure Mike can tell you when it came to me and doing this workshop. Coming up with an idea, you probably already have a good idea. You've probably already written, a 500 to 1,000 line utility that you use. So you have the idea. How do you break it down into small, manageable chunks, and then just filming them? So if anyone wants kind of help and advice in making their own workshops, ping me, and I'll be happy to help.
Yes, and I think I'm going to keep an open line of communication with you about that periodically going forward. Yeah, and I want to thank you for actually bringing that up, spreading the word and getting more bodies in. That actually is becoming a topic of commonality among some of the conference talks we've been doing lately. I mean, Robert brought it up in his DConf talk. My DConf talk was not about that, but motivated by that, by getting more people in. And we need it. We need more people. And I'm glad to see. I didn't expect to see it in your talk when it popped up, but I was glad to see it there. So thanks for doing that. All right. So there's not any more questions coming in. So you can get an early start on the break if you want to, or hang around for a few more minutes while I pick 3 winners. Okay, we've got to get one winner from this talk, and I'll go ahead and do that right now. Rant. That text. I wish I had. I don't have my OBS set up for this right now. I wish I had this. This is the first time it's happened. Congratulations, Ricky.
I'm so honored to be the one that Ricky finally wins.
The New Zealand curse is over. So, Ricky, you are the winner of this talk. I will be in touch very soon, and let me write you down on the winners list so I don't forget. That would be a tragedy. All right, so that's the first one. Mike did not cheat. That's why I wish I could set this up. I don't know. My OBS foo is not so good right now. Let's see. What's the next one? The next one is the daily. So everybody who has asked a question today is eligible for the daily prize, and the daily prize is a $50 Amazon e-gift card. So let's see what comes up for that. Okay, the winner is Anonymous. And Anonymous, you know who you are. I know who you are. So I will email you and talk about your Amazon e-gift card. And finally, we have the grand prize, $100 e-gift card from Amazon. And everybody who asked a question yesterday and today that was answered is eligible for that. So we got several people in contention for this one. So let's see how it goes. Okay, hang on just a second. I got an error. Because I used the wrong. Okay, I see what I did wrong. All right. Yeah, that's a great way to ruin the suspense. Yeah. Two in a row for Anonymous. Congratulations. So I will email you. And so error one, says Walter. All right. So actually, it wasn't error. It was file exception. Okay. So I'm not going to end the stream. Like I said, I'm going to run the workshop videos here back to back, starting with episode 1. We're going to start that at 15 past the hour because that's what time I scheduled it for. So that's what time we're going to do it. The winner is, oops, something went wrong. So Brian, you can be here for the duration. No problem.
Yep. I'll be in the chat.
Okay. Yeah. So he'll be in the chat, ready to answer any questions anyone has. And I will be monitoring things from time to time in case anything goes wrong. So that is, otherwise that's it for this edition of DConf Online. So I hope you guys, if you stick around for the workshop, I hope you enjoy it. It's you should stick around. It's worth watching. And thanks everyone for coming. Thanks for asking the questions. I wonder if anyone has seen Anonymous and Ricky in the same room. Yes, we'll do this again next year. Depending on when our real world DConf takes place, it's either going to be, I might push this back next year into 2024 instead, depending. We might go in January or February, but we'll see. All right, everybody, I'm out. So take care. See you around. I'm going to be in BeerConf in a little bit. So Brian, thanks. I'll talk to you in the chat later on. Thanks a lot.
Hello, I'd like to welcome you to the DConf Online 2022 workshop. Something that I talked about in my talk just before the workshop, and if this is the first video that you are watching in this series, I'd recommend you go back and watch the first video, which is more of a general overview and discussion about what it is we're going to do here in this workshop. But for me, I thought it'd be really interesting to introduce D in a way that people who might be new to coding, let's say you only know Python, let's say you've only been coding for a little bit, could learn something interesting about a brand new language, maybe their first compiled language, and walk away with a real, tangible, complex, and interesting and explainable piece of software. And something that have always been interested in is what I call programs that create programs, right? This kind of meta idea, right? Programming can solve lots of problems for us, but what if the problem that we're looking to solve is actually the business of writing programs, right? And there's many tools that we can use for that. There are text editors, IDEs, but there are also compilers and assemblers. And I've also been real interested in retro computing for a long time. I grew up with Z80s and 6502s, and so I thought it would be really nice for us to sit down together and kind of work on and produce a real working Intel 8080 assembler, right? Because if our assembler works for the 8080, it will also work with the Zilog Z80, and you can still actually buy those Zilog Z80s brand new from the factory if you so want to. All right, but let's sit down, let's think about it, let's talk about it, and let's get ourselves coding. So I have a couple of screens up here. I'll kind of have them up throughout the workshop. On my left here, I have my terminal, and just to kind of say hello and show you kind of what platform I'm on. One of the nice things about D is that it's very, very cross-platform. So I'm on OpenBSD. You can be on anything, Windows, Mac, Linux, another BSD. This code here will work on any platform. And on my right here, I have up a Firefox window, and whatever interesting thing that we're working on at the moment, I will have up here so that we can talk about it as well. So I also have in here just a quick makefile and general assembly file. Because ultimately what I want to be able to do is I want to be able to run this code. And it turns out that I do in fact have an 8080 emulator called TNYLPO, but if you can see here, if I try to just feed that assembly file into that assembler, we get a complaint that the command file name must end in .com. That makes sense because it needs to actually be an executable file, and this assembly file is not. So we're going to do the work together to convert this assembly file into the actual executable file needed to actually see the hello DConf Online 22 message printed to the screen. All right, and I also have a quick make file just so I can just run make real quick and it will process. We don't actually have a complete program here, so at the moment it complains to us, but we will fix that in due time. One other thing I'm going to do real quick is just set my vimrc to kind of what I like for D programming. All right, so let's go back to our file. And the first thing that we always need to do in D, like we would in C or C++, is to come up with a main function. So I have to say all good things start with a single function. All right, and in D, you can either have things return void, as in not give you a return value, or you can have things give you a return value. I like for assemblers to have my assemblers give a return value at the end, because we could, in theory, take this assembler and make it part of a larger kind of pipeline with a compiler, possibly a linker, and that way we can detect in that pipeline whether or not our assembles were even successful. Because if they're not, there's really no reason to move on. Another interesting thing in D that you might be used to in C and C++, but it's handled a little bit differently in D, is that D only takes one argument for its main function. In C and C++, they take two. In D, they just take one, which is an array of strings. So let's ask ourselves some questions. What does our assembler actually need to be able to do before it can start assembling? Well, the first thing that makes sense for me for it to be able to do is check to see how many input files we give it. And I want to make sure that the user only ever provides one input file. Now you could, right, as your own kind of improvement and enhancement on this assembler, find ways to make it process more than one input file at a time. But for us, I think one input file is going to be more than enough. So we can actually say, hey, program, args, being an array of strings, will have a length. And that length is equal to the number of actual arguments, the number of actual strings in this array. And so we can say, if the length is not equal to 2, then we'll just error out with a nice message showing us how to actually use the program. And so that's going to require us to come up with a new function called usage, and we'll say print this if we didn't provide a valid input file, then we quit the assembler. And we can say int usage, and usage doesn't need to take any arguments, so we can simply leave the arguments empty. And we can say we want to write a line, and we want to actually tell the user how to use the program. So the way you use the program is you say A80, which is going to be the name of our program, and then we say file.asm. And then we can say return 1 or something like that. WriteLine, for those of you who have used, let's say, C or C++, is pretty analogous to printf, but it is going to require us to import standard.standard.io. Right? And import is the way that we bring in functionality from either Phobos, which is the D standard library, or some other libraries that we might have available. I'm just going to be using Phobos for this particular program, but if you had other libraries, you can also import them with the import statement. Another really interesting thing about D is that there are lots of different ways to express yourself. D is a highly, highly expressive language. And one of the things you can do with WriteLine is you can specify where you want your output to go. So if you don't put anything, it automatically sends your output to standard out. But since this is an error and traditionally you want to send your error messages to standard error, we can say standard error.WriteLine, and that'll say, hey, do your WriteLine call, but send the actual output to standard error. And now we can detect if the user has put in the correct number of arguments. And if they have not, then we can show them what to do instead. And then that user can fix their invocation the next time. Next thing we're going to want to do is create a new input file object. And we're going to declare this at the moment, but then we'll kind of come back to it in the next video. I'm going to try to make all these videos relatively short so that you can kind of follow along at will, and it's not going to overwhelm you any particular video. So we're going to make an object called input, capital I input. And for now, we're just going to say new input, and we're going to say args1. So this will, when we write the code, create a new input object. It's going to give that new input object an argument, which will be whatever the file we put in was. And we'll see that when we create these input objects, part of what we will do is we will read in the source file that we gave on the command line, and we will break it up into individual lines and store all that in one big object, and then that object can just hold all of our source code for us. The next problem we're going to need to solve is we're going to need to come up with some name for the output file. And it might be really neat if we could make the output file have the same name as the input file, but with a .com ending. And so there's this really handy function here called find split that you get for free in the D library, but it does require us, we can see here, to import standard algorithm. So I'm going to go ahead and do that as well. I'm going to say import standard.algorithm. And the command, the function is called find split. And what find split is going to do, it's going to read in a string, And it's going to search for whatever it is that we have asked for as the argument to find split. And then it's going to return to us 3 different strings. Hopefully, if we put in something that actually has the string that we're looking for, it will return to us the string prior to the thing that we've looked for, the thing that we've looked for, and then whatever is left in the string afterwards. And another interesting thing about D is that you can set auto as your type for your variables, and D will automatically figure out what the correct thing to use for that variable is. I think you actually need it for find split because the find split's interesting. It returns 3, an array of 3 strings. So we can search for that .asm ending. And so if we did in fact put in a file that ends in .asm, we should get back 3 strings. One string should be everything leading up to the .asm. The second string should be .asm itself. And then interestingly, the third string should just be empty because there shouldn't be anything after the .asm. And we can actually search for that. So the 3 strings we get back will be split index 0, split index 1, and split index 2. So we can say if split index 1 is not equal to .asm, or split at index 2 is not empty, there actually is just an empty method that you can call on strings to see whether or not they have anything inside of them. If either of those things are true, then we probably didn't put in a file.asm formatted file name. So once again, we can just say return usage, right? Teach the user how to actually use the assembler correctly. All right, and then we will need to create a new object, or output object. And again, we're going to cover our objects in the next video. So for now, we'll just say output output. So we'll have an input object and an output object, and we'll just say new output. And our output objects will have a file property, which will be the file name. And the file name then must be split 0 concatenated with the .com extension. Again, split 0 will be everything before the .asm in our file.asm input file. The tilde character in D is your string concatenation, so I can just say split and then .com. And then lastly, we need to actually do the work. And so to do the work, we will put everything into a try catch block. And then inside the try block, we will say assemble, which will be kind of our main processing function, and that'll take our input object and our output object. And that's really all we need. However, if something goes wrong along the way, we can throw an exception, and that exception will be caught here. And we can use the same trick. We can say standard error dot writeline, and then we can give an error message. And that error message for us will be the name of our program, A80, and we will concatenate that with the line that we're currently on in our input file. So our input object will have a method or property called line, and that will just return whatever line number we're on. And then we'll actually print out the message itself. So in the exception object, there is a property called MSG, which will be the actual message. And then we'll say return 1. On the other hand, if everything works, then we can just say return 0. And that's really all we need to kind of control our assembler. One other thing that we will need is we'll need standard dot conversion for this, this 2 here. So this 2 is also really powerful. We can give it something of any type. In this case, line is going to be some sort of integer, probably an unsigned integer. And we can just say convert it to a string. And then we're going to concatenate all the different string pieces. Right? And that is really it. So we're going to save our work. We will set up a Git repo so that we can save our work and make sure that we don't lose anything. We'll say git commit, or sorry, so first we'll say git add, then we'll say git commit, and we will say begin work, wrote a main function. And that's all for part 1. So join me again for part 2 as we continue on our journey to write ourselves a easily understandable and followable Z80 Intel 8080 assembler.
How can I help you?
I'm looking for a laptop with internet like, and not like, oh, I'm so tired, I'm gonna.
Okay, welcome back to part 2 of our workshop. So for this part, I thought what we would do is create our input and our output objects, because we're going to be using these all the time throughout the lifetime of our assembler. And they're going to be the data structures that will hold a lot of the really important info that we are working with throughout our time actually taking source code and assembling it into binary code that our Intel 8080 Z80 CPU emulator can actually understand. So the first class we're going to write is our input class. So this class represents our input, and we'll say input is a source code file. So to create a new object in D, we just say class, and we can say class input. What things actually need to go into our input class? So if input is going to represent a source code file, well, it'd be really important for us to actually think about what a source code file is, or maybe what would be easiest for us. There's a couple of options that we could pick here, but I think there's one option for us that's going to be better than the others. So one option would be we just read the whole file in as one big long string, and then we worry about it later, right? So we could say string, and I could say, I don't know, code, something like that. But I'm not sure that that's the best approach for us, and that's the best approach for processing assembly. Because if we think about what assembly actually is, unlike D, where you could do something like you could say, let's say write line, and then we can put a new line, and then write our string, and then write another new line to close our string. And everything from the write line to the semicolon gets interpreted as one piece of code. In assembly, the way it works is every line itself is by itself. Every line of code is kind of its own thing that you process. So the new line at the end of the line is actually what terminates our input in assembly, unlike in D where it tends to be that semicolon and you can cross and span lines. So if it's the case that we only need to process a single input line at a time, then for me, I would think for us, it might be better to make our input an array of strings, where each string is its own line of input. Because then as we read and process our input, we just need to process one line at a time, and it's already kind of pre-split for us. So we don't have to do the hard work of saying, okay, well, did I get to a new line yet? No. Okay, then I need to keep reading. We can just say whatever it is I'm currently working on must be a line, and therefore I just have to worry about processing this line. And when I'm done with it, I can go on and fetch the next line. So we'll just call it lines, but we'll make it an array of strings. And the other thing that I want to make sure that we remember is I want us to remember what line that we're actually on. If you remember down here in our error handling, we say input.line, right? Line being a property of the input object. And that's going to remember for us what line we're actually on. So that way, if the user does have a mistake in their assembly code, we can do more than just say, hey, there's an error here somewhere. We can say, hey, here's the error. It's on line, whatever line it happens to be on. So I think the ulong storage object is going to be the best thing for our lines, since in theory, a line will never be negative. If we have a negative line, something has probably gone wrong, and ulong can store a unsigned 64-bit number, and I'm pretty sure there's no way that anyone can write an assembly file that would be that many lines long, so it's definitely going to be big enough to hold whatever source code we throw at it. Okay, so we have our lines, and we have our line, right? So we can remember what line we're actually on. One more thing that I think would be really interesting and useful for us in our input object is to have some sort of constructor. And we kind of gave it away in the previous episode where we actually gave an argument to input, and that argument is the file. Why not? Whenever we create an input object, we just have that input object as part of its creation, read in a file, and create an array of lines, right? Because we already have that lines array declared there. So the way to write a constructor for your D objects is this. So this is a special method that will be called whenever you create your class. And that's going to take one argument, and that argument is going to be the file name that we gave it. And so what is it that we actually want to do? Well, we want to read in that file, and we want to be able to process that file into its individual lines. So there's actually another very handy dphobos library function called splitlines. And so we will need to import standard string for this. And what splitlines does is it reads whatever you give it and then splits whatever you gave it into an array of lines according to the Unicode standard using the different new line characters that exist, which is great. That's exactly what we want. So we're simply just going to read in the entire file as one big long string, and then allow split lines to do the work of splitting up the file into the individual assembly lines. And that way we don't have to do any work worrying about where our new lines, did our line end, did it not end. It's already taken care of for us when we built this input object. So that's really easy. We can just say lines equals, and then we can say split lines. And you might be tempted just to say read file, and read is the function that we would use to read in a file. I know ahead of time it'll actually give us the complaint. It will ask us to cast that into, in this case, a string. So we'll do that. We'll say cast string, read file, and that is all you need to do to read in a file and split it up into its constituent lines. Virtually no work, which I think is great. And I think we're done. I think that's all we need for our input object, right? Because an input object is just representing our source code. It's just an array of lines, a variable to remember what line number we're on, and a constructor so that when we build our input object, we can feed it our input assembly file and get back our handy array of lines. All right, next thing I want to do is build our output object. And it seems like I got a message on my phone, but we'll just keep moving on. So we'll say output is a symbol table and a final executable. And if you're not sure what a symbol table is, don't worry, we will talk about it quite soon. So I am going to start by saying, okay, so what things do we need in our output? So our output is going to store whatever our binary code is going to look like at that given point in time. There really is not much of a reason for us to print out our final executable one line at a time. Let's save it all in memory, and then when we're done, we can spit it all out at the very end. And that way there may not be any like half-assembled file sitting around someone's file system if they wrote an incomplete or incorrect assembly file. All right, so what is an executable, or what is a binary file? Well, I think it's just an array of bytes, right? Because fundamentally, that is all that all of these programs are that we're running. They're just an array of bytes, and I'm going to make them an unsigned byte array, right? That way, just a byte from 0 to 255, just some sequence of bytes from 0 to 255 is going to write a valid executable. What else do we need? Well, one thing that we need that we might have remembered from our first episode is that we need a file name, right? Because we actually do write a file name here. So we are going to need a file property of some sort. So we'll go ahead and add that too. We will say string file, right? Because a file name is just a string. And for now, that might be the only things that we need. But one more thing that I'm going to want to write for right now, just because I know we're going to need it at some point, so we might as well just take care of it now, is we need some sort of function to actually write out the output at the end. So I'm going to make a method called write, and there's actually a couple of different writes that you have available to you. So there's one in standard file, there's one in standard IO, but we want to make sure we want to use the one from standard.file. So you can actually write import statements directly in your functions. So I can just say import standard file, and I can say from standard file, I only need here the write function. I don't need anything other than that. And now when I say write and give it its arguments, then it will know to use the write from standard.file, which I think is actually pretty neat. One thing that we will need up here as well, since we have a read, we will also need a standard.file up here. And that's it for now. That is going to take care for now of our two main objects. So I'm going to go ahead and save our work. I'm going to go ahead and commit our work, create input and output classes. And we'll call it here, and I'll join you back in the next episode.
잠자는 퇴직연금을 깨워라! 연금 투자 시대 신한은행 퇴직연금.
유산 기부 어린이의 삶에 날개를 달아줍니다.
Okay, welcome back to part 3. And in this part of our workshop, let's go ahead and write that assemble function, right? If you remember, we had at the very end in our try catch block, we had this assemble function. So let's go ahead and write that. So what is this assemble function going to do? Well, it's going to be our control function. It's going to control the work of assembling. Not that there's going to be a whole lot of work to control, but it's good to have that all, I think, in one place. Helps us more easily remember where it is and what we're actually doing. So assemble is going to take two arguments, right? It's going to take our input and our output classes, our new objects that we created. And so we come actually up to a really interesting problem for really all assemblers. If we read through our assembly, it is possible, and I'll pull it up here. So we have these labels here on our left-hand side. Well, something that's really interesting, something that we actually see here is that if we have a label and we write the label, and then later on in the code we call the label, then that's fine because we've actually declared the label, and then after we've declared it, we've called it. But if you notice here with this message label, we're actually using message before we've declared it. So we have this really interesting catch-22. How can you use something before you've declared it? If you ever coded in C, in particular C or C++, and you have written a function and you had forgotten to declare it, you'll get a nice error message saying that you're trying to call a function before you've actually declared it. D is really nice in that it's actually going to do the same trick we're going to use here. So D is actually going to know what all of your functions and all of your labels are before it starts doing the work of compiling. But we need to do the same trick here in assembly. So traditionally, assemblers are what we call two passes. The first pass is we're just reading through the code, and all we're looking for is our declarations of our labels. And we're going to remember what address each label is at. And then through the second pass, that's when we're going to actually do the work of assembling our instructions into binary. And in the second pass, because we already know the addresses of our labels from the first pass, it's not going to matter that message is used before it's declared, because we've already gotten that information. We already know that information during the second pass when we're actually using it. So that's really the traditional way of producing assemblers, this two-pass methodology. Again, D is really nice in that it's also going to be doing that. So if you notice, I don't ever declare any of my functions. We don't need to. D is going to collect that information for us before we actually do anything useful with it. All right, so we'll say we need 2 passes for our assembler. Pass 1 collects addresses for symbols. Pass 2 processes assembly into binary code. For each pass, we need to parse a line and perform the work. So what I'm going to do here is we're going to need to have some sort of variable that's going to store which pass that we are on. So the question becomes, does it make more sense to put things in the input object or the output object? I'm not sure it matters all that much, but just for my thinking, I am thinking of remembering what pass we're on as part of the work that we are doing to create our output file. So I'm going to put pass inside the output class. You can choose to agree or disagree with me on that determination, but that's what I'm going to choose to do. And so no matter what, for each pass, the first thing we want to do is reset what line that we are on, right? And lines always start with 1. There is no 0th line. We're going to start our lines at 1. But we don't want to have a case where we find an error in the second pass and we end up spitting out a line number that's twice as large as the actual input file itself. So we just need to remember to reset input line to 1 at the beginning of each pass. And then we can use the for each loop, and we can say for each line in input lines. And you'll notice I did not previously specify what a line is. D is going to just know what a line is, and line is going to be a string, right? Because input lines, as we remember, is an array of strings. So we can say for each line in input lines, the first thing I'm going to do, and it may not make much sense now, but we will see when we get to our parser, is I'm going to put a null byte at the end, just so we have some sort of character at the end of all of our input lines that we know can't possibly belong to anything that we wrote. And we'll see kind of how that comes in handy when we write our parser. So what's the next thing we have to do? So for each line, well, there's a couple of things we have to do. So first, let's take a look at what a line actually is. So a line in assembly can be, well, in this case, totally blank. It can have nothing in it. It can just be a comment. It can either have a label, or in this case, not have a label, or have a label. It has some sort of instruction. Some instructions don't take any arguments. Some instructions take 1 argument, and some instructions take 2 arguments. And then they may or may not have a comment at the end of their instruction. All right, some do, and some don't. So with that in mind, we're going to sort of impose what a assembly line can look like. So I'm going to say an assembly, or I'll say a line of assembly is 1, an optional label, 2, mandatory white space, 3, an optional instruction, and then optional comment. And so we can actually use this kind of predetermination of what a line of assembly is to kind of help write our parser a little bit, but also kind of have us think now about what it is we need to do. If a line of assembly is a label, an instruction, the arguments to that instruction, then we need to find a way to split the line that we currently have into those different parts, where those different parts are a label, an instruction, and its arguments. So we need to essentially break these down into kind of a smaller unit of work, which we're going to call tokens. We're actually going to create a new class for this, a tokens class. We'll worry about it in the next video. But for now, we'll say tokens equals new tokens. And just like we do with our input, With our tokens class, we're also going to feed it a line. So when it gets constructed, it will parse that line into its tokens. And that way, the parser itself will actually become part of the tokens class. And then we'll need to process those tokens. So we'll say process tokens, and we'll probably need to deal with our input and our output as well. So we'll make all three of those things arguments to our process function. And then after we process things, we'll need to increment our line number, since we will now have the next line to worry about. If we have been totally successful out of all of this, and that means we have completely processed and assembled our input into output, then we can go ahead and write our output, which is why we wrote that output method in the output object in the previous episode. And that's really all we need. That's all the control work we need for our assemble function. One thing you might be asking to yourself is, well, wait a second. Why do we have to process each line into a token twice? Can't we just remember the tokens of each line? And the answer to that question is yes, you could. But one of the things that I'm trying to go for in this workshop and with this code is kind of making it kind of a stretch enough for someone who might be brand new to all this stuff to still be able to follow along and be able to walk away from this with not just some code that they wrote that's interesting, but the actual capacity and ability to explain that code to their friends. That's kind of the goal that I'm trying to reach here. And so while you're right, we could save everything, and that way we don't have to parse things twice. It would be more work to have to save it somewhere and then refer back to what we saved. It is going to be true that if we successfully parsed our lines in pass 1, we will again be able to successfully parse our lines in pass 2 because we're not modifying the lines. We're just parsing the lines, but we're leaving the lines intact as they are. So because we're not modifying the input lines at all, if we're successful in parsing them once, we must be successful in parsing them twice. And we'll leave it to our process function to determine what to do depending on which pass that we are on. And that's really all we need to do here. So I'm going to go ahead and save our work. I'm going to commit our work. And that's going to be it for part 3. And see you again in part 4.
공부도 운동도 둘 다 잘해야 진짜지. 지역난방처럼.
Welcome back to part 4. I think this part will probably be the single most difficult part that we are going to work on together. So what we're going to do in this part is we are actually going to create our tokens class. And this class for us is going to represent a set of tokens parsed from a line of code. And so actually inside of this class will actually be our whole parser function. That way we don't have to write a separate parser function, and we kind of do the work of parsing each line into tokens as we read in each individual line. So we don't really have to think about it. We just say, create me a new tokens object, and we just know that that tokens object is going to have the tokens that we want to work with. So like we mentioned before, if we just quickly, once again, look at our assembly file, the maximum number of interesting tokens that we can have would be 4. So we can have a label, we can have an instruction, and then we can have 2 arguments. We're not going to make comments into a token. There's really nothing that we can do with comments when we write out that executable file. We're not going to put any like debugging information or anything in to our executable files. So 4 is really the magic number for us. So because what we're working with is strings and we're really just kind of parsing out substrings, the actual things we're going to be storing themselves will be strings. We'll have a label string, we'll have an instruction string, we'll have, I'll call them first and second for first and second argument strings. The next thing we're going to need is an array of all valid Intel 8080 instructions. And I happened to Google Intel 8080 instruction set, and I got back this very handy page at pastrazor.com, which has a table of all of the valid instructions. And so I cheated because it would take quite a long time to write them all out. I went and copied them, and so here's all of our instructions. And all I did to get this array, and I made this just an array of strings called instructions, is just look at this table here, and just every time I saw a new and unique instruction, I just added it kind of in order. So this is not alphabetized. This is actually in the order that they are shown here in this table. And it looks like I copied it in a way that over preserved some spaces, so I'll just go ahead and remove those over preserved spaces. Okay, so what do we need to do next? So we have our 4 tokens. The only really thing left to do is write that parser function. So we're going to say the constructor parses a line into, we'll say up to 4 tokens, right? Because there could be fewer than 4 tokens, but there definitely won't be more. So again, that's that this method, right? Which will run whenever we create a new tokens object. And like we said, that's going to take 1 argument, and that argument's going to be a line, and we can see that kind of right here. Okay, so what is it that we need to actually do? So we need to do a couple things. So we need to kind of read through the different lines. So the first thing we're going to do is say, do we have an empty line? Because if we have an empty line, then we have absolutely nothing to parse. We can say, if this is an empty line, we're done. Easiest line we're ever going to have to parse, a totally empty line. So we can say if line, and just like our strings array had a length property, strings themselves in D also have a length property. You might be used to something like strlen in C and C++. It's actually a property of strings in D, which is super nice. So we can just say, if for some reason our line length is 0, we're just going to go ahead and return. We're done. We don't have to worry about anything. Next thing that we need to do is we need to know when our tokens begin and when our tokens end. So let's do that. I'm going to start with when tokens end, because that one's a little bit shorter. And all we really need to know about whether or not they end is whether or not true it's ended or false it is not ended. So we can say, is this the end of a token? And so we'll have a Boolean, we'll call it end of token. I'm a very original function name creator. So what is the end of a token? Well, I guess it makes sense to say, what is a token? So for us, a token is going to be alphanumeric characters, numbers, maybe some punctuation, but essentially just ASCII characters. So the end of a token would be, in my mind, a space, a tab, right, our white space, a null, right, and that's how we're going to know that we're at the end of a line for sure. We'll see that null byte. But there is one other character, and that's that semicolon character, right? Because if we have a semicolon, then we must be in a comment, because a semicolon, as we saw, is our comment character. So I'm going to say, if the place we're looking at now, and I guess we're going to need some sort of variable to remind us of where we happen to be. So why don't, in this, we will say size ti, just so we remember. And I guess I'll also bring this end of token thing. I'll actually bring it into the constructor function, just so kind of logically these things all stay together. And I guess I'll reflow my comment here. Okay, so is this the end of a token? Other nice thing about D is you don't have to manually say that a variable equals 0. You can just declare it and it automatically gets initialized to 0. All right, so if the character in the line we're currently looking at is white space, which is a space, or a tab, or the character we're currently looking at is a semicolon, because then that starts a comment, or it is a null byte, which we are using as our end of line character. If it's any of those things, then it can't be part of our token, so our token must in fact be complete. So in that case, we can return true. In any other case, we should return false. Easy. But how about if what we end up having to worry about is what is the beginning of the next token? So we can do something very similar. We can say, get to the start of the next token. And so again, this can be a Boolean. We just want to know true, false. Are we at the next token? There are two things we need to check to know whether or not we have any more tokens on this line. First thing we need to know is, are we at the end of the line? Because if we're at the end of the line, then there's simply no way that there can be any more tokens. We're at the end of the line. The other thing is we can also do an end of token check. Because end of token check includes that null byte, and because there's no rule that says you can't have white space or a comment or white space or a null byte at the end of the line, we should check all of those things. So while we have not reached the end of the line and we currently have either a white space character or something like that, we should be able to say, keep moving forward, right? Because our white space characters will be what separates our tokens. We also want to detect if we've hit the end of the line. So if it's the case that we have not reached the end of the line and we're currently pointed at some sort of white space or some sort of end of token character, we can say, move to the next character. But there's actually something we need to do before that. We need to say, if what we've seen is a comment character, then we can just say return false. Because it's true that if we see a return character, the whole rest of the line will have no more valid tokens. It'll just be a comment. So that kind of takes care of that. We can also say, if I is equal to line length, or we saw that terminating null byte, we should also return false, because we'll also be at the end of the line and therefore there are no more tokens to go to. In any other case, we want to return true. In any other case, it'll be the case that we're at the beginning of another token. So that's really it for this episode, and then we'll go through parsing in the next episode. Special case for if we have an empty line, we're just done. We need to know what the end of our tokens are, because we need that information to know when we've hit the beginning of the next token or we've hit the end of the line. So let's save it. Let's commit it. We'll say next and end of token functions. Beginning of parser. And with that, I will see you back here for the next episode.
콘텐츠가 숭 자격증을 쏴 어디서든 숭
Okay, welcome back to part 5. So in this part, we're actually going to do the heavy work of writing the parser. And then while it might seem like a somewhat daunting task, it's actually pretty straightforward. We're actually just going to kind of reuse the same logic over and over and over again to write our parser. So as we mentioned, there are really kind of 4 things that could exist in a line of assembly, right? We have a label, we have an instruction, we have comments, we have white space, but it's a little more nuanced than that. So there's really kind of 4 different tokens that we mentioned, right? A label, an instruction, and potentially a first argument and a second argument. And they will present themselves in that order, so we should process them in that order. So the first thing we're going to do is get a label. Now we don't know if we have a label yet, so we'll have to detect that. So the way we're going to detect that is to say, if the first character of a line is not a space, and the first character of a line is not a tab, our two white space characters, then we must have a label. And so we're going to need some sort of variable to represent the end of that label. So I'm literally going to name it nLabel. Like I said, I'm a very, very creative variable namer. One of the nice things about D is I don't have to say equals 0. If you just declare a variable, it automatically will get initialized to 0. Nice and safe. So what we need to do now is we need to write a for loop to iterate over our line and to stop us whenever we've hit what must be the end of the label. So that could be any of our end of token characters, or of course it could be if we reach the end of the line, right? If we've reached the end of the line, then it must be the case that we're done processing because there's nothing more to process. So we'll say if end of token, or now labels are a little special in the fact that you can terminate them with a colon character when you declare them. So we can check for both. We can check for an end of token character or a colon character. If we see any of those, we must be at the end of the label. So we can say nLabel equals wherever we are in the string at the moment. And then we can use a really handy feature of D called slicing, which is just to say we have a portion of the string, a substring in the string. So we can say the label must be equal to the slice of the line that begins at the beginning of the line and ends at wherever nLabel happens to be. We can then say if line I equals colon, because the colon is not actually part of the label name. It's just the way you can choose to end the declaration of a label. So if we do end with a colon, we should just increment to the next character in the line, since that's not actually part of the label name. And then we break out of our loop. And we're pretty much going to repeat this logic over and over again. So next thing we have to do is go to the start of the next token. So we can say if next, right, which brings us to the start of the next token, is false, then there are no more tokens. So we're done. We can just return. If it does find another token, then for us, it must represent an instruction. So we will say get instruction. And so we'll say the start of the instruction is equal to wherever we happen to be in the line now, which is I as our index. And then it's exactly the same logic. For no initialization, I is less than line length, I++. We're going to iterate through things, and we're going to say if we've reached the end of the token, and we don't need the colon here because you can't terminate an instruction with a colon, just any of the end of token characters. So if we've reached the end of the token, then this must be our end instruction location. And we can say that an instruction is the slice of the line that begins at start instruction and ends at end instruction. And then we can break out. And that's it. And that will get us an instruction. And then it's exactly the same logic. We'll go to the start of the next token. So if next equals false, then we have no more tokens, so we'll return. If we have more tokens, it must be the case that it's the first argument. Now, we don't know at this point if we have one argument or two, but it really doesn't matter. So we'll just say that if we only have one argument, then it's also the first argument. So we'll say start first equals I, and then it's exactly the same logic. So we'll say for no initialization, I is less than line.length, I++. That's also one of the nice things of D. Lines, strings, all your strings will have a property called length. In C or C++, you might be used to something like a strlen function, but in D, it's just a property of strings. So you can just say line.length and get the length of your string. So we'll say for I less than line.length, so same logic. So we'll say if we see an end of token character, or as we mentioned before, if we have two arguments, then they'll be separated with a comma. So end of token character or comma character, we must be at the end of our first argument. So first will just be the slice of the line that begins at start first and ends at end first. As you can see, the logic is really straightforward. Once you kind of wrap your head around it for one of these tokens, it's exactly the same thing for all of the other tokens. But we are going to end with the same thing like we did with our labels. If we happen to see a comma at the end of our first argument, the comma is not actually part of the argument, it's just separating the two arguments, so we'll just skip right on by it. And then we're going to do exactly the same thing. We will say we need to go to the start of the next token, and that would be if next equals false, we'll return. Otherwise, we'll get the second argument. And by now, I think you know what we're going to be doing. We'll say we'll have a new variable we'll call it start second. And we'll make that equal to where we are in the line at the moment. We'll then have our for loop. Oops. We'll have our for loop. And we will say if we see the end of any of the end of token characters, we will perform the logic to end a token. And by now, you should all be pros at it. It is exactly the same. This slice will be from the beginning of start second to the end of end second. And then we break out of our loop. One last thing we can do for sanity checking is say, well, at this point, we have our 4 tokens. And that's the maximum number of tokens that we can have on a line. So we can check to make sure that that's actually true. So in this case, we can say if next equals true, right? Because here we want next to actually equal false. But if next happens to equal true, then we should error out. Something is wrong on this line. And the way we can do that is by saying throw new exception and then give it some sort of error message. So I'll just say found extra tokens. That works. Exception is an object, so we'll initialize it with new. And if you remember, for those of you who are new to this throw language is the metaphor for catch, right? It's baseball or whatever other sport you like that has someone throwing a ball and catching a ball, right? So the catch catches the throw, and when it catches the throw, it prints out an error message with whatever message we put in and whatever line number we happen to be at, and then returns a 1 to let the user know programmatically that there's been an error. And that's it. That's our whole parser. So I would invite you to kind of sit with this, particularly if this logic is new to you, and see if you can parse out. You only need to do this for one, right? So pick a label, an instruction, the first argument or the second argument, parse through the logic, make sure that you understand what the logic is doing, and then it's exactly the same for all the other ones. And that's really all we need to successfully parse any of our lines of assembly. So I'm going to save this. I'm going to commit, wrote parser. And before we conclude this episode, I'll just mention that you might have seen other places where I'm making assumptions as to what our lines of code are going to look like. For example, I'm not allowing for the possibility for there being a space before that comma if we're separating two different arguments. So when things like that happen, they'll become what we'll call homework assignments. So for homework, you can think about how you might implement the ability to have, let's say, a space in between the end of the first argument and that comma. So you don't have to do it. I'm not going to do it for this workshop, but it might be something for you to think about as you grow in your skills, extra niceties to have in our assembler. All right, with that, I'm going to conclude this episode, and I will see you back on the next episode.
가까이, 더 가까이. 당신이 꿈꾸던 내일의 차이, 현대차증권.
고위험군이라면 확진 즉시 바로 의료 전문가와 상의하세요.
Welcome back to part 6. So what I'm going to do in part 6 is we're going to talk about symbol tables. So the work of part 1 is to collect all the different labels that we've written and make sure that we understand and remember what address goes with that particular label, right? Because we had that interesting problem where you can use a label before you've actually declared it, and then what do you do in that case? And we said, right, that you can have 2 passes, and that will take care of that problem. Pass 1 will simply be read in all the labels, remember their addresses, and then we can use that information in part 2. But that means we're going to have to store that information somewhere. And we're going to store them in what we call a symbol table. So I'm going to go ahead and just do a little bit of boilerplate. One thing I forgot to do in an earlier episode was to add a pass property to the output class. So I'll go ahead and do that. And then we're going to say, well, we're going to need really a new data structure to represent our symbol table. And I'm also going to put our symbol table inside our output class. So what actually does a symbol table need to hold? It really only needs to hold 2 things, right? A symbol is a label, the name of the label, and the value representing the address of that label. That's really all we need. And then a symbol table can just be an array of symbols. So I'll say struct symbol to make a more complex data structure. And we'll say string label. And we'll actually save the label name, right? Because we do parse it. We just learned in the last episode how to parse it. So we'll actually save that label name in our symbol data structure. And also say int value. And that'll just be the address. Now with the Intel 8080, with the Z80 being a 16 or really an 8-bit CPU, it can only hold 16 bits of address space. So it's only a number from 0 to hex FFFF. Int is way larger than hex FFFF, 65,536. So we don't need it to be any larger than that. Int will be big enough for whatever we could possibly need. And then the symbol table itself is simply an array of symbols. No complex data structures needed. In compiler, for those of you who will eventually go on to take courses in things like compiler construction, you may hear of linked lists or hash tables or things like that to be the data structure to store all your different symbols. We're not going to make things that complicated. We're going to use some built-in niceties of the D language to just make the symbol table just an array of symbols. We're never going to have that many anyway, and our CPUs are going to be way fast enough that really compiling even the most complex 8-bit programs are going to be basically instantaneous. Right? We're not really looking for speed here, right? We're parsing all of our lines twice. So we're definitely not looking for speed here. We're just looking for things to be correct, and we're looking for kind of a nice stretch project for maybe the new coder. Of course, that is not permission to not study your data structures, to not study your algorithms, but that's even kind of a stretch from where I want us to be with this assembler. Okay, so we have a symbol table that's just an array of these symbol structs. And we're going to now need to have logic that will allow us to add symbols to the symbol table. Now, I know it's not going to be hooked up yet, and that's fine, but we just need the logic to actually write symbols into the symbol table. So I'm going to add a new function, and we'll say it's going to add a symbol to the symbol table. And it's going to have an extremely creative name. It'll be named add symbol. And add symbol will take a collection of tokens. And we'll also need our output object because, as we just saw, we put our symbol table inside our output object. So the way we're going to add a symbol is we're first going to have to iterate over all of the symbols. So we're actually going to have to iterate over our symbol table. And again, we don't need to declare what label is. D is just going to figure out for us, which is quite nice. So for each label in our symbol table, if it's the case that the label that we want to add is the same as a label that we have found in the symbol table, then we should throw an error because we cannot duplicate symbols. So we'll say duplicate label, and we'll just tell them what that duplicate label is so that they know. That way when they go into that line of source code, they can spot the point in the code that they probably made a mistake. So that's what we're doing here. We're iterating over the symbol table with the label that we want to add, and we're saying if the label that we have is equal to a label that we find already existing in the symbol table, then we have a duplicate symbol, and that can't happen. If we iterate over the whole table and we don't find any duplicates, then we can go ahead and add this symbol. So the way that I'm going to do that is I'm just going to create a new struct with this curly brace syntax. And just like we can use the tilde for concatenating strings, we can also use the tilde to concatenate really anything. So our symbol table just gets the new symbol appended to the end of it. That's it. That's all we have to do. But one thing that we may have noticed, we have this new address thing here, which is not one of our variables inside our output. So I'm going to just go ahead and make a new property inside of our output object. And again, an address only needs to be an int because it's a 16-bit is the maximum of the address that it could possibly be on an 8-bit CPU, which is only 65536, and an int holds over 2 billion. Over 2 billion is greater than 65,000, so an int is plenty big enough to store everything that we need. And so same thing as with the previous episode. That's all we're going to do for this episode, because this is pretty important enough that it is worthwhile to pause here, read through this code. I mean, it is only 5 lines of code, but make sure that you really understand how each symbol in the symbol table is being assigned this new name label, and then the label we want to add is being compared to the current label in the symbol table we're looking for. If they're equal, then we can't have that. You can't have duplicate labels. We iterate through the whole symbol table like this, looking for these duplicates. And if we don't find any, then we create a new symbol, and I'm using this curly Q notation for a literal notation. And then we just append that new symbol to the end of our symbol table. All right, and so with that, I will commit what we had, add symbol table logic, and I will see you in the next episode.
임플란트 하면 뭐가 다른겨? 뭐가 달라도 다르겠죠. 오스템 임플란트.
Welcome to part 7 of our workshop. So this is where the fun begins. So we're actually now going to do the work of taking our tokens, figuring out what it all means, and beginning to output the actual binary that will be the actual executable that we can then run either on our CPU or in our emulator like I have here. So we're going to write a new function that's going to match the parsed instruction with the proper action. And so if you remember, at the end of our assemble function, we had this process function. And that's the function we're going to write now. We're going to write this process function. So we're going to say process takes in a set of tokens. Set of tokens. It also needs access to our output. It also needs access to our input. So the first thing that we want to make sure that we remember to do is we need one special case. And that special case is if we have a blank line or a label by itself, right? Because in that case, there would not be any instruction that we parsed. And so we want to make sure that we don't try to parse an instruction that isn't there. So we can say if tokens.instruction.empty. So we had mentioned that strings can have a property called empty. We actually use that all the way back in the beginning with our find split method. We were able to check that there was nothing after the .asm of our input file by checking the empty property of our split2 string. And we can do exactly the same thing here. So if our instruction is empty, meaning we did not parse an instruction, and it's also the case that just for sanity, we're going to make sure that we don't have a first argument and we don't have a second argument. That's probably a little bit of overkill, just the way that our parser works, but doesn't hurt to check it anyway. So if we have just empty instructions and arguments, we then need to check to see if we are in the first pass. Because if we are in the first pass and we happen to have a label on this line, then we still need to do the work of adding that symbol to our symbol table. So we need to make sure that it's not the case that we have an empty label. If we do not have an empty label, we're going to need to add the symbol. But if our output passes 2 or we don't have a label, then there's nothing for us to do, and we can simply now return. So that takes care of our one special case. Now, the remainder of what we have to do is look at what instruction we have. We need to then process that, and then we need to find the correct function that will output the correct code for that instruction that we have found. We haven't written any of those yet, but we will. But for now, we're going to say match opcode to helper function. And so again, this is going to be one of those perhaps most difficult of pieces of our actual assembler, but it's going to show a really useful and I think nice feature of D that's going to save us an unbelievable amount of typing. So if you remember, in our tokens object, we have this array of strings here. That's all the different instructions that we found in this table. It's actually not quite all of the valid instructions. It's actually missing a couple. It's missing in and out. And the reason that it's missing in and out is because, unfortunately for us, in and out are both instructions that are reserved words in D. And that would actually mess up the part of the code that we're going to do. But it's pretty easy to just work around that one little problem. Not really even much of a problem. And easy, like I said, easy for us to work around. So we're going to write a switch statement. And that switch statement is going to be tokens.instruction. So much nicer than C. You can just run a switch on a string. You can set equalities on strings. You don't need any fancy functions. It's built into the language, which is so much nicer than having to like process each individual character. All right, so what we're going to do now that we have our switch statement is we're going to say static for each. which is going to do the very same work as a for each loop, but it's going to do it at compile time. And so what this is going to do for us is it's actually going to end up creating an entire laundry list of case statements for all of the different instructions that we have up here in our array of strings. So you don't have to write, case nop, case LXI, case stacks, case, that would take forever. D can actually write that code for us at compile time, and we're going to take advantage of exactly that feature. So the way we're going to do that is we're going to say case instruction. All right, so for each instruction in our list of instructions, each instruction will get its own case, and we'll fill in, it'll replace the word instruction here with whatever that instruction happens to be, right? Whether it's nop, LXI, et cetera, et cetera. Then we're also going to use this function in D called mixins. And so if I go search in the D documentation for mixins, does it actually come up with that? Let me check the actual D itself. Mixin. There we go, string mixins. So it says string mixins enable string constants to be compiled as regular D code and inserted into the program. That's neat. There are also template mixins as well, which will take an arbitrary set of declarations from the body of a template declaration and insert them into the current context. So this mixin is actually really quite powerful, and we can use it to effectively write the logic for each case statement so that we only have to write it once, and the combination of our mixin, our string mixin, with our static for each will cause D to write out all of the cases and all of the logic that those cases will execute one shot, which I think is really, really cool. So we can say mixin instruction, and then we'll say tokens output. So what all this is going to do is during compile time, it's going to iterate over the list of all those instructions in that array. And then for each one of those strings, it will create a case with that string name. And the logic will be the string name itself, which will actually be the name of a function to be called. And then it will have the arguments like we did before, tokens, comma, output. So instead of writing however many of these case statements there are, the D language will write it for us with the combination of mixin and static for each. And the last thing we had to do is just put a break, and you can have it break back to the label we made, which was match. And I think that's really, really cool. But like we said, there are some things we need to watch out for, right? We're not quite done, right? So we did say that there is the out and in that we had to worry about. So let's go ahead and worry about the out and in. So we can't just say out as the name of the function, which is why we can't have it in our mixin, because out is already a reserved word and it'll cause compile errors. So I'm just going to name it I80 underscore out. You can name it anything, but I'm just going to name it I80 out. And we're going to do exactly the same thing for in. And I'll also just name it I80 in. And there's actually one more case that we have to worry about. There is also an end pseudo instruction, which, while doesn't have a name that's a reserved word, actually requires 3 arguments. It also requires an input argument. And we'll see that kind of towards the end of the workshop when we're done with everything. And the last thing we need to do is have a default case. So if we didn't match any of our instructions, then we're just going to throw a new exception because we've hit an error. We're going to say it's an unknown instruction. And we'll just spit back to the user whatever that instruction happens to be. And that's it. That is the entirety of our process function. Not all that many lines of code, but I'm going to say the same thing again as we've been saying for the last couple of episodes. Make sure that you really understand what's going on with this process function. Right? We have that one special case if we just have a blank line or we just have a label by itself. If we have the label by itself, we need to register it in our symbol table. Otherwise, we have no other work to do. And then make sure you really do follow and understand what's going on here with this matching function, what's really going on with these mix-ins, with this static for each, right? So at compile time, we're reading over that array of strings, which we have right here. And for each one of those strings, it's going to have its own case, right? Instruction will just be replaced by the name of the actual instruction, nop, LXI, so on and so forth. And then it's going to generate the logic. And the logic for every single one of our instructions is going to be to call a new function. And the new function it's calling is going to also have the name of that instruction. And so mix-in instruction is going to write out that function, and then it'll take 2 arguments, token, output. And then we had our 3 exceptions, right? Because out and in are both reserved words, so we'd break the logic here. And then end is just a special case where it also takes input, and we'll see why kind of towards the end of all of this. All right, and with that, I will go ahead and save our work, add process function, and I will see you all in the next episode.
차는 모르지만 차는 사고 싶어. 차가 어려운 당신. 잘 봐. 진짜 단순해. KB가 진단.
Welcome back. Welcome to part 8. And in part 8, the fun is going to begin. We're going to begin to systematically and methodically just move through the Intel 8080 instruction set and write the functions that will actually output binary code for each of those instructions. So we'll conclude today with actually implementing our NOPs, our very first instruction, because there's a little bit easier way to subdivide these, but NOP is the easiest and it's the very first instruction, so that's the one that we're going to start with. 2 interesting questions arise. One is, well, what exactly is the binary code for each instruction? So NOP would be 00, LXI is 01, stacks is 02, inks is 03, so on and so forth. The other interesting question is, how can we sanity check to make sure that an instruction has the proper number of arguments, right? NOP doesn't take any arguments. LXI takes 2, stacks takes 1. So we're going to need to find a way to check that. So I'm going to actually start by writing that kind of sanity checking function. So we'll say ensure the proper arguments are provided for the instruction. And we'll just call this function check. There's nothing particularly fancy about the naming as usual, but let's do that. So it'll take a number of tokens, and that boolean we're going to call passed, as in not failed. We're going to say if passed equals false, then we should throw a new exception. And the reason we need to send tokens in with check is because in our exception, we're going to say arguments not correct for instruction. And we'll concatenate that with tokens.instruction. That way the user knows. So let's write our very first processing function, which will be NOP. And NOP has instruction code hex 00. So I'm just going to put that there just to remind myself what output I should be getting. All right, so we're going to say, make a new function called NOP. And all of our instructions, if you remember from process, take 2 arguments, tokens and output. So in NOP, it's going to take tokens, and output. First thing we want to do is check to make sure that we have the correct number of arguments, which for NOP should be 0. And so tokens is going to be our first argument to check, since we have tokens here, and that way we can just spit out what the instruction was if it's incorrect. But what goes into this Boolean, this passed Boolean? Well, we can use the logic that is built into D and built into many languages to do that work for us. So If it's the case that we don't want to have any arguments, we can combine the fact that strings, as we learned, has an empty property with ands. So we can say tokens.first.empty and tokens.second.empty. Right? And this will actually check to see is the first argument empty, is the second argument empty, and so if you have 1 and 1, you have 1, so you would pass. If you have 1 and 0, right, so on and so forth. So we want to actually check to make sure that both tokens for the first argument is empty and the second argument is empty. If for some reason you have a first argument, or somehow you have a second argument but not a first argument, or you have both arguments, pass should become false, and it should give you a complaint that the arguments are not correct for the NOP instruction. So after we do that check, we need to perform some sort of action. And that's kind of the way that all of these instruction named functions are going to work. They're going to do a check, and then they're going to perform some sort of action. So we haven't written the action function yet, but I'm going to go ahead and write what I know to be our argument. So action is going to take 4 arguments. It's going to take our tokens, it's going to take our output, it's going to take then 2 numbers. In this case for NOP, it's 1 and 0. So let's go ahead and actually write that action function. And then we can actually see how it works in action, no pun intended. So this function will take appropriate action depending on which pass it is. So we're actually deferring, for the most part, what to do for each pass all the way down till we get to the actual action we want to perform. So we'll say tokens, output, and then I'm going to say the third argument is going to be an unsigned short, which will be a size. And again, unsigned short because there is no way an instruction is going to be longer than 65,536 items, because that's bigger than what we could even store in an 8-bit program anyway. And then also say int out byte. And so what do we need to do? Well, we need to do different actions depending on which pass we're in. So first we'll check to see if we're in pass 1. If we are, we'll do one set of actions, and if not, we don't really need to check for pass 2 because there's only pass 1 and pass 2, so we'll just say else. If we're in pass 1, we need to add a new symbol if we have a label. We don't know if we have a label. Well, at this point we do know if we have a label, but we can't know at the time of writing the code if we have a label, right? Some lines will have labels, some lines will not have labels. But that's very easy to check, and you probably already suspect that you know how to check this. If it's not the case that the label is empty, then we want to add the symbol. Easy as that. That's it. We then need to increment the address counter by the size of the instruction, because we need to make sure that the address for the label actually corresponds to the address where that label shows up in our source code. So we need to know how big each instruction is. And it turns out there are not that many options for how big an instruction can be. It can be either 1 byte, 2 bytes, or 3 bytes. And this table here is actually telling us how many bytes each instruction is. So this number here, it's this left number right underneath the instruction name, tells you how many bytes that instruction is. So for NOP it's 1, and that's why we put 1 in as our size argument. And an out byte is what byte should actually be printed out, right? What byte does this instruction actually correspond to? And for NOP it's hex 00, which is why hex 00 went into that 4th argument. So let's do that incrementation. So let's say output.address plus equals size. Simple enough. Now it might be the case that, your address might become larger than hex FFFF. One of your homework assignments will be to detect if address is now too big and throw an error if it is. Again, I'm not going to do it for this workshop, but it's a thing for you to think about moving forward. Do you want the possibility to end up assembling files larger than you can actually address and actually use on such an 8-bit CPU? All right, so that takes care of pass 1. If we're in pass 2, all we need to do is output the byte representing the opcode. But what happens if our opcode takes 3 or 2 bytes, if that instruction takes more than 1 byte? Well, we're essentially going to defer that knowledge and that calculation until later on. So we'll say if the opcode carries additional information, such as an immediate or an address, we will output that in a separate helper function. So for now, all we have to do is use the same magic we've been using before to concatenate something to something else. So we can say our output.exe, we just want to concatenate the out byte, and we'll cast the out byte to a U byte because if you remember, in our output object, our executable is an array of U bytes. So we'll just cast that into a U byte. And that's it. So regardless of which pass we're in, we will perform the correct action. If we're in pass 1, we need to do a label check. We need to add a label if we have one. No matter what we do, we must increment the address counter by the size of the instruction. That way we know and can keep track of where we are in the 16-bit address space, so the next label we run into can have the right value. If we're in pass 2, we simply spit the byte out. That's all we need to do. And so at this point in time, we actually have, well, I don't know if I'd call it a completed assembler, but you in fact have an assembler that can take any number of nops that you write and output the correct number of zeros. On the other hand, being able to output nops and only nops probably won't make for a very useful set of programs that we can write. Seems like we'll need a little bit more than just nops, but we're going to call it for now. We will make sure to commit our work, add check, action, and nop. And in the next episode, we will implement a full quarter of all of the 8080 instructions. We're going to tackle this section here, all of these moves, and this little halt here. So by the end of the next episode, we will have a full quarter of all of the instructions completed and assemblable. So join me in the next episode, and I will see you there. Welcome back. Welcome to part 9 of our workshop. And as promised, we will tackle a full quarter of all of the Intel 8080 instructions, all of these move instructions. We'll do halt as well because it's pretty straightforward. It's pretty much as straightforward as NOP is. So we will have more than a quarter of all possible instructions assemblable with our assembler at the end of this episode. So let's start by actually implementing that move instruction, because we're going to see that as we implement that move instruction, we're going to have an interesting, let's say, new problem to tackle. So let's go ahead and say move. And move is, well, there's a lot of moves, aren't there? There's like 64 of them. I guess technically 63 because there's a halt in here. Okay, so how would we go about actually figuring out how to process move instructions? So something that sticks out to me is that every move instruction has 2 arguments. And those two arguments are always two registers. So on the Intel 8080, there's a number of different registers. There's A, B, C, D, E, H, L. And this is kind of pseudo register that they call M. So for our intents and purposes, let's say that there are 7, right? So there's A, B, C, D, E, H, L, and M are our 8 registers. So no matter what, if we see a move and we don't see registers, then something's definitely wrong. The next thing that looks interesting to me is that the registers appear to follow a pretty strict order. So if we look at the first register, we have all the B's, and then all the C's, and then all the D's, and then all the E's, and then all the H's, and then all the L's, then all the M's. We're going to ignore halt for now. And then all the A's. So the pattern is B, C, D, E, H, L, M, A. And each one of those, again, with the exception of M, we'll just ignore the halt, has 1, 2, 3, 4, 5, 6, 7, 8. The 9th one here begins with move C. So each register destination appears 8 times. So here the instruction is read move B is your destination register. The first one is always your destination register. The second one is your source register. So for example, move D comma B says take the value of B and put it into D. So if you look at the ordering of the second argument, it follows the exact same pattern as the first argument. B always comes first, then C, D, E, H, L, M, and A. If we look over here, B, C, D, E, H, L, M, A, B, C, D, E, H, L, M, A, right, so on and so forth. So that appears to be the pattern of registers. And sure enough, if we look down below into our arithmetic operators, B, C, D, E, H, L, M, A, B, C, D, E, H, L, M, A, right? So that's clearly a pattern that seems to be constant throughout the entirety of the instruction set. And that is actually going to make our life significantly easier because there's a formula that we can apply to know which byte to output, because if you notice, every move is only 1 byte, but we can know based on the combination of having move as the instruction and the 2 arguments, which byte we should actually output. And the formula is going to be hex 40, and that makes sense because the very first move is at hex 40, plus, and then it's going to be the register times 8, or bit shifted by 3, plus the register. So we can apply this formula to figure out what the byte is going to be for each move instruction. So let's write out the move instruction first, and then we can go back and see what the actual formula is and write out the logic for that formula. So a move is going to be tokens, tokens, as always, output, output, as always. And then the logic is going to be check. And what is it that we want to check? We want to make sure that both arguments have values in them. So we want to make sure that the first argument is not empty and the second argument is not empty. Right? And then what action do we want to take? So the action that we want to take, all moves are 1 byte. So we can put 1 here for our third argument. And then we're going to need this formula here to actually output the correct byte. So we can just write it in right where we are. So hex 40 plus, I'm going to make a new function called register 8, and that'll be how we can figure out what number to give to each of these registers. So I'll say register 8 tokens.first times 8 plus register 8 tokens.second. And that's it. That is all we need to do to process a solid quarter of all of the instructions that we will possibly ever write. Very cool. But how about that register 8 function? So we need to figure out what the actual numeric value for each of these registers are. Let's take the second argument for the first set of moves, because that's going to kind of make it easier for us. So the very first move instruction is 40, hex 40, and that is move b comma b. Well, what's the only value of b that could make this formula make sense and yield hex 40? Well, that would have to be 0, because 40 plus 0 is going to equal hex 40. Anything else is going to equal something different. So it's probably going to be the case, if I had to guess, that B has the value of 0 when calculating register to instruction number. And indeed, B is 0. Move B comma C is 41. So what must be the arguments in this formula to get 41? Well, we already said B is 0. So hex 40 plus 0 plus what equals hex 41? And of course, the answer is 1. So C must equal 1. By the same logic, D must be 2, E must be 3, H must be 4, L must be 5, M must be 6, and A must be 7. And that is indeed the pattern that you will use anytime you see registers and need to convert them into an instruction number. So it's going to be exactly the same here when we get to our adds and subtracts. So let's go ahead and code that up. That's going to be fairly straightforward to code up. So we can say return the 8-bit register offset. So we want to return an int because we actually want to return the number. So we'll call this register 8, and it takes a string, and that string is the register that we've read in. And this is fairly straightforward. As we kind of saw before, D will allow us to do cases on strings. So let's go ahead and do that. So for case B, we want to return 0. Case C, we want to return 1. Case D, we want to return 2, and so on and so forth until we get to the end. H is next, and H is 4, and then L is after that. L is 5, M is after that, and it's 6, and finally we have A. And that's it. That's our whole logic for any time we see a register in some sort of argument for our instructions. So definitely for our moves and definitely for our arithmetic instructions as well. And that's it. We can now successfully process all of our NOPs and process all of our moves. But we should probably also, before we end for this episode, also process the halt. So one thing I'm not going to bother doing is if a user happens to put in, let's say, move m comma m, because the halt is in the location where move m comma m would be, I'm not going to worry about that. If a user wants to put that in, they can suffer the consequences, but we should definitely put in something for halt, because we may see halt as its own instruction. And this is going to be fairly straightforward. So at this point, we should know how to kind of set up the boilerplate for each of our functions. And so let's take a look at halt. Halt takes no arguments. So we want to check that, oops, let me just fix those there. We want to check that the first argument is empty and the second argument is empty. And then the action for us to take is 1 byte. Halt is only 1 byte, and it is hex 76. And with that, we can now process all of our moves, our halts, and our NOPs. So we're almost at the point that our assembler can be useful. We're not quite there yet, but we're getting there. So let's save this. And we'll say implemented move, halt, and register formula. Okay, and with that, we'll wrap up this episode, and I will see you in the next one.
He fills my heart with very special
Welcome to part 10. We are marching on forward to completing all of the instructions on this instruction set table. So for this episode, what I want to do is implement this quarter of the instruction set. These are all of our arithmetic operators between two registers. And on the 8080 and Z80, the way it works is every arithmetic operator from hex 80 to BF implies having the A register as your destination register, and the register that you actually write out here is your source register. So just to kind of quickly summarize it, so add B really means register A equals register A plus register B. Add C is register A equals A plus C. Sub B is A equals A minus B, right, so on and so forth. So nice in the fact that all these arithmetic operators are pretty much all the same because they all take one argument and they all use that same register calculation as we did for the moves. So I'm going to get you started with maybe one or two of them, and then for homework for this part of the workshop, you will implement the remainder. The other nice thing is every single one of them is 1 byte in size, so you really can, for the most part, copy and paste a good amount of this. So let's start with add, since that's the first one that we see. So I'm going to say add is going to be hex 80 plus register offset, right? B, C, D, E, H, L, M, and A, just like we saw with the moves, and the pattern is exactly the same. So our add instruction, by now we should know what our boilerplate looks like. And so what do we need to do? What do we need to check? We need to check that the first argument is not empty, but that the second argument is empty, right? There's no comma, something else for any of these arithmetic instructions. It's just the instruction and then one argument. So we want to make sure that the first argument is not empty and that the second argument is empty. And then what action do we want to take? Well, we know that all of our arithmetic instructions are 1 byte in size. And then for add, it's going to be hex 80 plus our register 8 function for our one argument. And that's it. That's all you need. So let's do ADC just to kind of show the pattern here. And again, we can just copy and paste because it's going to be very easy. So what's the first byte that corresponds with an ADC instruction? Well, it's 8 something, 8, 8. So the formula for ADC must be hex 88 plus the register offset. It's exactly the same. We want to check to make sure that our first argument is not empty and our second argument is empty. And then all we have to do is change the starting byte for the output from 80 to 88. All right, let's do sub as well, just to kind of hammer home the pattern. So sub starts at 9, 0. Okay, so let's say that, hex 90, and then our register offset. So same thing, we want to check to make sure that we don't have an empty first argument, but we do have an empty second argument. And then all we have to do is change the starting output byte from hex 80 or hex 88 to hex 90 for the sub. And that's it. So I'm going to leave it up to you all for homework to implement SPB, ANA, extra, aura, and compare. Again, it's exactly the same. You can copy and paste just like I did. Just remember to change your starting byte and change the name of your function. All right, and with that, we will save our work. Add 2 register arithmetic instructions. And I will see you on the next episode.
찬바람으로 목이 칼칼할 땐 기관지가 촉촉하게 유지될 수 있도록 수시로
단도 직입 용각산 쿨. 브라운 하나만으로 면도 끝.
Welcome back. This is part 11 of our workshop. So half of our instructions are done. We have our NOP, we have all of our moves, we have our halt, and then we have all of our arithmetic instructions now. Unfortunately, those are the easy ones. So now we have the remaining half, and as you can see, they're nowhere near as straightforward as the moves and the arithmetic instructions. But that is not to say that they're any more challenging. We just need to kind of think about our process maybe a little bit differently. So I'm going to start in this top half here. I'm going to save this bottom quarter, I should say, for the next episode. So we'll tackle this top quarter here. The good news is once we've implemented one instruction, we don't have to implement it each time we see it, right? Just like we with the moves, we implemented one move and we let the formula take care of the rest. Same thing with the arithmetic instructions, we implemented it once and let the formula take care of the rest. And some instructions, we just don't have to worry about at all, right? Once we've implemented NOP, we don't need to implement NOP for 10, 20, 30, or 8, 18, 28, or 38. We'll just make all of our NOPs be 0, 0, and that'll be perfectly acceptable for what we're looking to do. So we do need to implement LXI, stacks, SHLD, STA, inks, inner, decker, move I, these different rotations, the DAD, LDAX. We also need to implement LHLD, LDA, DCX, and then some more rotations. Okay, so that seems like a lot, but it's not quite as much once you begin to break it all down. So let's start right with LXI. So LXI is interesting in that LXI is going to take some sort of 16-bit number and put it in a 16-bit register. Now, I know the Intel 8080 and the Z80 are 8-bit CPUs, but they are able to address pairs of registers as if they were a single 16-bit register. And that's what LXI is doing here. So what's going to happen is these are also going to follow a formula, BD, H, and SP. So we're going to need another formula to kind of figure out which one is which and to give us the correct number for whether or not we have B, D, H, or SP. So let's go ahead and start there. So I'm going to put it right underneath our register 8 function. And so this is going to return the 16-bit register offset. So again, it'll be an int. We'll call it register 16. Again, I know I'm very, let's say, naming challenged for my registers and function names and variable names. So just like with register 8, this is just going to be a switch. And if we have B, we'll return 0, right? Because using the same logic, if LXI B, comma, we're not going to worry about this D16 because that's not going to be factored into the output byte. So if LXI is a base of hex 01 and LXI B is hex 01, well, the only thing B could be in this case would be 0. Otherwise, it won't be 0, 1. Here, though, LXI D is 1, 1. So D must be equal to hex 10. H must be equal to hex 20. SP must be equal to hex 30. So we're going to take care of that. So we'll say return 0x10. For case H, we're going to say return 0x20. And then for case SP, we're going to say return 0x30. Now it turns out that when we get down to the bottom here, these registers are replicated, except in pop and push, the register name is PSW instead of SP. It's just a thing we're going to have to live with. For LXI, that last one is SP. For pop and push, that last one is PSW. So let's implement logic to make sure that we use the correct spelling of our registers for whether or not it's SP or PSW. So in SP, we can say if tokens.instruction is not equal to pop, and the instruction is not equal to push, then and only then do we actually want to return hex 30, right? Because in that case, it'll be LXI. And you could just check to say if tokens.instruction equals LXI if you wanted to. I'm going to keep it this way just for symmetry of logic in a little bit. In that case, we return hex 30. If not, we're going to have to throw a new exception because we now have an error and say SP may not be used with tokens.instruction. If we have PSW, it's going to be the same thing, except instead of checking to see that it's not pop or push, we're going to check to make sure that it is pop or it is push. And if that's the case, then we return hex 30. It's the exact same number. Otherwise, we're going to throw a new exception, and we're going to say PSW may not be used with tokens.instruction. We should also have a default case. We should error out if we don't have a valid register. In fact, I like that so much. Why don't we go ahead and also add it to register 8. Okay, so that's going to take care of LXI, and then later on we'll see pop and push. So let's go back to LXI. So what is LXI? So LXI is hex 1, and then so it's going to be hex 1 plus that register offset that we just wrote. So void LXI. Again, by now we should be pretty used to our boilerplate. And we're going to want to say, okay, well, how many arguments do we have? We have 2, right? B, comma, and then some 16-bit number. So we're going to want to check that our first argument is not empty and our second argument is not empty. The action we want to take is to say that this is a 3-byte instruction, as it says so right there, and the output byte is going to be hex 1 plus that register offset. But there's one other thing that we need to do, right? This would only output 1 byte. And we did say that LXI is a 3-byte instruction. So we have to do something to deal with this 16-bit number. And so that 16-bit number is an immediate. So we're going to write a new function, an immediate function. And that will output the correct value depending on what we type in. So let's go ahead and actually write that function since we're going to need it now anyway, and that way we can say that we've completed LXI. So this will be the way that we can get either an 8-bit or a 16-bit immediate. Right, so while LXI happens to use a 16-bit immediate, you can see over here MVI uses an 8-bit immediate. So we need to deal with both possibilities. Not that any instruction will have either possibility, but we can see either possibility throughout the course of any particular assembly program. So we'll call this instruction immediate. We'll take a size, and then boilerplate, tokens, tokens, output, output. So the first thing we need to do is figure out if we have a 16-bit immediate or an 8-bit immediate. The other thing to notice is while LXI and MVI have their immediates as their second argument, every other time we see immediates being used, for example, ADI, SUI, ANI, ORI, ACI, SBI, XRI, CPI, they're all going to take their immediates as their first argument. So we also need to check to make sure and see if we're currently dealing with LXI or MVI. Because if we are, then we need to be looking at the second argument. Otherwise, we need to be looking at the first argument. So I'm going to go ahead and make a new variable there for that. Okay, so the next thing we need to check is, well, so this one's interesting. So a user, at least in like the classical CPM assembler, could put in either a decimal number or a hex number. And that doesn't sound like a terrible idea for our assembler either, but I absolutely hate the way that the old school CPM assembler did hex numbers. So the way they did it is you had to write the number and then you put an H at the end of it, which means you had to have write in and scan to the very, very end of the number to see if there's an H there to know if you're in hex or decimal, which is kind of a waste. I think the way that, let's say, for example, Turbo Pascal did it was the right way to do it. And they prefix their hex digits with a $sign. And that's the way that I'm going to do it. That way we can see a $sign right away at the very, very beginning of our string. And if we see the $sign, we know we have a hex number. If we don't see our $sign, we know we don't have a hex number. Because that also led in the classical CPM assembler having to do weird things like if you wanted your hex number to begin with a character, A, B, C, D, E, or F, you had to put a 0 in front of it, and then put your hex number, and then put an H, as opposed to just being able to say $sign FFFF and just being done with it. So that's what we're going to do here. So first thing we need to check is if we have a digit, and the D library has a nice handy isDigit function, which lives in standard ASCII. So I'm going to put that in, import standard ASCII. So we have our if isDigit. So the first character we read in of our argument is a digit, or the first argument we read in is a $sign, or, well, now we also need to check for if we have something like A, B, C, D, E, or F. So we can say argument 0 is greater than or equal to A. Actually, I'll wrap all these in. And argument 0 is less than or equal to F, or argument 0 is greater than or equal to lowercase a, or argument 0 is less than or equal to lowercase f. Kind of long-winded, but that kind of does get us all of our possibilities. A number can begin with a digit, 0 through 9. It can begin with a $sign, because then that tells us it's a hex number. Actually, now that I think about it, we probably don't even need to have those arguments A, because if we just say $sign, then it's a hex number. And there's no decimal number that can begin with A, B, C, D, E, or F. So look at that. We were able to simplify some of our argument parsing just by using that $sign. And that's why we use that $sign. All right, so if we have a number or a $sign, then we set a number. So I'm going to go ahead and make a new variable called number. And I'm going to say if number equals, say argument 0 equals $sign. So we're going to check, did our number start with the $sign? If it did, we want to convert this string to an unsigned short. Again, it's the largest number that we can write in. D16 is one option we have, D8 is the other option. So it's either an 8-bit number or a 16-bit number. So a U short is really the largest thing that we can write in anyway. So if our number started with a $sign, we want to say convert, not the whole string, right? This is where slices, again, can come in handy. So we want to say the argument from 1 to the $sign, and in D, the $sign is the shorthand for end of string. So what is this going to do? Well, this is going to just remove the $sign from the number and convert the rest of it, minus the $sign, to an unsigned short. If our number did not begin with the $sign, then it's just a regular decimal number, and we don't need to worry about any slicing. We can just say convert the string into a number. And that's all we need to do there. Otherwise, so this is a little deceptive where it says D16 here. This could also be a label. Maybe not specifically for LXI, but it could be a label. And so we need to deal with the possibility that any of these LXIs has a label instead of an actual 16-bit number. So how are we going to do that? Well, we can say that if we're at the point in time where we are ready to output code, as in we are currently in our second pass, so if we're in our second pass, then we are going to need to iterate over our symbol table. And if we find that symbol in our symbol table, then number is just going to be the value of that symbol. Simple as that. And that's why we have to store the values in the first pass. I'm also going to make a Boolean called found, just to show that we have in fact found this. Again, the nice thing is D will auto initialize your variables, and it will automatically initialize your Booleans to false. So we can say bool equals true here, and then we're done. Right? Because there's never going to be a case where we have two labels of the same name. So if we find our label, we're just done. We can break out of the loop. If for some reason we got to the end of our symbol table and we did not find the label that you've asked for, then that's going to have to be an error. Because that label doesn't exist in our symbol table. And by this point in pass 2, it definitely should. So we're just going to say label not defined. I think that's good enough. All right, another thing that we're going to have to do, regardless of whether or not we have a number or a label here, if we are in fact writing out code, then we had to convert that value, that number, into the actual bytes that will live in the binary. So one thing to keep in mind is that Intel 8080, the Z80 are little endian. So we can't just write the value out exactly as it is. We have to make sure that all of our values are written in little endian notation. And a quick way to do that is to say, give me the bottom half first. And then if we have a 16-bit number, then give us the top half. Let me just bit shift to the right by 8, and so they just give us that byte. And so that's why there's this size argument in our immediate function. That way we know if we're dealing with an 8-bit immediate or a 16-bit immediate. Okay, and so that takes care of LXI. And I'll take care of all of our instructions that need to have an immediate, like MVI, ADDI, ASCII, SUI, SPI, ANI, XRI, ORI, and CPI. Neat. So let's call that here for today, and we'll come back in the next episode and we'll kind of continue on with stacks, inks, inner, decker, and we'll try to get done this top quadrant of our instruction set. So let's go ahead and save our work. So implemented LXI and immediate processing. And I'll see you back here for the next episode.
질레트랩스 한 번의 움직임으로 깔끔한 면도. 신제품 질레트랩스 딥 클렌징 바.
Welcome to part 12 of our workshop, and we're getting there. At the end of the day, at the end of this episode, we should be able to process at least this top line of instructions, which means we should also be able to process the second line as well. We're going to hold off on SHLD and LHLD to the next episode, and that's pretty much going to round out almost all of these special cases that we need to worry about, which I think is kind of neat. We're getting there. All right, so let's kind of move on. Next instruction here is stacks. So stacks is going to be hex 2 plus a register offset. Now, unlike LXI, stacks, there's only two versions of stacks, B and D. So I'm going to do something where I'm not going to be running that offset 16 function. We're just going to check directly, because if someone writes stacks H, we don't want to accidentally do the wrong thing. So again, our boilerplate, tokens, output. We want to check. What do we want to check? We want to make sure that there's only one argument. So first should not be empty, and second should be empty. Then we're going to have to do a switch on that one argument that we have. And if it's B, then we're going to say tokens output. Both stacks are just 1 in size. And I'll just hard code 02. And I'm going to do the same thing with D. If we happen to see a D, then our action will be tokens output 112. Just hard code it. In all other cases, we do want to throw a new exception, because we do want to error out. So we say only B or D can be used with stacks. Fair enough. Same thing is going to be true with LDAX. So part of your homework assignment will be to replicate what you do with stacks with LDAX as well. Because again, there is no LDAX H, no LDAX SP. Most of the instructions on this list, you should now know how to work on all on your own. All of these rotations don't take any arguments. They're all 1 byte. And they're all different: RLC, RAL, DAA, STC. So you just line up, right? In this case, 7, 17, 27, 30, 37. The same thing over here: F, 1F, 2F, 3F. Again, we don't have to process these NOPs. And so let's see if there are any left that might require special attention. Well, the Decker, Inner, DCX, INCS, they all follow the general register offset. So we can say 30, 13, 23, and 33. And again, if we look at our register 16, that will all match up quite nicely for us. Inner and Decker, though, are different than INCS and DCX. While DCX and INCS increment 16-bit registers, Inner and Decker are actually incrementing 8-bit registers. There's an Inner B, Inner C, Inner D, Inner E, so on and so forth. So we do need to do something a little bit different for our Inner and our Decker. So let's see what that would be. So I'm going to trust that you can do INCS and DCX on your own, following the pattern we used before with LXI. I'm also going to trust that you can do these rotations: RRC, RAR, CMA, CMC, RLC, RAL, DAA, and STC. So let's take a look at the Inner and Decker. So let's start with Inner. So Inner is 4 plus, well, kind of a register offset. So it definitely is a register offset, but it's not quite the same register offset pattern as we had before. So let's take a look at it. So Inner is going to start with hex 4, right? Because the first time we see INR, we have 0, 4. So B must continue to be 0, because the only way you get hex 4 plus something equals hex 4 is if that something is 0. But how about C? C would turn hex 4 into hex C. Let's see if we can count the number of instructions between. So we have 1, 2, 3, 4, 5, 6, 7, 8. So inner C is 8 instructions after inner B. Could it be as simple as we can do our register 8 function and then simply multiply the result of that by 8, or bit shifted to the left by 3? Let's see. So if we did that, so if this was 0, we get hex 04. If this is 8, right, 1 times 8 equals 8, that would be 0C. If it was 16, right, 2 times 8, then yeah, 2 times 8, 16, or hex 0, or hex 10. 10 plus 04 is 14, and sure enough, that lands us here. So that does appear to be the pattern. The pattern for inner and decker appears to be the starting value, 04 for inner, 05 for decker, and then you add to that the register 8 function, but before you do that add, you multiply the result of the register 8 function by 8, or bit shifted to the left by 3. I'm going to do the bit shifting to the left by 3. So inner would be check, tokens, and we only have one argument for inner and decker for that matter. So we want to make sure the first one is not empty, and we want to make sure the second one is empty. And the action we're going to take is tokens, output, the usual boilerplate. All of our inners and deckers are only 1 byte in size, so we'll say 1. And then the formula for inner is going to be 0x04 plus register 8 on tokens.first and shift it to the left by 3, and that's it. We're done. It's exactly the same for decker, except we start with hex 5 instead of hex 4. And with that, I trust that you should be able to complete for sure these first 2 rows. Keep in mind that for MVI, it only takes an 8-bit immediate, not a 16-bit immediate like LXI does. So for that particular case, your immediate should be immediate 8, token, output for MVI. And you'll also notice that MVI follows a very similar pattern to INR and DCR in that there's a B, there's a C 8 away, there's a D, there's an E 8 away. So it's going to be the same logic that we just implemented in inner as well in your MVI. So MVI becomes a mixture of the inner logic with the immediate logic from LXI. And that's it. There's one more thing that we're going to have to do that we'll tackle in the next episode, and that will be dealing with addresses. Once we can deal with addresses, we're pretty much home free. That's the last big thing that we need to do. So let's go ahead and save our work, implement INR, DCR, I guess, and others. And with that, I will see you on the next episode.
잘 쳐줬다는 내 차 견적 믿을 수 있어? 누르세요. 안심벨 오토벨.
Welcome back to part 13 of our workshop. The last real thing we have to worry about to be able to implement any of the instructions in the instruction set is dealing with an address. We first run into addresses with SHLD and LHLD, but they're used often as well down here with our jumps, our calls. So we do need to know how to deal with addresses. The good news is dealing with addresses, we actually already know the logic for. Addresses are always 16 bits in size, and we already know how to process 16-bit immediates. But just for the sake of, I guess, clarity or ease of reading, I'm going to implement a separate address function, even though the logic is going to be the same as if we had a 16-bit immediate, I'm just going to do it anyway, just for clarity as we're going through all of these instructions. D16, I know to use an immediate. A16, I know to use an address. But if you want to, just claim that an address is a 16-bit immediate, fine, that works too. But I'm going to do it this way. So because the logic is more or less the same, I'm pretty much just going to copy it directly out of our immediate function. So it's the same idea. If our first character in our token is a digit or a $sign, it's a number. The other nice thing about addresses is every instruction that uses an address only ever has one argument, and that one argument is the address. So I can just go ahead and just know it's tokens.first if I'm dealing with an address. So if we have a number or a $sign, then we just got to do the same conversion that we did before, tokens.first. If the first character is a $sign, we just want to make sure to convert it as a hex number. And let me make sure I didn't make this. Yep. Let me just fix something right here real quick. Make sure it's base 16 if it's a hex number. So we'll say if it starts with a $sign, we want to convert the string to a short. But we don't want to convert the whole string to an unsigned short. We want to chop off that first character, that $sign. Otherwise, we don't need to chop off that first $sign. We still want it to be an unsigned short. But we do not need to chop off that $sign, and we want to make sure it converts to decimal rather than hexadecimal. Otherwise, it's going to be a label, and we're going to need that label to be processed. So let's go ahead and do that. Let's process the label. And it's going to be exactly the same as we did before. Just fix that right there. All right, same thing as we did before. So we're going to say if we're on our second pass, we're going to iterate through our symbol table. And if we have a match, then we must want the value of that label. And we can say we found it, and we can break out. If we get to the end and we did not find it, then we should throw an error. And then in all cases, we need to make sure that if we're in pass 2, we actually output the value that we have. And again, we make sure to remember that we are outputting in little endian format. So the way to do that is just take the bottom half first, and then we can add the top half after that. And that's it. Again, the logic for address and immediate, basically the same, but just for ease of as we're working through, right, you see a D, you do immediate, you see an A, you just automatically think address. At this point, you should be able to process all the moves, which we already did, all of the 2 register arithmetic instructions, which we already did. You should now be able to process all of the instructions in this top quadrant as well. And you should be able to process the vast majority of instructions in this bottom half. The only real exception left that we don't know how to process are these RSTs. And so we'll do that right now. There are 8 RST instructions named RST 0 through 7. If you were studying 8080 Z80 assembly, you would know that these are your reset vectors. We don't necessarily need to know that these are our reset vectors, although I do hope as you work through and as you implement all of these instructions, you are actually reading up to see what they are and what they do, and might be getting ideas of how you might be able to use them in your own future Z80 programs. But let's go ahead and actually do the RST together, since that's the last one that we actually don't yet fully know how to do. So the first RST instruction is at hex C7. So RST is going to be C7 plus some offset, right? And there's a number of possibilities, 0, 1, 2, 3, 4, 5, 6, and 7. So we'll say void RST is tokens, output. Again, we should be used to the boilerplate by now. We want to make sure that RST does have one and only one argument. So we want to make sure that first is not empty and second is empty. We then need to actually know what that offset is. So I'm just going to convert tokens.first, or the one argument we have, 0, 1, 2, 3, 4, 5, 6, or 7, into an integer. And we can check to make sure that offset is greater than or equal to 0 and less than or equal to 7. Because if it's for some reason not in that range, we have a problem. So if we are in the correct range, then the action we want to perform is tokens, output. All of our RSTs are only 1 byte in size. And then the formula is hex C7 plus 0, 1, 2, 3, 4, 5, 6, 7 times 8. Actually, pretty much exactly the same as the inners that we did before. Just we had the actual numbers instead of having to do the register to number conversion. But it's the same idea. They should be 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8 apart. So we should be able to say offset times 8 or bit shift by 3. Otherwise, we just want to error out. We want to throw a new exception, and we'll say invalid reset vector, I guess. And we'll print out what the invalid reset vector is. With that now complete, you should be able to go through the entire rest of this instruction set and just follow the formulas that we've been using to get to this point. And you should be able to implement every single instruction within the Intel 8080 instruction set. However, even when you get to that point and you are able to implement them all, we're still not quite done yet. There are a couple of pseudo instructions that I want us to implement, which will give us a bit of a richer environment so that we'll be able to do more and more powerful things with our assembler. But when you are done with all this, definitely give yourself a pat on the back. I would create a test program that actually tests every single one of these instructions to make sure that they are actually producing the correct hex numbers. But yeah, give yourself a pat on the back. We're almost home. So let's save our work. And I will say, well, I'm going to pretend that I did them all. So I'm going to say implemented all instructions. And I'll see you on the next episode, and we'll wrap up with a couple of pseudo instructions.
채워주고 감싸주고 보호하니까.
시리니엔 시린메드 부광약품.
Welcome back. Welcome to part 14 of our workshop. And in this part, what I want to do is I want to implement some pseudo instructions. So they're not instructions we'll find here in the instruction set, but they will make our life a whole lot easier when we are writing our assembly code. So there are a handful that I want to do. I want to do 4 in this episode, and then I want to save the last one for the final episode because it'll be a little bit more involved. The 4 that I want to implement in this episode are DW, DS, org, and end. So DW allows us to place a 16-bit word anywhere we want in our assembly, in our program. DS allows us to reserve a space for uninitialized memory. Org is a way to force update the address counter. This is used all the time in CPM assembly. Almost all CPM assembly begins with the instruction org 0x100 because that's the entry point for CPM programs. And then end just says, if there's anything after this, too bad, we're at the end of our assembly. So let's start with end because that's the easiest one that there is. So end is simply the end of the assembly. End of assembly. Even if there is more code after. So if you write an end, that's it. Our assembler is just going to up and stop itself. And so this one, interestingly enough, is the one special case in terms of arguments. This one actually needs the input as well. We're going to see why in a second. So end should not have anything. It shouldn't have a label. It shouldn't have a first argument. And it should not have a second argument. And all we need to do is set the line counter to the largest possible number that it could be. And so numbers in D have properties like min and max. Max is going to be the largest number that an input line can hold, which if we go all the way back up to our input class, that's an unsigned long. So that's going to be a really, really huge number. So big that there's no way you're going to ever be able to write anything that is of that size. So all we have to do is say input line max, and I'll say -1, just so that it increments and is a number far larger than you could possibly have written in your code, and that way things just end. And that's it. That takes care of end for us. So the next one I want to do is org. And so like I said, org for us is going to force update the address counter. Again, it's used all the time in CPM assembly coding. Everything begins with like org hex 100. So at this point, we kind of know our boilerplate, tokens, output. And what do we need to check? So org only takes one argument. So we'll say tokens. Org should also not take a label. So we'll just say if label is empty and we have an argument for our first argument and we have an empty second argument. All right, so what are we going to do? We're going to take a number and we're going to force update the address counter to be that number. And we're only going to worry about numbers. We're not going to worry about if you give a label as an argument to org. If that's a thing you want to implement as you are further developing your assembler, you are welcome to do that. But I'm not going to do that. I'm just going to worry about if they are numbers. So if it's a number, and if we are in our first pass, then let's just force update the address counter. Kind of the same thing that we did with numbers, right? We're going to check to see if the first character in our number is a $sign. If it is, we want to make sure that we make it into a hex number. Otherwise, it's just a decimal number. All right. Otherwise, if for some reason we don't have a number, let's just error out. And we'll say, org requires a number for its argument. That way the user knows what they did wrong. And that takes care of org for us. Now we can kind of be more precise about exactly the memory layout that we want for our programs. All right, the next one that I want to implement is DW. And DW is going to place a 16-bit word wherever we happen to write the DW instruction. So we'll just say place a word. We'll say void DW, tokens, and output. And so same thing. DW should only have one argument. So if we're on the first pass, we still do need to check to make sure that if there's a label on that line. You can put a label on a DW line. So we'll just want to make sure to check for that. Again, the logic is the same as we've done in the past. And then we want to take the address. We always want to increment by 2. And we're done. Pretty straightforward. All right, and then the last one I want to do for today is going to be DS. And what DS is going to do is kind of reserve space for us. Oh, hold on. This should be... There we go. We don't want to spit out, right? Because if we remember, address will... There we go. Address. If we're in pass 2 of address, we're going to spit out. Actually, address will take care of that for us. Let's not even worry about that. Let's make our lives a little bit easier. Let's actually just get rid of that. And we'll just stick address like that. Because it won't spit out any values unless we're in the second pass. But we do always want to make sure to increment by 2. That's important. All right, lastly, like I said, DS. So DS is going to reserve an area of uninitialized memory. So again, boilerplate, tokens, output. All right. So actually, let's make this bigger. Let's make this a ushort. Why not? There's no reason we can't take out more than 256 bytes. So let's make it a ushort. So let's check. So we only want DS to have a single argument. And so same thing. If we have a digit, or we have a $sign, and I think we all know what we're going to do here. We'll set value to be either hexadecimal or decimal, depending on what we have. Or without the $sign, then it's just decimal. Otherwise, we have an error. And just let the user know DS requires a number, so you got to give it a number. If we're in our first pass, we do need to update the amount of space that we actually reserved. We also need to check if we have a label, because we can in fact still have a label here. So if we have a label, we'll have to add it to our symbol table. Otherwise, we increment address by the value. If we're in pass 2, we write out that number of zeros into our binary. And that's it for DS. So we can now place any value we want anywhere in our program, by 16-bit words. We can reserve as much space as we want in our programs. We can update the address counter, so it'd be very helpful if we write CP/M programs, or we can just end assembly. There's one pseudo instruction that we have left, which is going to be how we place a byte, which will be our DB instruction. And because this one will require a little bit more work, we're going to save it here and we're going to have our final episode be implementing DB. So we'll say implement DW, DS, org, and end. All right, join me in our last episode. Welcome to episode 15 of our workshop. So we're almost at the end. So we will implement DB. There's actually one other pseudo op I want to implement, and that's EQU. And that's going to allow us to define constants, which we can then later on reference in our programs. This one's pretty straightforward as well, so let's just get this one done real quick. EQU says I have a label and I'm going to tell you what its value is. I'm not going to rely on where we happen to be in the program. I'm going to tell you this is the value I want for this label. So the first thing we got to check is if we have an EQU instruction, then we must have a label because it operates on labels. So if we don't for some reason, we need to error out. Must have a label in EQU statement. Let's think about this. So what do we need to do? We need to say that if we have a digit or a $, and I think you know what's coming next, then value is going to equal. Right, this should not be a surprise to us at this point. We've kind of used this idiom over and over and over again to convert a number either into decimal or into hex, depending on if there's a $sign at the beginning of it or not. Otherwise, we should error out. Okay, else, throw new exception, EQU statements must assign a number. There we go. Let's carry on. So after we've done this now, oops, spelled exception wrong. All right, so if we're in our first pass, then what do we need to do? For in our first pass, we need to actually create a new symbol that has the name that we asked for and has the actual value that we asked for. So the way that I'm going to do that is say autotemp equals output.address, one too many equal signs. Then I'm going to say output.address equals value. I'm going to say add symbol tokens output. I'm going to say output address equals temp. All right, that's just an easy way to make sure that we don't forget where we actually are in the address, but store the new symbol with the information that we want. And that's it for EQU. So the only thing we have left to do now is DB. And so DB, well, so let's say the easy way out for DB first. So the easy way out for DB would be same thing. Takes one argument. And we'll say first one can't be empty, and the second one must be empty. And it can take a number or a hex digit, right? But just one byte. So this is going to look familiar to all of us. So if it's a digit or it's a $, oops, forgot a parenthesis there. Yep. So value will be tokens.first, And if the first digit is a $sign, first character is a $sign, then we just want to chop off that $sign and make it a decimal, or it will be hexadecimal or decimal, depending on whether or not we have that $sign. Now what comes next is, fairly interesting. If we're in pass 2, and all we care about with DB is making them, a single 8-bit number, then we can just say, write out that number. But I'm not so sure that that's necessarily exactly what we want. It is definitely what we want if we have a number. But what if, like is done in the traditional CP/M assembler, we want to be able to write strings. DB is how we will write strings. So DB can be used to simply give us an 8-bit number or an 8-bit hex digit and stick that into your code, into your executable. But it's also going to be how we are going to deal with strings. In the CP/M assembler, they actually let you have multiple items in a DB call. We're not going to do that. We're going to take the lazy way out and just say one argument per DB instruction. But we do need to deal with strings. So let's do that. Let's actually deal with strings. So we're going to deal with the logic first, and then we'll go back to our parser and actually parse out strings. So it's going to be the same deal here. If we are in our first pass, then we should be able to say if we have a label for some reason, we should add that label. And actually, it might make more sense to always do that. So let's take it out of here. Actually, let's put it up. Let's put it up here. Right, because no matter what, it may always be the case that a DB has a label attached to it. So we just always want to make sure that we can correctly assign that label. If we have a string, if we're in pass 1, then we probably shouldn't do anything. But if we're in pass 2, there is something that we are going to need to do, and that's going to be to actually output the values of the string, right? Each individual character of the string. And now that I think about it, there might actually be something important for us to do in pass 1. And that will be, we need to account for the length of our string in our address calculations. So we actually need to increment output address by the length of our string, because each one of those bytes in our string will go into our final executable. So we do need to track that. We do need to account for that. Then in pass 2, we can say for each, and I'm going to say for each character in our string, just output that character. And it'll be a U byte, right? Because it's an array of U bytes. And that's really it in terms of what we need to do to output a string. If it's the first pass, we need to count the number of items in the string and account for that and adjust our address for that. If it's pass 2, then we just need to print out each one at a time. But it does mean that we are going to have to update our parser a little bit. The good news is that we don't have to worry too much about things. Right? So the only time we can ever have a string is when it's the first and only argument to a DB instruction. So the only part of our parser we're going to need to worry about modifying is the part where we get the first argument. There'll never be a string in the second argument. There'll never be a string in a label. There'll never be a string in an instruction. There will only ever be a string in our first argument. And there are a couple of ways we can do strings, right? We can do a C-style string in quotes, or what I'm going to prefer to do is a Pascal style string with single quotes. just because I'm not going to bother with the like / new lines, / nulls, right? You can just make a second DB for that one character and then move on. So I think Pascal style strings will make things a little bit easier for us to wrap our heads around. So what we're going to need to do is we're going to start off by saying if the first character of our argument is a single tick, and I'll just push all these up since these are now going to be in an else block. So if the first character of our argument is a single quote, and therefore what we have here is a string, the first thing we should do is skip past that first character because we don't want to process that first character. That first single quote is not actually part of our output. It's just delimiting the string itself. But then the logic is pretty straightforward. It's not so different than what we are used to. We're going to iterate over the string. Right, make sure that we don't go past the length of a line because we don't want that. We're going to say if the character we're currently looking at is also a single quote character, then there's two things that can happen. So if we see a single quote character, it is either literally a single quote or it is the end of our string. The only way we're going to know that is by checking to see if the next character is also a single quote. So if we're not at the end of the line, right? If we are at the end of the line, then it must be a single quote. So if we're not at the end of the line and the next character in the line is also a single quote, then we're going to say, let's add a single quote character. Let's increment I, and let's continue on. Otherwise, we're going to break, because that's going to be the end of our string. Right? So what we're doing here effectively is saying, if we have a single quote that is immediately preceded by another single quote, what you're actually asking for is a literal single quote. So we're going to append the single quote to our argument, and we'll continue on. If we find a single quote all by itself, it's the end of the string, and therefore we're done. If we don't have a single quote, in every other case where we do not have a single quote, we will simply append the character to the first string. And so what we're really doing here is we are incrementing our string, but we're also building the string one character at a time. So we're not doing the thing we're doing in every other instance where we're just taking a slice of the line and calling that our first string. We're actually going to go ahead and literally build the string if it is in fact, something delimited inside of single quotes. It's not going to change the count, all right? We are accounting for the number of items we are iterating over. So it's not going to ruin the count for us in terms of where we are, in terms of the actual line of code. But I found it easier just to build the string from whole cloth rather than trying to do a slice. Because of this, what do you do if you have two single quotes right next to each other? But that's it. That's the only thing we need to add in order to deal with strings. And so with that, I am going to save our work. And something that's kind of incredible is we are actually at the point where we have finished our assembler. And so if you did all of the homework and you worked through everything, you should have now a working assembler. I'm going to copy in one that I had pre-done because I did not do all the homework. I'm going to run make real fast, and that will build our assembler. And I'm just going to use GDC to build our assembler. And once that's done, I should be able to now run my assembler on that original Hello World source code that we saw all the way back at the very beginning of the workshop. And if I do that, sure enough, I now see a hello.com file. And if we run the hello.com file, we in fact see, finally, Hello DConf Online 22. So I want to thank you for coming with me on this adventure to build an assembler. One of the things that I mentioned in my talk that was shown before this workshop was, I've always been fascinated by programs that can build other programs. I love the idea of that kind of meta work of how do you solve the problem of writing software. And I think a lot of us enjoy those questions, right? We are here hanging out in the D community after all. And for those of you who are new, welcome to the D community. Hopefully this also kind of showed you some interesting facets of the D language, particularly if you are new to D and you are just kind of trying to look around and see what things are available to you. And if you're more on the new side of coding itself, spend some time, review some of these episodes if you need. If you can walk through all the different episodes and you can talk to somebody about what it is that your assembler that you wrote is doing, then you have a pretty good understanding of how to take source code and turn it into instructions that an actual computer can actually understand and process and do something with. And I think that's really awesome. I think people tend to think that compilers and assemblers are these kind of magic things that, require so much theory and knowledge to understand. And it's just not true. It just takes some creative thinking about the problems that we need to solve, and sometimes just simple, potentially less inefficient and less elegant solutions to solve those problems. And we too can have an actual working assembler, compiler, what have you. So with all of that, I'd like to thank you one last time for coming through this adventure with me. I'd like to thank you for attending DConf Online if you were attending DConf Online. If not, come check us out. You can check us out at dlang.org. There's a nice forum in there. If you want to check me out, you can check me out on my own homepage. And with that, I will say goodbye one last time and enjoy the rest of your day.
All right. I hope you guys can hear me. Brian, thanks for the excellent tutorial and for sticking around to answer questions, even though you didn't get a whole lot of them during the viewing. And I want to thank everyone else who watched, who participated in DConf Online. And I think this is going to officially bring us to an end. And it's going to give me an opportunity to go to bed. So everybody have a nice weekend, whatever's left of it. And we'll see you next time. Bye-bye.